Welcome to Data Analytics Full Course by Intellipaat. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. Data analytics is nothing but a science of analyzing raw data to make better business decisions. Data analytics helps in analyzing customer trends and customer satisfaction, which can lead to the creation of new and better services. Data analytics has been adopted in almost all the industries such as travel, hospitality, retail, and many more. These industries collect customer data, figure out where the problems are, and fix them immediately to reduce further damage. Data analytics helps in collecting and analyzing data to identify trends, recommend products, and increase profits. The demand for data analytics skills is going up consistently, yet there is a shortage of skilled data analytics professionals. That is why we at Intellipaat have brought Data Analytics Full Course video to help you learn about data analytics and make a career in it. So in this session, we will be covering everything about data analytics from basics to advanced level, along with hands-on demo and interview preparation. So guys, without any further delay, let's get started.
We've all heard this term somewhere. It pretty much rings a bell that every time we think about it, right? So analytics with respect to data. Well, what are we trying to analyze is what we need to know here, right? So the formal definition of how it goes, it's basically extracting meaningful information from raw data. It's as simple as that. So we have data, right? So consider anything to be data. If that is not useful to you at that point, it is considered as data. But then if you perform some operation on this data and make sure that it is useful for your organization, this is when the data becomes information. And this information is what is usable for you, right? So the process of pretty much converting raw data into information by performing certain analysis on it can be termed as data analytics, guys. I mean, this is just a very rough definition of what goes in the industry. To give you a better insight of what that means, basically it is the pursuit of extracting meaning from raw data using specialized computer systems, guys. And then these systems, they transform, they organize, and they model the data. End of it is to basically draw the conclusions from all of the data. So you'll have, again, as I've mentioned with the raw example, our goal here is to basically draw conclusions, to identify patterns, to make use of this raw information in a better way. I mean, sure, data can just be used in its raw form, but then not with every case, right? And to give you an example, so think of the data, probably you understand. So let's say you're looking at a huge data set which contains thousands of values. Those are just numbers, right? So having these numbers, sure, as a data analyst, you will understand what you're doing. But then let's say you need to explain it to a person who doesn't know what data analytics is, or you need to explain it to someone, probably your peer or someone above you as well. Let's say you have a business meeting where you have to explain this. Giving the numbers will not really be that great, right? It will not make a very good presentation. So converting all of these numerical data, making it into graphs, making it in a way where everyone understands the data, and showing out graphically whatever insights that you can generate from the data, that can be considered as data analytics as well, guys. Again, today basically the field of data analytics is ever so growing rapidly. And why is it growing so rapidly? Well, because the market demand for it is that much. So we have pretty much every startup companies these days have a requirement for big data as well. So big data, to dumb down the definition, it pretty much means a huge amount of data that cannot be handled by just one machine. If you're stretching out your data across multiple nodes, you have data coming in from various sources. Then you need a method to handle all of this big data that's coming in, to process the data and then to perform analysis on it, guys. So this has been in demand in the market for a while, and for the last couple of years, data analytics has been in the boom, and then it's providing a very straight answer to all of the questions being raised about how all these can be handled, guys. And of course, we're going to need the people who have the skills which is needed, skills which are needed to manipulate all the data queries, to translate all these numbers into graphs, and to make insightful analysis on it, right? So that's what is the main key role of a data analytic person. what is the need for data analytics if you have to break it down into 3 steps, guys? So again, we already know that it is on the rise, right? So I can pretty much go about to step out into the open and then tell you that it is not soon that it will be an integral part of an organization. It is already an integral part of every organization there is, guys. So the first important need is, again, we already know that it is a top priority for all of these organizations, ranging from the small organizations all the way to the big guys. And then this is needed to make very good decision making. Well, with respect to you being confused to, let's say, take a decision for you, then looking at this analytics will make your decision making skills and decision taking skills a little bit easier, and it'll be more validable as well, guys. And it'll be more validated as well, guys. And the second thing is to we require new revenue, right? So let's say you have the data which pretty much only a couple of people can make sense of understand. Let's say your market is very niche. In that case, sure, you'll be still making revenue, still be making money on it. But then at the end of the day, if you have to reach out to a broader audience, you need to make sure your data is understood by this broader audience, right? So that forms the second very important need for data analytics, guys. And the third one is to obviously decrease these operation costs for every organization. So this can be a very demanding task if you have to convert raw data into information, process the data, and make out very good visualizations out of it as well. But then if you have the workforce for it, then sure, you can do it. But if not, again, since it's probably a manual task, and until a couple of years ago, it surely was a manual task. And these days you can implement machine learning and data analytics to pretty much automate itself and make your job easier as well. It speeds up your work. It keeps you very efficient in such a way where your data is being visualized, processed very effectively. So again, time is money when it comes to big organizations, right? So on that note, pretty much it helps decrease all of the operational costs with respect to, either waiting in the data pipeline or waiting to process, waiting to publish, waiting to do some analytics, waiting for visualization. All of these waits, you need not consider them anymore because they will pretty much be reduced to null, guys. So on that note, you might be wondering, who are data analysts, right? So data analysts are the people who sit at the end of the chain. I'll just explain the chain in the next slide. So these guys form a very good workforce for the company, where they basically deliver the values by taking in all the data that data scientist might give it to them, a data engineer might give it to them, and then he uses this person, data analyst, uses all of these to answer a couple of questions and then communicate all of the results back. And all these results that he just gives back is basically used to take very good business decisions, guys. It might include analytics of past trends, it may be prediction of what the future looks like, and so much more. And then the common tasks done by data analysts are data cleaning, performing analytics, and then creating visualizations. Well, data cleaning, to come about it, is basically simple, guys. So again, data is raw information, right? To make sense out of it, to pick out information that we only require, and to make sure that, again, efficiency is the game here. If you're pretty much processing data that we pretty much will not require, then it's just a waste of time and resource. So cleaning the data, making sure that your data is just perfect enough for processing, that's a very important first step, guys. So this is the spearhead of a data analyst's role. And then the second one is, obviously, as soon as your data is clean, you need to perform some very good analytics on it and create very good visualizations, guys. So these 4 designations you see on the screen right now is basically the designations a data analyst is also known by. So the first is a business analyst. So data analyst is also a business analyst. He or she can be an operations analyst, a business intelligence analyst, and a database analyst as well, guys. So coming to the tasks that they pretty much do, the first important task that we already spoke about was cleaning and organizing raw unstructured data, right? So this is again a very overlooked concept in today's world, unless you get your hands dirty with the data itself. When you start to go about doing that, you will realize that cleaning and organizing the raw data is extremely important, because at the end of it, your data might be unstructured, your data might be semi-structured, or it might be a structured data. This will not matter if the data you're processing is of no use at the end, guys. So cleaning and organizing raw data is very important. And then the second thing is the analysis of all of the hidden trends found in the data. So making sense of something, again, maybe predictions in the future, or looking at past trends, generating this sort of an information which you cannot figure out upfront just by looking at the data. This is pretty much the umbrella under which the hidden trends function of a data analyst's work. So you'll be looking at a data, you'll find something very interesting. So let's say you find a trend in your data where pretty much you can access a new side of the market with respect to your sales in the next 5 years, 10 years. And then you were not told this, but then your data was telling you this. So you making sense of the data in which this trend was found, which was not upfront, then this is again a very important skill of a data analyst as well, guys. And the third important thing is pretty much the big picture view using descriptive statistics. At the end of it, sure, we know what the past trends of the company are, we know how the company is going on now, but then if you need to just summarize all of this and say even add some predictions for the next 5-10 years, getting this big picture view of what's happened, what's happening now, and what will happen in the future, not just using very simple statistics, but using descriptive statistics where we'll be picking up each aspect of what's going on and then perform analytics on it and find out what's going on. If we are right at this place, if we are wrong at this place, how can this be improved? How can this concept be checked? How can we reach the clients better, and so much more. So getting this big picture view is again a very important task a data analyst goes about doing, guys. And the fourth one is probably the most important thing a data analyst does, is pretty much the creation of dashboards and visualizations, guys. So as I already told you in the introduction part of the video, where we're starting out with raw information, again a lot of numbers, but if you have to show these numbers at a business meeting, numbers are numbers. Some people like them, but a majority of the people who they might not understand the numbers. So making these numbers as your input, creating very good visualizations, giving them a user interface, and giving your customers, your peers, your superiors, your business meeting members, giving them a very good user experience with all of this data. Again, at the end of it will add up to very good business methodologies, and then it will help you take better business driven decisions again. And again, the same goes for presentations of results to your clients and your internals as well, guys. So coming to the chain of how the data moves around in a firm, I have 3 important things that I just want to walk you through, guys, in a quick gist. So the first person who is the spearhead of the data for an organization. By spearhead, I mean he's the first one who look at the data, or he'll be responsible for bringing in all of the data from various sources, guys. So data coming in from the various sources, right? So think about all the data you can get from Twitter, or if you're performing any sentiment analysis, think of all the data that can come from all of the big data sources. You can have data coming from your various nodes from Hadoop, so much more. You can have your data coming from your own network, away from your network, and so much more, guys. So the data engineer is the spearhead who handles bringing in the data and making it understandable by the organization, guys. And then as soon as the data engineer finishes his part with the data moves on to the data scientist. The data scientist, he's responsible for working on all of these raw data, converting it into valid information. But then we already told this for the data analyst as well. Well, the data scientist pretty much uses machine learning algorithms. He uses deep learning. He uses, let's say, binary classifications, naive bias. He makes use of so many concepts here that a data analyst might not know. And he uses a lot of machine learning and deep learning, as I've already mentioned, to convert this raw data into valid information. And 99% of the time, the information which is being converted into are numbers, guys. So after the data scientist pretty much goes about doing his magic onto the data, and then we have the data analyst who steps in. This person, again, as we've already been mentioning, he is responsible for the prediction of what happens in the future, that is finding out trends, and then the presentation of all these informations to your peers, to your clients, to your superiors, and so much more. This is the basic gist of how data moves around. So the data is first seen by the data engineer. He does his job, comes to the data scientist. The data scientist works his magic via all these fancy algorithms and whatnot, and then pushes the data to the data analyst performs predictions, sees trends, visualizes the data, makes it presentable for everyone to understand, and then eventually goes about analyzing the data, guys. So on that note, we can come check out the type of data analytics that can be done in today's business, guys. There are a couple of types of data analytics, and I'll be walking you through the same. So the first type of data analytics you can go about doing is the descriptive analytics. With respect to descriptive analytics, again, the quick one phrase answer to what descriptive analytics is basically picking out data from a source, summarizing your data, making sure your data can be understood by everyone, that is picking out very good insights from your data, from all the past events, doing some predictive analytics on that as well, and then keeping it ready so your data is descriptive at the end of the day. And a question which goes by to understand the descriptive analytics is what happened in my business. So the answer to this question, what happened in my business, is given to by the descriptive analytics, guys. So most of the time the data which is generated by descriptive analytics is very comprehensive, it is extremely accurate, and the visualizations are very effective as well. So here's a very simple scenario that you guys can consider. So consider a scenario where an e-learning website decides to focus on a trending course according to the analytics of the search volume of the course content, which pretty much the users go on searching, and all of the revenue generated by the course in the past few months as well. So there are certain technologies, again, we live in a world full of trends, right? So let's say data science is in the boom right now. So pretty much any e-learning company, or any company for that matter, they're going to find these trends. They're going to know that, hey, data science is sitting in the top tier and we need to do something about it. If they have students in data science, then most of these companies are aimed at making the students' life better, right? So even as a firm here in Intellipaat, that's exactly what we do as well. We get this amazing insight from all of our learners for any particular course, and we use all of those insights, all of the feedback that we get, and what's trending in the market, what's latest in the market, and we use all of these to perform analytics, and then pretty much all of these helps us to put out a better course as well, guys. So at the end of it, you can already see how the descriptive analysis is already helping our business, right? And then the next type of data analytics we can check out is the diagnostic analytics, guys. So we already checked out what is happening to my business with respect to descriptive analytics. With respect to diagnostic analytics, you will check out of why this particular thing is happening to my business, guys. To simplify it again, it basically gives you the ability to drill down to the root cause of why something is behaving just like how it should, guys. So drilling down the data to identify certain set of problems which are present in your data or in the trends that the data shows is a very vital part of diagnostic analytics, guys. And then it basically helps in answering the question for us about why the issue has occurred, So it just takes one look towards the data, towards the analytic result of the data, to understand what the cause behind a problem, if one should exist, as guys. So again, to give you a very simple scenario of how diagnostic analytics would work, let's say consider a company where the sales went down for a month. So let's say they weren't doing as good as the previous months. So to diagnose this particular problem, you will let's say consider the situation where the number of employees were quitting their job and they weren't bringing in a lot of sales. So this could pretty much, this number of people quitting the company could directly impact the sales that they brought into the company. So the sales went down this month because they did not have the company right. They did not have the sales right. So finding out why this is happening and hunting for that root cause, which is basically a treasure hunt with your data, where you go on finding something and taking insights from your data. Finding out that why part of it is extremely important, where you'll be finding out what's happening to the data and why it's behaving this way, guys. So this again is a very vital part of diagnostic analytics. And coming to the third type of data analytics, it is predictive data analytics, guys. And as the name suggests, the quick question you'll be asking is what will happen in the future based on the past trends, guys. So hunting out historical patterns that are being used to basically predict all these specific outcomes using let's say machine learning algorithms, using deep learning, and using so many more concepts to predict something in the future based on the data we have now is again a very important niche of data analytics, guys. So predicting the future trends and the possibilities in the market based on the current trends is self-explanatory. And then it helps in optimizing all of the business plans for the future, because now your business has a direction to head to, right? So you're predicting certain aspects in the future and you know which path leads to better business strategies, right? And this will give you an edge over all of the other businesses as well. To give you a very nice example, think of the Netflix recommendation systems, guys. So this will basically use statistical modeling to analyze all the content that it's being watched by the audience across the world. So let's say there are a couple of TV shows which are very famous in India, but then there might be a couple of TV shows which is trending in the United States, and let's say Australia, United Kingdom, so much more. Making sure that the right users in the right geographical area get to know the right recommendations are extremely important for Netflix as a business, right? So this again, predictive analytics will just do them good there, guys. Again, it will provide us with the prediction of all of the upcoming content and the shows that must be watched by all the different class of audience as well. So let's say someone sitting in the United States is very interested in watching an Indian trending television series as well. So knowing Netflix, finding out that this person exists and to recommend an Indian TV show for this person sitting in the United States to watch. Again, this is another very good business opportunity for Netflix. And then if they go about nailing their recommendation system for everyone, it just makes them a better business model, and then it just makes a better user environment for the users to go about watching videos there, guys. So the next type of data analytics is prescriptive data analytics. So as soon as we think of a prescription, again, we think of a doctor, we think of something, a medical appointment or something, right? Here it's again something similar. The question which will be asked here is what should be done? So applying advanced analytical algorithms to ensure that you make very good recommendations, you make sure you're punching out very good strategies that help the business, and so much more is a very vital part of prescriptive analytics, guys. So it basically involves breaking down all of this complex information into a very simple set of steps. And these steps are like the prescription we handed out when we visit the doctor, right? And these are the prescriptions which are precautious as well, let's say. They're the precautions basically used to remove any of the future problems that might occur, and it will also help in performing predictive analysis. This will basically help to predict outcome, and eventually that will help us optimizing business as well, guys. So this again demands the use of artificial intelligence and big data, and then the data analyst person will always be in touch with the data engineer as well and the data scientist as well, because he's going to need all the help he can get with respect to artificial intelligence from the data scientist, and help with respect to big data from the data engineer as well, right? So all these three guys working in correlation make up a business, and I've already told you that. So again, to give you a common scenario of how this would happen, consider the prescriptive data analytics that Google Map goes about doing, right? So every day we are commuting from our office to our homes, or let's say we're going on a vacation and then we need to get out of the city as quick as possible. So Google Maps has a wonderful API where they map out the best possible route considering live traffic conditions, weather conditions, road closures, and so much more. It considers your distance, traffic constraints, and again, as I already told you, it even considers if it's raining, if you're walking, what's the best route that you can take to walk, what's the best route to take if you're in a car. And now they've come up with the bike route as well. So if you're in a moped or a bike, you can take a different route compared to the person who'd commute with the car, and so much more. So knowing this kind of a prediction into the future, and giving you the sort of a prescription to ensure you don't run into any problems along the way is a very important part of prescriptive data analytics, guys. So on that note, let's quickly check out what the life cycle of data analytics is like. So the data analytics lifestyle, it basically defines the analytics process and all of the best practices which goes on from the discovery of the data or the project till the completion of this project, guys. So there are a couple of steps involved in this life cycle process, and the first one is business understanding. At the end of it, again, understanding the purpose and all of the requirements that come from your business, and understanding it from the business viewpoint is very important and vital for the functioning of a business, right? This also consists of a very good introductory plan. It consists of a decision plan. It consists of a formal to-do list, let's say, for the business to go on to achieving the target. So the first important thing about the life cycle is the understanding of what's going on around you, and the second one is the data understanding, guys. With respect to data understanding, again, this mainly involves the process where we're collecting the data and we're processing the data in a way which leads to analytics. And then after the analysis of the data is done, we need to pick up some insights that we can go about using from the data. So extracting all of these meaningful insights from the data, again, is a very vital step in the life cycle of data analytics through data understanding, guys. The third part of it is data preparation. So data preparation is the let's say, converting the data from an unstructured form to a structured form, and this involves constructing, let's say, a data set as well. And then this data set will be provided and fed into a model, and then this model will be used by a machine learning algorithm to train, to understand, to see what's going on, to perform predictions, and then it will be given to the data analyst to be visualized using Tableau or any other business intelligence tools, and so much more. So data preparation, again, is a very important phase where the data is actually being transformed, and even at the stage the cleansing of the data is pretty much performed as well, guys. And then comes modeling. This step is very important because it involves the selection of various modeling techniques, applying all of these modeling techniques, making sure the parameters are right and all of the readings here are right to ensure that your data being converted into the information, raw data being converted into the information is of the optimal, let's say, it's of the optimal tolerance that can be used for your business usage. And then as soon as your modeling part of it is done, as soon as the techniques are applied and all the parameters are marked, then comes evaluation, guys. So evaluation is a very important phase where, again, the model which is being built, it will be built very rigorously, tested very rigorously based on what you've built in the initial stages, and then so many tests will be performed on this data as well. So evaluating something that you have generated, performing various tests on it, is extremely important. Most of the time this is overlooked, but then these days everyone knows the value of evaluating your data, guys. So this again involves reviewing all of the steps that are, again, needed to carry out to construct this particular model and to perform tests on it is very important. And with evaluation, that's exactly what we do, guys. So the next life cycle concept I want to tell you guys is deployment. Deployment is the last step in the data analytics life cycle, because deploying is when you're sending out your model into the world, for, let's say, by the world I mean, let's say, for your team, for your peers, or let's say even for your client and customers as well. So making your data go from just you seeing it all the way till spreading the data and performing spreading the data to your clients, to your peers, or anyone else. If you can perform more tests on these as well. So after deployment, you can have after deployment tests. If something is wrong, again, you can go back to modeling, perform more evaluation, perform more deployment as well. So the thing you need to know here is that deployment pretty much goes about to be the final phase of the data analytics lifestyle, guys. And on that note, we can check out very quickly what are the roles of analytics in various industries around us, guys. Again, data analytics has an amazing insight and impact when it comes to the telecom industry, because, again, if you've been observing, all the prices of let's say the calls, the messages, or the internet packs these days have been coming down and down, and there was a time when they were being exorbitantly high as well. So again, the telecom industry realized that if you keep the prices very high to make more profits, then eventually your customers will not come. They will not buy the internet packs. So to keep this in mind, probably they decided, let's say we're having a bad impact right now, so let's drop down our prices to see if it works. And it is, I guess. And this has helped the telecom industry in bringing better business. And for us as users, this has helped us just make it a bit economical and efficient on our side with respect to money as well. And then the retail banking industry, data analytics has a huge impact in the retail banking industry as well, to know what their customer wants, because again, with telecom industry as well, they have a huge amount of customers to play with, right? So they need to understand the view of each customer, the requirement of each customers, and then to find out if all of the customers are actually in the common chain of what's being supplied by the bank, or if the customers are against something that's being sent by the bank. So
Test your knowledge of data analytics by answering this question. Which of the following is not a major data analysis approaches? A. Data mining. B. Predictive intelligence. C. Business intelligence. D. Text analytics. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
That again is a very important thing that you need to check here as well. And then with respect to the e-commerce industry as well, to perform again some analytics in the e-commerce industry, it might be ad recommendations, or there are very big sales which are run by some of the big names in the industry such as Amazon, Flipkart, Myntra, and so much more. So these guys will have to perform extremely heavy analytics on the data that they see based on the products that they sell, and based on the places, based on the city in which the product sells, or if the people are unhappy with the price. Again, performing analytics has just changed the e-commerce industry, if you may, guys. And the last most important industry where data analytics has touched is the healthcare industry. This has had the most impact with respect to analytics in the healthcare industry with respect to so many things. Mainly it is with respect to finding out what medication is required by what countries, what amount of medication is working for what population, and so much more, guys. I can probably talk about just the roles of analytics in these industries for days together, and we can still be going on and have a very good discussion of how important analytics has become these days. Again, with respect to insurance as well, what geographical location requires insurance, what the audience are, and so much more. So again, as I've said, we can go on talking about this, but then to keep it to the scope of this tutorial, we can just quickly brief through each of these guys. So with respect to the healthcare industry, this is the formal way of going about analytics. The first one is to again analyze all of these disease patterns, analyze all of the disease outbreak that pretty much goes out. We had a disease outbreak a couple of years back, which is Ebola, and so much more. We had H1N1 and so much more, right? To keep a track of all of these outbreaks, this basically again improves the surveillance with respect to health, and then this gives out good responses to the emergency sectors as well, guys. And then development of better targeted preventive techniques, obviously, and then with the development of vaccines, making sure your vaccines again reach your customers, and all of these where you need to reach your customers, or let's say in this case the patients are very important, guys. So identifying the consumers again in this is the greatest risk of business. So identifying certain customers or patients who are at the greatest risk is again, because they might be developing some adverse health outcomes, and then developing welfare programs to keep a track of their health, to track their health on a daily basis, even a weekly basis, monthly basis, to perform analytics on all of the aspects and the parameters that you're tracking with respect to the patients. Again, that is a very important thing. And lastly, to ensure that they can reduce readmissions, because they might know what the cause of an adverse effect is. And if there are 10 patients with very similar symptoms, then you can perform analysis, and you can at least filter out and find out that all of these 10 patients might have this one common symptom associated with them, and this might be the cause of that. So mapping that for every patient is again very important, guys. So coming to the telecom industry, again, telecom industry pretty much goes about using predictive analysis to gain all of the insights that they need to make better decisions, to make faster decisions, and to make more effective decisions. Again, as I was talking about the internet pack example, again, this was very key in that. And then by learning more and more about their customers daily, and the preferences and the needs, these telecom companies can be more successful in this extremely highly competitive industry as well. It's good for them with respect to business, and it is good for us as customers by bringing down the prices again. So it is used for analytical customer relationship management, it is used for fraud reduction, it is used for bad debt reduction, it's used for price optimization, call center optimization, and so much more. So now that you're looking at data analytics in this way, you realize that data analytics eventually has a big play, or has a big say when it comes to any of these business models, right? So again, coming to banking, as I've already mentioned, analytics is making banks become very smart day by day, guys. So it is managing all of the plethora of challenges that the bank faces, and then again, while pretty much going about doing some basic reporting all the way till descriptive analytics, and this is all a must for every single bank, right? Even performing, let's say, advanced prescriptive analytics or so much more, and all these are starting at this age. Banks have started to realize that this will again help you generate very good insights, and this will result in extremely good business impact, and it will help the banks as well. On that note, we need to check out how data analytics is helping in the banking industry as well, right? So it is used to acquire and retain customers. It is used to detect fraud, which is again extremely important with respect to banking. It is used to improve risk control, find new sources of growth for the bank, and to optimize all of the product and generate their portfolio models as well. So as soon as we check out the banking sector again with the e-commerce industry, right? So this is a market which is exploding for the last couple of years. I can say even the decade, right? eBay came up, Flipkart came up, Amazon is again taking over everything, Myntra, Nika. Guys, there are so many e-commerce portals today, and to make sure we perform very good analytics on these e-commerce industries is very vital. So how is data analytics used? Again, it is used to improve user experiences. It is used to enhance customer engagement, customize offers and promotions, maintain effective supply chain management, optimize pricing models, minimize the risk of frauds, provide them very good advertisements that pretty much help them pick up products, good recommendation systems where they'll pick up another product after the first product, guys, and so much more. If you've just bought an iPhone, again, you will pretty much be recommended with a couple of cases that the people have bought as soon as they bought another iPhone. So you might be that person, you might like the case and you might pick it up. At the end of it, you have the case to protect your phone. The business just created more money out of it, right? So again, the analytics, the role of analytics in e-commerce industry is extremely vital. Let's say the people in the e-commerce industry have known this for a while, guys. So coming to the analytics in the insurance industry, again here as well, guys, this is basically used to enhance your customer engagement, acquire new customers, retain the existing customers, make sure the customers don't leave, prevent the frauds, at the end of it reduce the frauds, prioritize all the claims that need, because you'll have medical insurance, you'll have again health insurances, you'll have life insurance, you'll have so much more that you need to take, and all of these directly impact the user, right? So making sure you take the feedback from the user, work on it, and then create some analytics out of it is again very vital, guys.
You might have heard of this, let's say, terms like data science, machine learning, AI, right? Multiple things that you've heard of, right? Just think of data science, that let's say any kind of a science which is applied to data. Yes, as simple. Any kind of a science which is applied on data, right? Which can generate insights to you. There's a small clause there which says that it should generate some insights for you. That is called as data science. Now, data science is not, let's say, like 2015 or 2010, let's say something, right? Data sciences have been for years, for ages, right? It can be as simple as a question. Let's say if your CEO or let's say your CFO is asking you that which of our products are doing very good. So what you'll do is you'll go globally, you'll collect all your sales data, you'll let's say aggregate them, and then you'll put them into country wise, and then you'll do a, let's say, cut on group by on your product level, and then you'll say, okay, my product P2 is doing very awesome. This is the smallest, or let's say the simplest form of data science, right? Data science does not always mean that you're applying some heavy mathematics and statistics. Obviously, yes, but it can go as small as this term, right? Something which creates insights from your data. That is called as data sciences, right? Now, this thing can be as simple as what I said, and it can be as complex as this. It can be as complex as a level 3 self-driving car. All of you might have heard this name of Elon Musk and his very ambitious electric car manufacturing company, Tesla, right? Model S, Model E, Model X, and Model Y, right? And now they're releasing their Cybertruck also there. All of them today, except I think S, doesn't have level 3 automation skills. It means you can leave the steering and the car will navigate on its own on a selected path of areas. It works. Yes, and it's not just Tesla, right? Do Google for something called as Waymo, W-A-Y-M-O. Waymo is a self-driving division of Google. Google itself is making, and Google is so confident in its driving skills that they have started doing now something called as Waymo taxis. It means you order a cab, a Waymo cab will come in front of you with no driver. You will sit inside it and the car will drive on its own, obviously in selected areas for today. No driver required. On Tesla, you still, let's say, need to put your hand after a certain time on the steering just to make sure that you are aware about the context, what is going on. But in Waymo cabs, you don't even need to do that, right? Leave it alone and it can go apart. You have heard about this Siri, Cortana, Amazon Alexa, how intelligent these are these days, right? the third, I mean, a little bit more context I'll give you here. Those people who are from technical background and they are doing, let's say, coding, right? I'll just give you a very small example. Almost 2 weeks ago, exactly 2 weeks ago, right? GitHub launched a project called as GitHub Codeplex. GitHub Codeplex. It means that you just write down the doc string that I want a function which can add two numbers. You just write this down, and the Codeplex can generate code for you in your desired language. Yes, it can generate code for you. So that's the level of automation that we have gone, right? And I'm talking about, let's say, some fancy things here, but obviously we have done some very interesting, let's say, impactful work here, right? COVID was hit, right? Multiple companies did a forecasting model of how COVID will hit their sales, and they could, let's say, make sure that their supply chain and their supply demand cycle is always in sync, right? A lot of these medical companies, the pharmaceutical companies now, earlier they had to manually do simulations, but now with these agents they can do this all alone, right? We have a domain called as reinforcement learning, where the model can learn itself. The model can learn itself how to prepare for let's say a game, right? There's this a very wonderful reinforcement learning algorithm called as AlphaGo, and it is played majorly in Southeast Asia, in Japan, Korea. Lee Sedol is a world champion, four-time world champion, and he's a winner, obviously. Now, Google made this reinforcement learning called as AlphaGo. They showed AlphaGo multiple videos of Lee Sedol and other people that how they're playing the game, and they challenged Lee Sedol that would you like to have a game with this bot? They had a 5 series game, and the bot won 4 times, 4 out of 5 times. A world champion lost 4 times out of 5 in front of it. If you think on airport, if you see 100 people, not all of them are employed there, right? Almost 60% of them are, let's say, on contract basis, and they're called based on something called as workforce management. So these airlines companies, they don't, let's say, hire people full time every day. What they do is they bring them on contract and on work basis. So what they do is 2 day or 3 day prior, based on their schedule and based on the holiday and based on the how much tickets that they sold, they try to bring in these people, additional people. This is called as workforce management, and it is totally handled by data sciences, right? Totally handled. One more example of, I don't know if this fits in aerospace or not. Drones, swarm drones today are one of the biggest examples. Today, the biggest problem with drone is that there is somebody who's controlling that drone, right? There's a remote that a manual person has to see and then remove that drone, right? With reinforcement learning, you can simulate a pilot also, right? So the drone can take its own decision like a self-driving car, and a self-driving drone can also be deployed there, right? Okay, so this is a one of the examples that how much, let's say, money they have saved, right? And with this example, right, obviously this is a great example. I just want to tell you that why data science is so prevalent right now. I think this is the biggest question that comes to people's mind, that people are saying that, Shivam, you just said that data science is not new. Data science is very old. So why is it that we are hearing about this? Why is the drum rolling happening right now? Right? Why is it that it was not 20 years ago, 30 years ago? The problem is data science requires two things. One is the data itself, and the second is the computing power to process this much amount of data. Till 10 years ago, we did not have, let's say, this much amount of storage, or let's say the capacity to keep this much of data. And we did not even have, let's say, the processing powers to process this amount of data. But today, if you see, right, your small hand, your mobile phones, they have almost half terabyte of spaces in them, right? An average phone can have half terabyte of space on just a phone. So just think about how much have we scaled at a data center level. And again, on the same part, on the computational also, right? GPUs, the word GPU you would only hear this, let's say, word only from people who would, let's say, either do the video rendering job or they were into gaming. These two only people had these, let's say, GPUs. Today, GPU is available in every other laptop also. And people are using these extra GPUs to run analytically more fast, to make things more fast in analytics, right? With this airlines, let's say example only, I'll give you a very small example. If you, there's a statistics which says if let's say a plane is flying from London to New York, right? It generates, one single flight generates 1 terabyte of data. 1 terabyte of data. And you might think that's impossible. How can it this be? I'll give you one more simple example to you. Whenever you go to any e-commerce website, let's say Amazon, right? When you go to amazon.com and you buy something, they record each and every step of yours. When did you click? What did you click? Let's say if you're buying a product, let's say P, how many other products did you sort before buying this product, right? Some people, they put the product into the cart and then they buy it later. They record everything, and this thing is called as click stream data. Click stream data, it means they record everything that you write down, everything, every click that you do, right? With the timestamp, they're recording everything. So in the flight also, when the flight is taking, let's say when the flight is flying in the air, right, they record everything. Just think about these metrics, right? The humidity, temperature, the flight altitude, the wind speed, the RPMs of the motor, right? I can just think about this very basic things. Just think about this, how complex this airplane is, and then it's recording everything. So it generates 1 terabyte of data, right? I'll give you one more example. I'll give you one more very simple example is that when I was working for this railroad company in US, right? They had, let's say, their coal mines in Alaska, and they used to ship those coal in the rail cars, and they would bring it into US. They would bring it into Dallas and some other places. Now the problem is in US, everything goes through a sanity check and they do a lot of scrutiny. So from Alaska, whenever the train would come, right, they would manually stop every rail car and they would manually check this thing. So I'll just give you an example. Let's say, I hope you can see what I'm drawing on my screen right now. So let's take an example that this is the rail car, right? This is one of the cars and the engine is in front, right? Let's say this is the car and this is, let's say, filled with coal. Now this car is called as box car. This car is this container, or people call it container, but in logistic company they call it as car. So this box car, they will fill this with coal and they'll put a, let's say, top shield over there. Now there are multiple things that needs to be checked manually. Like let's say there's a door at the back, right? They need to check the door. Then they need to check the nozzle. If the nozzle is 2 inches down that closing tap or not. Then there is the air compressor here, which is there, right? You check the rim nodes here. So for every car, they would check this manually. Now just imagine a train, if it is going, and let's say if it has 50 cars, and on one car, if they're spending, let's say 2 or 3 minutes, they're wasting 150 minutes just at one major station. And from Alaska till the destination, they would have around 7 to 8 major, let's say, inspection areas, right? So just imagine the amount of hours that you will be wasting. So what we did is we did a very simple thing, right? We made, let's say, an oval shaped cart like this around, from which the train would pass, right? A very big oval kind of thing. And it contained 8 high-speed action cameras. 8 high-speed action cameras which are mounted there. They would take the picture of that car, right? And they would first of all decide what kind of a car it is, and then second, is the defect there or not? If the defect was there, the station master would get, let's say on an iPad, they would get the notification that yes, there's a flaw, and they would stop this car on the next station. And if there was no flaw, the car would run at the same speed.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customers says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also the course material is structured in such a way that it covers all the basic till the advanced level of concept, that even a non-computer science background student can easily understand the concept.
Now, let's continue with the session.
No stopping. You earned 150 minutes per car per station per day. And now they could flow in, let's say, multiple rail cars. I mean, they could flow in multiple cars there, and we increase the process. In data science, that's the best thing, right? That you can measure the impact in the amount of either money, or let's say in terms of the time saved that you've done, right? Okay, these are some other, let's say, stories how UPS, how let's say Southwest and other these people, let's say they saved the money. These are all public available stories, but I'm telling you about my personal engagements that I did with these people, and we saved the money for them. And these are companies which are like Fortune 50 companies, which are very resistive towards changes that they bring in. So just imagine if there's a tier 2 company or tier 3 company, they would happily come and ask you to apply analytics there. Correct? Now, what should be my, let's say, skills there? So I'll give you that view. If you want to become a data scientist, right, there are multiple levels, and we'll talk about them slowly one by one, right? If you want to become a data analyst, if you want to become a data engineer, a data scientist, and a machine learning engineer, and then a deep learning engineer. So these are, let's say, ladders that you have, right? So if let's say you want to become a data analyst, right, the first and the foremost thing is that you require one, programming language, in which you can work upon, right? It can be Python, it can be R, or it can be any other non-coding platform also. Today in this world where we are right now, there are so many non-coding platforms also available there where you can do all these stuff, right? So one is you require one programming language, then you require some kind of statistical learning also, right? Statistical and mathematical learning. Why? Because you have to implement those knowledge there. Now you would say that, Shivam, I have never done this mathematics ever. I have never done statistics in my life. I have never done mathematics. So should I leave the field? And the answer is no. See, even if today I know mathematics, I am not on my day-to-day life, I am writing maths. Don't think that I am opening up a sheet and I am doing, let's say, some matrix multiplication or some differential equations. No, there are people who have done all these things for you, and they have made libraries. These big tech companies like Google had has a framework called as TensorFlow. Facebook has a framework called as PyTorch. Microsoft has a framework called as CNTK. Amazon has something called as MXNet. So all these big tech firms, they have already made the industry standard frameworks there, which will do the mathematics in the background for you. You as a data scientist do not need to do the mathematics in the background, but still mathematics is required. Why? Because you have to understand what is happening in the background. It should not become a black box for you. So that is why when we study data science, right, we say that we'll do it in two phases. In the first phase, you'll understand that how things are happening in the background. And the second phase, you'll understand what you will do in your real life, right? Because in real life, you won't be doing the mathematics. Then second phase, then we learn that, okay, see, now you have done all the heavy lifting on your own. Now see, in the real world, you don't need to do all these things. This can be done by just 3 lines of code, right? And then there's a third most. So first I said, let's say, one programming language. Second, I said, if it is, let's say, it's optional. I mean, it's good to have statistics and mathematics. And the third thing is, my friend, problem solving attitude. That's the most important thing that data scientists require. See, a data scientist is not a regular software engineer where you give him a task and you do it. No, you will get very vague problems where, let's say, the CEO will come to you and say, hey friend, hey data scientist, listen to me, that our revenues are going down. Can you find out why? That's it. They will never say to you that, this is the code, please go and write this down. No, 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 no. So you need to have a problem solving attitude here, right? And to solve a problem, you need to understand the problem. So that is why domain is also required a little bit. Now, what is a domain? Domain is nothing. And see, domain is, let's say, not a big problem, because in whatever industry you'll go, you learn the domain, and everybody has to learn. If it's a software engineer, or if it's an architect, or if it's a UX, or it's a product manager, everybody has to learn the let's say, the domain knowledge about it. So that's the last part, domain, that you need to learn, right? Okay. Now this slide tells you about that, who are data scientists, what their day-to-day job is divided into. So I was telling you, right, data science is machine learning, deep learning, and then pattern recognition is the fourth kind of, let's say, division there. I'll do a much more simpler division for you, right? A very simple division for you. And I'll do a much more simpler, let's say, division for you. The first division that you will hear is something called as data analyst. Data analyst. Where's my pen? Right? Data analyst. Who is a data analyst? See, data analyst is more close to data sciences, right? I told you, right, that if you do any kind of, let's say, analysis, if you on the data, which can give insights to you, that is called as data analyst. Now, the primary skill of data scientist is to pull the data. So that guy should know SQL, right? Second thing is, he needs to learn how to crunch the data, how to, let's say, massage the data, and how to get insight out of it. So he or she needs to learn, let's say, any one anyone, let's say either R or Python, or let's say any one like a non-coding tool if you want, like Alteryx or K9 kind of tool. And then at the last, to show their results, to demonstrate their results, they want one dashboarding thing, right? Which is either Tableau, you can use Tableau, or you can use Microsoft's Power BI. So it's a three-step process. First of all, pull the data, or pulling the data, you need SQL. Then crunching and massaging your data, you need R, Python, or any no-code thing like Alteryx. And then to show the results, you need Tableau or Power BI, correct? The second terminology that you will, let's say, listen is something called as data scientist, decision scientist, or machine learning. This person's job is not just limited to, let's say, finding insights, but trying to predict the next value. Till data sciences, what in data analyst, what was the data analyst doing? Data analyst was just finding insights from it. Now this guy is not just finding insights, but it is also predicting or forecasting things, right? So this guy should obviously know SQL. SQL is a no-brainer. And then one programming language, obviously R or Python, any of the choice. Then this guy should know machine learning algorithms, right? And this is optional. It means deployment, how to deploy these models. This is optional, correct? And then the last one that you will hear is, this is called as deep learning engineer. Now what is deep learning? See, in data science, data analytics, what you were doing, you had, let's say, data, and you were trying to find insights. In machine learning, what you are doing, you are saying that I will not just find insights, rather I will also try to predict or forecast the future. But this is majorly on tabular data. Tabular data means the data which is present in rows and columns, or which is present in your Excel files, in your SQL files, or that you have, let's say, dumped either from a databases, right? Those things are called as tabular data. But we have other kind of data also in the world, which is called as cognitive data. Cognitive data means that for your eyes, you have cognition, that you have images, you have videos, right? And then you have text, and then you have speech. These four are the major, let's say, areas, text and speech, where you can try to predict, or let's say find the correct answer. So you might have heard of something called as, let's say, facial recognition. It means if you go in front of the camera, it will identify who you are, what is your current age, what is your emotion right now from that page. How is it all happening? It is happening through deep learning. Now deep learning says that deep learning works exactly in the same way how brain works. So scientists, what they've done is they have studied the brain, and they say that how does our brain replicate, how does our brain reacts, will replicate the same case for humans. So, right, you can think of, let's say, auto featured deep learning model as something like how a kid learns, right? How a small kid learns, right? Based on the experiences and by doing and learning heuristically, the same way data sciences also learns. Deep learning also learns, correct? Okay, why data science is a very good question. Why? I think these are three factors which says in demand, job abundance, and highly paid. I would agree, highly paid, yes. With your peers who are doing front end or back end, obviously you will be paid more in the industry. Job abundance and demand. In demand, again, I will agree, right? Because see, with COVID, what has happened is everybody is looking for digital solutions. Every business owner after COVID saw that we cannot stay locally and offline. We need to come online, right? We need to come online, and we need to pursue our customers. And with data comes analytics. And as soon as analytics come, there comes the position of data analytics, right? So I think with COVID, a lot of new opportunities have come up because of just COVID, right? Why data science? See, I will give you a very simple answer. Because when you are solving data science, right, you're not just no more a coder there. You have become one of the product, let's say, responsible guy. Because see, every decision of product, whether to place this button here or not, this also can be decided by analytics, right? What they're doing is they're trying to understand from your patterns, right? Let's say when the button was at this particular position, this guy was not coming to the home page, but if the button is shifted here, they're coming to home page. So these kinds of, let's say, analysis can be done through data sciences. And now data sciences, you're not a part of just a small software engineer who was given the work in the morning and now he's expected to complete. No, data scientist is somebody who will sit with the business owners and will try to solve the problem. Correct? Okay, let's come to roles and responsibilities, right? I think, as I have already told you, right, that you will be given a very vague problem. You will be not given a very clear statement that you have to build this or build that. No, they will give you a problem and you have to come up with the solution, and also you have to come up with the most optimized solution, right? First is this. Second thing is to apply your analytical knowledge and, let's say, generate insights from this particular data. Correct? And then the next thing is, let's say, if you have done all the things, right, then you need to communicate your results also. I mean, see, the model that is prepared, right, if it stays with you only, then it is of no use, right? So yes, I was saying about communication, right, that if you have made something, it is your responsibility and it is your job to communicate it well also, right? So for communication, I think it's CP. You cannot explain machine learning to your senior vice president, or you cannot explain it to your CEO or CFO, right? But what you can do is you can take one step back and you can make your answers non-analytically answers there, so that they can understand, right? So I think, as we have already discussed, this is the second part. I'm just answering some of my friends. Okay, so I think this is the skill section that I think we have already discussed, that you need one programming language, right, which can be R and Python. Then you require a SQL learning. Then you require probability learning and statistical things, in which you can, let's say, have your small statistical tests and small mathematical tests also there. And in the end, you have your machine learning algorithms, right? See here, the linear algebra, the data intuition, and the data warehousing. I'll explain you one by one. So linear algebra will be used for your mathematics, from your mathematics field, right? Linear algebra. And when I say linear algebra, I don't mean something complex. I mean as simple as this, that y is equal to 3x plus 7. Can you plot this line? Or if somebody says to you that 3x plus 4y is equal to, let's say, 7. So if tomorrow somebody gives you one more equation, 7x plus 12y, sorry, 8y is equal to 14. Okay, this is what I was referring to earlier also, before this page came up. This is the number one skill that you want: one programming language, right? Then data visualization through Power BI or Tableau. Then you have data nurturing and statistics, data wrangling. And then what I'll do is I'll keep this data science apart, sorry, this machine learning, software engineering, and then this multivariate thing. Okay, see here. So we talked about this first one, programming language, either Python, either R, whichever is your favorite. Next is any visualization, which is either Power BI or Tableau, whichever is your favorite. Next is data imputation. This should not be, let's say, a separate part. They should come under machine learning only. Statistics is obvious. Statistics, data wrangling, and data intuition can let's say own right thing there. I'll try to combine these two terms. And this one is machine learning. Obviously, machine learning means the information about algorithms which will be used. So I will say algorithms. Okay. Then you have software engineering. Software engineering is not always required for every role, but for some roles it is required. Okay, right? Average salary. This is for your US and your India. You can see here. Junior data scientist, senior data scientist, they are saying 10 LPA and 20 LPA. This is what they're referring to, right?
Just a quick info, guys. Test your knowledge of data analytics by answering this question. A graph that uses vertical bars to represent data is called as A. Line graph, B. Bar graph, C. Scatter plot, D. Vertical graph. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So what is R? So R is a language developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, R should be a go-to language. Now R is also a great visualization tool. So R provides packages such as ggplot2 and plotly so that you can create stunning visualizations. Now, R is an open source, cross-platform compatible software. So it's just plug and play. All you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can actually run the same R code on different operating systems. And the best thing about R is it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that's amazing, isn't it? And this is what makes R such a powerful tool. So you can do various operations such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with the help of this super language called as R. So now that we know what exactly is R, let's go ahead and install R and RStudio in our systems. So we can install R from the site over here. So we can go to cran.rproject.org. Right, so we have different versions of R. So if you are using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. Similarly, if you're using a Windows system, you can download R for Windows. And since I'm using a Windows system, I'll click on this link. Right, so you see this link over here, install R for the first time, click over here. Now this is the latest version of R 3.5.1. So you have to click on it and then the download would start. Now since I've already downloaded R in my system, I'll go ahead and cancel this. Right, now after you install R, you would also require an IDE so that you can perform your tasks quite easily. So one such IDE is RStudio. So RStudio is a free open source software which provides a smooth interface so that you can perform all of your operations quite easily. And you can download RStudio from this site over here, rstudio.com. So let's go to rstudio.com and download RStudio. Right, so we have entered the site. I'll click over here, download RStudio. And we see the free version over here, RStudio Desktop Open Source License. Again, I'll click on download and you see different versions of R. So again, if you're using a Windows system, this is the right link for you. If you're using a Mac system, you can download RStudio for Mac. Similarly, if you're using a Ubuntu or a Fedora system, you can download these versions. And again, since I'm using a Windows system, I'll click on this link. Right, the download has again started. And since again, I already have RStudio installed on my system, I will cancel this.
Make sure you open RStudio. There are two different softwares that you've installed. There's R and then there's RStudio. Like once all of you open up your RStudio, you see 4 different panes on your screen, right? Like I do. Is everyone able to see the four different windows? I'll also tell you what's the difference between the two. Right. So see, guys, R is basically the programming platform. So you can also code on the base R program, right, which you've installed. It's just that the user experience of coding on it is not great. So it's like a command line sort of an interface, okay, on which you will code, right, and you will not like you can't really save the output. You cannot export the output. So there are certain limitations, right, when you code on it. So what we've done here is that R has created an IDE, right? They've created an interface, a user interface, right, for you, which makes coding and consuming output and looking at error logs, etc., very, very easy for someone, right? So for example, if you've done Python, right, then think of RStudio as a pie chart or a spider, right, which is an IDE that basically makes your experience of coding slightly more efficient, right? And then in one platform itself, you'll be able to build visualizations, you'll be able to look at your visualizations, you'll be able to consume your outputs, you'll be able to export your outputs, you'll be able to look at the files, etc. All of that happens in this whole platform itself, right? So that's the difference between R and RStudio, right? For running RStudio, you would need R to be installed in your machines as well, because R is the base program package, right? Only if you have it available, that's a prerequisite, right? You will have to have it. Only then you can code on RStudio as well. Cool. So that's why we've downloaded 2 different softwares, and all our programming, all our coding will happen on RStudio itself. Okay. if anyone is not able to see 4 different screens on this, like 4 different views on their screen, okay, then what you should do is you should go to view, you should go to panes, and you should tick, like you should make sure that this show all panes is ticked for you. Okay, it is possible that one of the panes are hidden for any of you, but in case, like when you do this, it should get activated. All right. So see, there are 4 different panes that we see, right? Or you can call them 4 different quadrants. The purpose of each of these quadrants is, or each of these panes is different, right? Let's if you divide the screen that you see on your top left corner, it's called the script window. Okay, you can either call it script window or you can call it the source window, right? But let's go ahead with script window itself. Okay, this is called the script window. Okay, the one that you see in the top, bottom left is called the console. Okay, it's called console. The one that you see on your top right is called the environment. Okay, this is the environment window. Okay, the one in the bottom is basically called the plots window. You can call it the plots window. You can also call it the packages window. Okay, the purpose of each of these panes is slightly different. Okay, slightly different. I'll tell you what is it that, like, what is the role of each of these windows here. The script window is basically the window, basically the tab wherein you will write all your programs, right? All the scripts that you will create will be created on the script window itself, right? The script window is that place wherein you will write your scripts, you will write your programs, you will write your codes. I'll show it to you. For example, you don't need to do it, right? Don't jump into programming yet. This is only for demonstration purposes. I just want to show you how you could potentially write a very small script. Okay, I'm just showing you how, like, you can write a particular thing on a particular script on the script window. Let's say I create a variable called new variable, right? I'm just creating something called new underscore var, and then I'm storing its value as 100. Okay, I have to, and then what I want to do is I want to print this. Okay, I want to print new underscore var. Okay, now what you've done so far is that you've written 2 lines of code, right? The first line is when you are trying to create a variable. Okay, create a variable. Okay, and then the second line, what you're trying to do is that you are printing the value of that variable. Correct? Printing the value. Now, so far, you've just written down your code, right? You haven't run it, right? So that's why you don't see any variables getting created. You don't see any outputs getting generated. Okay. So this window is basically that window wherein you can write your programs. Okay. When you want to run these programs, right, what you'll have to do is you'll have to probably select, like if you want to run everything at once, you can select the entire code, and then you can go here. Okay, you can go here. You can find a button called run. Okay, I think this is the button. It will be different for you, right? Just search for something, or like there's a button called run on the top right. Okay, click on that button, and your script will get executed. Okay, so if you see, it says run the current file, and then there's also an option to rerun the previous code region. Okay, so when you've selected something, you can press this button, and it will run the program. Or what you could do, the shortcut of it is Control plus Enter. If you do Control and Enter, then the script gets run. I haven't run it yet, so I'll show you. When I run a script, for example, if I run this script wherein I'm creating a variable, what happens is as soon as I run it, this script, right, goes to the console. It goes to the console, right? So how would you know whether a script has been executed or not? Is when that script starts showing up on your console, right? It means that the script has been executed. Okay, the script has been executed, right? So whenever, like, the script window is that window wherein you will write your programs, you will execute it from there, but only when you press Control plus Enter, right, or you do a run, the script gets transferred to your console, and it means that your code has run. Okay, so far what I've done is that I've created this variable called the new variable. How do I know whether this variable has been created or not? You can see that there's a variable called new underscore var that's created on my environment. Okay, but I just created it yet, right? I haven't like, if I want to know, if I want to print the value, then I can run the next code as well. And when I print it, you'd see the value 100 gets shown on my output window or the console window. Okay, the window on the top, sorry, at the bottom left is called the console window. This window is basically wherein you'll be able to see all your outputs, where you'll be able to see all your executed codes, and the space where you'll also be able to see the logs, right? In the sense that any code that you've written, whether it's generated an output, whether it's generated an error, all of that will show up on your console. Okay. Okay, so this, like, you would know whether a code has done or not only when that code has reached the console. Okay. Now you might say that I can also write my code from console, right? I can also write something in the console as well. You can do that. You can do that, but that's not recommended because you cannot save your codes from the console, right? So, for example, if I write print of print of x, right, and I run it from here, of course it will give me an error because x doesn't exist. But, or let's say if I ever to do print of or let's say if I were to create a variable x is equal to 500, right, it would run, but this code doesn't get saved now, right? I can't, let's say I want to save this code for a future iteration, and that's not possible, right? It's only a one time sort of an execution that you're doing, right? The ideal way of doing things is that you write your code in the script window, and then you can also save it, right? For example, if I want to save this line of code, right, I can save it. I could and save it wherever I want. I could just call it test script, and then I can save it, let's say, in a folder called codes and data. Okay, so it's always recommended that you write your codes on the script window and don't write it directly on the console window, right? Because it's not replicable, it's not repetitive. That's not the ideal way of building programs. Okay. So I hope the script window is clear, the console window is clear, right? What we do on the script and what happens on the console. We will now move on to the environment window. Okay, the environment window is that window wherein you'll be able to see all the objects that you created. It could include variables, it could include data frames, it could include any new functions that you created, anything that you have created and it did not exist originally in RStudio will show up in your environment. Okay, so any new variables, any local variables that you've created, or any new functions that you've created, any user-defined functions that you create will also show up in the environment itself. Okay, so environment is that space where you'll be able to see if you created a variable, if you imported a data set from, let's say, a local file, if you've created a data frame, right, a data object, then it will also show up in the environment itself. Okay. There are a couple of other tabs as well, right, which are not very frequently used, but let's say if you want to refer to the history of your code, right, you can come here, and if you want to transfer it to the console or transfer it to the source, you have the option to do that, right? So you can look at any code that you've written and executed in the console will also be present in the history, and then you have the option to, let's say if you cleared your console or if you cleared your script, you can still retain your code from the history. Okay, and you can send it to either console or source. Connections is basically if you basically set up a connection with, let's say, an SQL database. You created an ODBC connection, right? That will show up here. We will not cover creating connections, etc., importing data directly from SQL. We will not do all of that. But in case that's a use case that you encounter, you can do it from the connections tab. Tutorial is basically for you to just learn different things, right? So if you want to learn more about RStudio, you can come to tutorial. Okay, so that's about script, console, and environment. The final window, and it's actually a very important window as well, it's called the plots or the packages window. The plots and the packages window. This is that window wherein there are different tabs here, by the way, right? So we'll talk about each of these tabs one after the other. The files tab is basically the tab that will tell you, it will give you a preview of the folders or any files that are present in the working directory of your session. Okay, so whenever you're working on RStudio, what you do is you create a working directory, in the sense that working directory is generally a location, a path, right, a library or folder. Let's call it a folder in your laptop where most of your data is stored, right? Which means you will have, when you want to access, let's say, Excel files, CSV files from a folder, you can set your working directory as that folder, so that when you're importing files, you can directly import it by just referring to the name of that file. Otherwise, if you have to import files, you will have to specify the entire path of a file. Right? The easier way to do that is set a working directory. And how do you do it? You can go to session. You can go to set working directory, go to choose directory, and you can choose the folder in which most of your data is stored. For example, if my data is stored in documents, within documents, let's say there's another document folder. Let's say my data is stored here. Okay, codes and data, or let's say data set itself. Okay, so I can set this as my working directory, and then in this files folder, I'll be able to see all the files that are stored here. Right? The benefit of doing that is that you'll be able to see everything that's stored here, and then you can directly import it. For example, you don't have to do it right now, but I'm just showing you. Let's say if I wanted to import this customer churn.csv file into RStudio, I could just create an object name new file. Okay, and whatever, right? It's up to me what name I want to give. And then I could just do read.csv, and within double quotes, I can write the name of this file. Right? Let's say it's customer underscore churn.csv. And when I run it, this new file object gets created in the environment. Okay, so this is a way in which you can import file, but the best thing about session or working directory is that you don't have to specify the entire path of your file, right? Otherwise, if this file customer.underscore churn.csv was stored in a different folder, which is not my working directory, then I'll have to specify the entire location of my file as well, right? I would have to write all of this in my script. Okay, the whole path of my file and then the name of the file. So that's a benefit. So yeah, that's about the files folder. It basically just tells you all the different files that are stored in the files, like in your working directory. Plots window is basically that window wherein you'll be able to see all the plots, right? Any visualization that you created, you will be able to see it here. For example, if I create a simple plot for you, it's a plot. Total charges. Of course, you don't have to do it. It's only for, I'm just showing you what happens in the plot window. You might not even have this file, so don't worry about it. Let's say if I generate a plot between total charges and tenure of a person, right? Two different variables, right? And run it. So a visualization gets created here, and it shows up here in the plots window. Okay, this is like one of the windows where I'll be able to see all my plots. Okay, any visualization, any graphs that you create will show up here, right? And you have an option to zoom it, export it, import it, whatever you want. Okay, you can also clear it if you want. So this is a plot window. Okay, the next window is called the packages window. This is an important window because it tells you all the different packages or libraries that you have installed in your machine right now, in your laptop right now. Okay. Libraries or packages is a very important part of RStudio because what happens is there are several operations, there are several packages which do not come pre-installed for you. Right? There's a base package, which means you can do like most of the basic things in R. But then to do more advanced operations, you might have to, let's say, import a package from outside. Okay, these packages are free of cost, right? It's not that you have to pay for it. It's just that, and it's a very important feature of RStudio as well, that a lot, like for example, if I am a programmer, right? If I am a data scientist, I can create my own package and make it available for everyone else to use. Right? It's a way in which you create repetitive toolkits and you make it easier for other people to leverage your work. Okay, for example, let's say I have coded the algorithm of linear regression. Okay, it could be a 300-line code, right? That I've coded and I've packaged it in the form of a function, right? So I've published my package, right? And I've made it available to everyone to use. So now what I can do is, let's say if you want to use it tomorrow, you can just download this package, you can just install that package, and you don't have to write those 200 lines of code to execute linear regression. Rather, you can just use my function and run it. So it's a way in which you can reduce your work. You can leverage existing codes, existing work from people, right, and make your life easier. Okay, that's the importance of packages. So in like this packages window will show you all the different packages that are installed for you already. And then if you want to install new packages, you can go to install and then write the name of a new package that you want to install. For example, there's a package called ggplot2, which is a very important package because it lets you create very, very intuitive, very, very important visualizations, right? So you can write the name of the package and then click on install. Okay, and it will install that package for you. So all the installed packages will be here, right? And if you want to install new packages, you can do it from here. Okay, so packages is important, and we will, by the way, import a lot of new packages, right? And we will leverage them, and I will also tell you what are the best packages to install for different things that we will do within data science. Okay, the next window is called the help window. It's also a very important window for all of us, right? Given that all of us are starting out programming in RStudio, it's very important because the help window is basically like a Google for you. Okay, so for example, if you are starting out programming in R, you know that you want to run the mean function, or you want to run a linear regression function, but you don't know the syntax of it. Okay, so what you could do in that case is that you can come to help, right, and you can type the name of the function. For example, lm is the name of the function that you want to run. Okay, so you can just write lm, right, and you would then get a documentation around this whole function, right? So it's a function which is used to fit linear models, right? And it gives you a description of the model. It gives you the usage, the syntax of the model. It gives you what are the different arguments and the description of each of the arguments. It gives you the details. It also gives you various examples in which you can run the LMF function. Right? So it's a very important feature, especially for someone who's starting out programming, right? Because, and by the way, I will never recommend anyone to learn syntaxes or to remember syntaxes. Right? You don't have to spend extra effort to learn all the different functions, all the different syntaxes, because it's available to you almost at a click of a button. Right? Let's say if I want to run a function and I don't know how the summary function works, I could just search for it here, right? And then it will give me the syntax of the function. I don't have to remember the syntax. Right? That's probably the least important thing that I want to do, right? Remember syntaxes, remember how what is the purpose of each of the argument. Of course, you will develop that kind of skill set. You will start remembering things as you practice them a lot, right? It's a muscle memory that you develop, but don't spend effort, or don't spend time in purposefully remembering or syntaxes, right? That's probably not the best use of your time. Okay, so this is that that window wherein you can get all the help that you need, right? In terms of object summaries, anything, right? Any function that you're for example, plot, right? I don't know how plot function works, so I could search for plot as well. Okay, so it will give me some options on what plots I want, what is it that I'm searching for, right? So it's a very important use case in that source, right? But I just hope all of you have a decent familiarity with the interface now, right? All of you know how the interface looks like, what is the purpose of different tabs that we have. So Victor is asking what is a project in RStudio. So Victor, a project is basically a combination of multiple scripts or programs or different files that you've stored. So when you work in a project, what you do is you generally create multiple code modules, right? And you create multiple objects, etc. as well. If you save a project in totality, then all your scripts within that project and all the files, etc., all the objects, etc., that you've created, data objects that you've created, functions that you've created, will get retained and saved in the form of a package itself, right? So when you open that project, right, all of those code windows, for example, if this is a project, right, wherein I have all of these different scripts, right, available to myself, right, then I can open this project and all of these scripts will be available to me. All the different objects that I created will be available to me in the next session as well. Right? So that's a project, right? It's a combination of multiple scripts, multiple objects, right, that you created in a session. Okay, so I hope all of you now have a decent familiarity with the interface. We will spend a lot of time on the interface now, right? But of course, you guys should explore it more, right? Try just coding it a little bit, just try playing with it, right? I'm sure you will have more questions. Okay, so spend some time on it, like whenever you have time. But for now, let's go and understand a little bit about programming itself. Okay, how does our programming happen? What are the just try and understand the basics of programming, right? Okay, So the first thing about programming, right? Like the most basic concept of programming, right? In any language, to be very honest, is basically learning about variables. Right? There's something called variable, right? That we manipulate from time to time on every programming language, right? So we'll start with the very basics of what a variable is, what are data types, etc. Right? So we'll come to that. But before that, I just want to spend a quick 5-7 minutes. It could be lesser than that as well. But I just want to tell you why is it that we're using R as a programming language here, right? What are the benefits that are associated with R? I generally get this question asked from people around why R, right? Why Python, etc. Right? R is, by the way, a statistical. It's basically a programming language that is built for statistical analysis, right, and machine learning. It's a there's no other tool, right, which is custom built for that aspect itself, right. For example, you can also do statistical analysis, programming, machine learning in Python, right? But Python was not custom built for statistical analysis. Okay, it's a more versatile language, programming language that is also capable of doing machine learning, deep learning, data science, etc. Right? But it can also do a lot of other things, right? It can also be used for software development. It can be also used for other things, right? But R is that language which is custom built for statistical analysis and machine learning, right? Data science, and I generally feel, and I've heard from people as well, that it's more intuitive, right? It's like programming in R is more intuitive. It's easier as compared to a programming language like Python, right? Which has a lot more indents, which has a lot more like the syntactically. I feel Python is slightly more complicated, but that's my perception. Like that's a personal sort of a perception, right? It depends from people to people, right? For some people, R might be more difficult, right? Python can be easier, but generally, right, R is basically a tool which is custom made for statistical analysis, and it is capable of doing a lot of different things. Okay, you can't compare R with Python or Python with R. I wouldn't say that Python is better or R is poorer, right? That's a decision for all of you to make, right? And what I recommend everyone to do is that everyone should get to an intermediate level of programming.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customers says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also, the course material is structured in such a way that it covers all the basic till the advanced level of concept that even a non-computer science background student can easily understand the concept.
Now, let's continue with the session.
Efficiency or skill on both languages, right? Both R and Python, right? Just get to an intermediate level, right? Don't try to become an expert on both languages. That's not required. Just get to an intermediate level of understanding of two languages and then choose which is that language that you want to pick as an expertise, pick as a speciality, right? And then develop a better understanding or better expertise on that language, right? Don't judge beforehand, right? Because in terms of functionalities, both languages have similar functionalities, right? Of course, the syntaxes and everything is different, but in terms of functionalities, R is able to do. When we talk about data science, R is able to do most of the data science that you would be doing. Okay, the same case is true for Python as well, right? So what I'd suggest everyone to do is like get to an intermediate level of understanding and then choose which language you want to become an expert on, right? And that's where the right way of doing things as well, right? Because it might just happen that you go ahead with a perception and then you don't even explore the other language. It also gives you a better chance of picking up more interesting projects, right? Because if you work on a setting when you have people who either know only R or Python, right? Then like if you come across as someone who's comfortable with both languages, then you can pick projects, right? You can become associated with any project, right? Be it in Python or be it in R. So that's a little bit of competitive edge that you get on people. So R.
Test your knowledge of data analytics by answering this question. Which of the following is not a major data analysis approaches? A. Data mining. B. Predictive intelligence. C. Business intelligence. D. Text analytics. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Is basically a free open source code, right? It's basically available under a open source license, which means anyone can download and modify the code. In practical terms, this means that you can download and use R free of charge, right? And that's what we're doing. R runs anywhere. Okay, the R development core team has put a lot of effort in making R available for different hardwares, different softwares. So this means R is available on Windows, it's available on Unix, it's available on Mac, everywhere it's available. It supports a lot of extensions, right? It performs a wide variety of functions, such as data manipulation, statistical modeling, graphics, right? One real big advantage of R is its extensibility. A variable is nothing but it's a temporary storage space, right? Wherein you can keep changing the values of variables of the object that you created. For example, if you want to store let's say the price of apple, okay, in an object in R, you know that the price of apple is going to change, right? It can change every day, it can change at a certain frequency, right? You want to keep that variable updated, right? But you know that this object, the value within that object can change, right? Can keep changing, right? So what you can do in R is you can create an object, right, which stores which has a temporary storage space assigned to it, and then you can, whenever you want, you can keep changing its values. That's what a variable is, right? It's a temporary storage space wherein you can keep changing values if you want to. If you want to create a static variable where you don't want to change the value, that's also fine, right? It's up to you whether you want to make a variable actually variable, or you want to make the variable static. That's up to you, right? It's just that it's an option available to all the programs, right? So where, like, a place wherein you will store values, right? Store information, it's called a variable. Okay. The second thing to know is data types. Okay, what are data types? Data types are nothing but it's a way to say what is the different kind of variables that you can create, right? What could be the nature of these variables that you could create, right? So data type is nothing but the kind of information, the kind of value that you're storing in these variables. Okay, so if you're storing a numeric value in a variable, like a number, 5,000 minus 33.5, fractions, decimals, very large numbers, 100 million, 100,000 million, 0.07936, 3.144, whatever. As long as that information is numeric, you can create the data type that variable is going to have is going to be a numeric data type. Okay, so if you're storing numeric information in a variable, you're going to have a data type that's going to be associated with it, right? And that data type is going to be a numeric data type. If you're storing a character information, like text information, right? Let's say, for example, if I want to create a variable that stores the names of all the people who are attending today's session, right? Then that is going to be a character data type, right? Because it's names, it's actually text. Okay, so storing text, storing alphanumerics or even alphabets is basically stored in the form of a character data type. Okay, string data type or character data type. If you're storing values which are in the form of trues and false, right? So for example, binary variables. Okay, let's say if you want to store information like whether someone is married or not, like there are only two possibilities, true or false. Whether someone has kids or not, right? Only, like, there are only two possibilities, true or false. Whether India is going to win the next World Cup or not, true or false, right? So there are two options, right? So whenever the output is in the form of binary nature, right? True, false, 1, 0, the data type that you're going to use to store that variable is going to be a logical data type. Okay. And finally, if you're storing a number which is a complex number in the form of iotas, 330 plus 2 iota, 5 plus 6 iota, etc., then that you also have a data type for that. So you can store that information in the form of a complex data type. Okay. slightly rare, but the other three is something that we're going to use very, very frequently. And just so that you're aware, these are not the only data types that you're going to work with, right? There could be other data types as well, but you could say that these are the most important data types: numeric, character, logical, complex. And 95% of the times you will end up working on only these variables, right? In a specialized use case, you might get exposed to other kinds of data types as well. Okay. The next thing which is important for all of us is operators, right? What are operators? Okay, operators are nothing but these are certain uh, predefined objects, right, or parameters that exist in R in the form of certain symbols, right? Symbols, or let's say a combination of two or more than two symbols, right? Which will help you perform a specific kind of operation on top of data and on top of variables. Okay, there are different kinds of operators, right? There's an assignment operator. There are basically four major types of operators: assignment operators, okay, arithmetic operators, relational operators, and logical operators. Okay, what is the difference between all of them? Assignment operators are operators which are used to assign values to a variable. Okay, there are three different types of assignment operators. They don't work very different from each other. Okay, they work very similarly, but you have three different ways in which you can create a variable and assign a value to it. Okay, so assignment operators are used to assign values to a variable, create variables. Arithmetic operators are operators which are used to do arithmetic operations, right? For example, you have a plus to add variables, right? To add values. You have a minus to subtract. You have a multiplication, division, modulus, exponent. A lot of different arithmetic operators available, right? Which you can use to do arithmetic operations. You have relational operators. Relational operators are basically used to compare two or more than two variables, right? So for example, greater than, less than, and this is typically used in numeric variables, right? When you want to compare whether one variable is greater than another variable, right? Greater than, equal to, less than, not equal to. That's what relational operators are. And then the final ones are logical operators, which are used to combine two or more than two relational operators. Okay. So there's an AND operator, there's an OR operator. We will look through each of these. So let's cover them one by one. Assignment operators are basically operators which are used to assign a value to an object. Okay. So for example, if you want to create a variable in R, you can use there are three types of assignment operators. There's equal to, there's leftward assignment, and there's rightward assignment. Okay, each of them have work almost in a similar manner. You can't say that in terms of efficiency any of them have a poorer efficiency or a better efficiency. All of them have a similar kind of efficiency. It's just that it depends on you on what operator you're most comfortable working on. For example, I always use the leftward assignment operator to create variables or to assign values. Okay, I'll show you an example of how you can use each of these operators. Right, I can just create a new R script, and I can clear my console by doing Control N. I can clear my environment by doing brooms here. So let's say if I want to create a variable, right, there are three ways in which I can create a variable. Right, so for example, I'm creating X, right, a variable X, and I want to assign a value 5 to it. Then I can use this operator, right, called the leftward assignment operator to create this variable. When I run it, you'd see X gets created and its value gets stored as 5. That's the leftward assignment operator, right? This is how you do it. On the left, you write the name of the variable, and on the right, you write the value of the variable. Okay. The other way of doing it is that you use a rightward assignment operator. You do something of this sort, right? You do this, right, and you write this, right, and you'd say actually opposite. So 10 is equal to y. So for example, here you're using a rightward assignment in which on the left hand side you write the value of the variable, and on the right hand side you write the name of the variable. Okay, this is called the rightward assignment operator. Works the same way, right? It also creates a variable y, and the value 10 gets stored in it. It's up to you which one you're more comfortable on. And then the last one is basically just use equal to. Right? This is the equal to assignment operator. Okay, so you can just do z is equal to 100. This also works the reason, of course, you might say that this is the easiest, right? Because we are used to writing equal to's and we know equal to's, but this becomes slightly confusing in the sense that there's also an equal to operator as a relational operator, right? To compare two values whether they're equal to each other or not, you have a equal to assign like an equal to relational operator. Sometimes people get confused between the assignment equal to operator and the relational equal to operator. Hence, it's preferred that like you use either of leftward or rightward. I generally prefer using leftward assignment operator. Okay, so that's about assignment, right? How do you assign a variable to a value to a variable? The next one is called arithmetic operators, right? There are like this is very straightforward. If you want to do addition, subtraction, multiplication, division, you can make use of plus, minus, multiplication, etc. So addition, subtraction is very simple, is very easy. For example, if you want to do a x plus y, right, and you want to just get its output, right, so you can make use of the addition operator here. Addition operator, or I've already created x and y, so 5 and 10. So if I run it, it just gives the value 50. Similarly, if I want to do subtraction, let's say if I want to do x minus y, okay, it does a subtraction. Okay, so the output of 5 minus 10 is of course minus 5. Okay, then you can do a multiplication, right? So x multiplied by y, you use the star sign and it done the multiplication. Okay, and the last one is division. So for example, if you want to do y divided by x, right, you can do division. I haven't run the multiplication yet, so I'll run both of them together. So yeah, so if you want to do multiplication, x multiplied by y is 50, right? And then y divided by x is 2, right? 5 divided by 10 is 2. So this is how you can do arithmetic operators, right? And there are more arithmetic operators as well. For example, if you want to do a square of something, right? If you want to do the power of something, for example, if I want to run y to the power 2, right? This is how I can do it. This is called the exponent operator. It's also an arithmetic operator. Okay, this will basically give me the square of y, right, which is 100. Right? If I want to do the cube of y, this will give me the cube, right? Y to the power 3 is basically 1000, right? So you can also use the exponent function if you'd like, exponent operator. There is, right, obviously it's asking, is there a mod operator? So there is a mod operator. There's a modulus operator. So see, modulus operator, not sure if everyone understands modulus operator, but let me anyways show it to you. For example, if you want to do this, right, if you want to do, okay, so this is the modulus operator. What modulus operator will do is that it's the mod operator, sorry. The mod operator basically gives you the remainder of a division division function. So for example, 10 divided by 3, right? If you consider the proper division, right, you do not take into consideration decimals, right? Then 3 into 3 is 9, and you get 1 as a remainder. But if you want that remainder out as an operation, you can make use of the mod or the modulus operation. Okay, so this y percentage 3 is basically a modulus operation wherein you're doing a 10 divided by 3, and if you want to get the output as a remainder, you can use this. Okay, that's what the mod operation is. Okay, so these are all the different arithmetic operators that you could use. Okay, the next one is called relational operators. Relational operators are basically used to test a condition, right, or to find a relationship between two operands, which means it's typically used when you want to compare two different values, and as a result of that comparison, generate outputs. For example, if I want to look at the age of people and want to categorize them into senior citizen, young, middle age, what I would do is I would say that if the age is less than 50, or let's say if the age is greater than 60, then it's a senior citizen. If the age is greater than 25 but less than 60, then it will be a middle-aged person, and if the age is less than 18, then it will be a young person, right? So young, or maybe you can call it a child, whatever, children, right? So like that's how you can make use of relational operators. I will show you how each of these relational operators work, right? For example, if you want to check whether y is greater than x, right, you could just do y greater than x, right, and you run it. Because the value of y is 10 and the value of x is 5, it will give you a true. Right? The output of this is going to be true. You can also do, actually, let's not do that. So yeah, this is greater than, right? Similarly, there is greater than or equal to as well. You can try it yourself. there's also something called equal to, right? So if you want to check whether the value of y is actually equal to x or not, you can just do this, right? Y is equal to x. You don't need to have the spaces. Even if you do, that's okay. So if you do this, because the value of y and x is not the same, the output that you would get as a result of this is going to be a false, and that's what you get. Okay. So if you want to check, right, if the value of two functions are equal to each other, value objects are equal to each other or not, you can make use of equal to, right? I can actually show you an example where I can create z, right, whose value is also 10. Sorry, z whose value is 10. And now if I do y is equal to z, right, the output that I'll get is going to be true. Okay, this is how the relational operators work, right? It's generally used within an if-else condition. You might just do if y is greater than x, right? Then print x, else print y. Okay. So for example, what it will do is it will check for this condition, right? If the value of y is greater than x, then it will print x, right? Else it will print y, right? In this case, because y is greater than x, right, the output that will get printed will be x, right? The value that will get as a result of this is going to be 5. It will give you an error because it's this is the syntax if else. Yeah, the output that you get is 5 here. Okay, so this is how you generally apply your relational operators, right? You make use of relational operators with an if else condition. But yeah, that's right, obvious, right? So guys, R is highly case sensitive, right? When you have to make sure that you're using the right cases, right? Lower cases or upper cases. If you don't do that, you will end up getting an error, right? For example, if I didn't print x, capital X here, right, instead of small x, I will get an error because the capital X doesn't exist here, right? So make sure that you're using the right cases, right? If you don't use the right cases, you might get an error, right? So there's a difference between small x and capital X, even in the way you're using it, on also in the names. Okay, so that's essentially a lot of relational operators, right? That's one way to find relationship between two or more than two values, right? There are lots of them. There's less than this, less than equal to this, greater than this, greater than equal to this, equal to, and then there's not equal to. Not equal to is also something you can check. So you could just do whether z is not equal to x, right? Because z and y have the same value, the output of this should be false, right? If I do z whether y is not equal to x, the output of this is going to be true because the values of y and x are different. Okay, so that's how your not equal to operator works. The last operators are logical operators, right? Logical operators are basically used to make a decision on the basis of a condition, right? This basically just means that if you want to combine two different conditions, right, there are two logical operators. There's an AND operator and there's an OR operator, right? When you use the AND operator, it means that there are two different conditions that you're checking, only if both those conditions are holding true, right, then the output that you're going to get is going to be a true. So for example, if I'd say if x is greater than y, right, and y is greater than z, right, then print 100, right? If this is my this is my code, then only when this is also true and this is also true, that's when my output is going to get printed. Otherwise, even if one of them are true, right? So for example, if this is true and this is false, then output will be false. If this is false and this is true, then output will be false. If both of them are false, then my output of course will be false, but only if both of them are true, which means the left hand operand is true and the right hand operand is also true, only then I'm going to get a true as an output. Okay, so AND operators are basically when both the conditions, right, both the conditions that you're trying to check, only both those conditions are holding true, that's when the output is going to get published for you. Okay, for example, if you go to buy a car, right, and you'd say I only want to look at those models of cars where the car has a sunroof, right, and where the car also has has airbags, right? So when you use an AND condition there, which means you're saying that only if both these conditions are holding true, right? I want a car where, or I want to get options of those cars where the car has both these features, right? It's not that either of these features can work for me, right? So when you want both those features to be holding true, that's when you would use an AND condition, right? An AND operator. But there's also another operator which is called the OR operator, and the way you would run it is basically a pipe sign. For AND, it's an ampersand. For OR, it's a pipe sign. An OR operator basically means that if either of the two conditions are holding true, then the output is going to be true. For example, if you say, I want to get car models where either the car has a sunroof or the car has an airbag. If either of those things exist, then I'm okay to buy that car, right? Which means you're okay buying a car which has a sunroof but doesn't have an airbag. You're okay in buying a car which has a airbag but doesn't have a sunroof, and you're absolutely okay with buying a car which has both these features, right? Which also has a sunroof and which also has a airbag, right? So that's when you would make use of the OR operators. Okay, so these are all the operators that exist in R. Okay, we will make use of these operators when we basically get deep into coding. Okay.
So what is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of those questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C#, or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. That's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century, and basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then, well, on that note, let's come to the topic of why one should learn Python. Well, the first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. We've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. There are no semicolons. It is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much probably equivalent to putting out an output which gives out hello world. You can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python, and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, basically Apple's operating system, and you can use any of your favorite operating systems. In fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this, makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the number one language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know.
What is data visualization? So data visualization is a representation of data in a pictorial or a graphical format. It allows the decision makers to see analytics, grasp difficult concepts, and identify new patterns at ease. Let me just show you an example of data visualization. So let's say there's our data. So our data set consists of the name of the animal, speed, aggressiveness, and size. So now if I visualize my data, this would look something like this, right? So here you can see that both my data and the visualization consist of the same data. So from this example, don't you think that visualizing our data is a better way to read and understand it? So let me make things more clear for you. So let's understand, why do we even need to visualize our data? So here's an example of Anscombe's quartet. Let's see. So our Anscombe's quartet consists of 4 different data sets with almost identical statistics. So here if you compare the sum, average, and standard deviation of all the 4 data sets, they are almost identical, right? So if you see the sum of all the coordinates of x and y of data set 1, we have 99.0 and 82.51. Similarly, sum for all the x and y coordinates for data set 2 is 99.0 and 82.51. So in all the data set, the sum, average, and standard deviation is exactly same. But here's a catch. Now if you plot all these points on a graph, you'll notice that all your plots or graph are completely different. So this is my plot for my first data set, this one is for my second, this one is third, and this one is for the fourth one. So even though the statistics for the data was so identical, but when we graphed it, all of them gave me a unique plot. Thus, it's important to visualize our data. Okay, so I hope now you're convinced with why do we need to visualize our data, right? Let's move ahead. Next is data visualization library in Python. So we have Matplotlib, ggplot, Bouquet, Seaborn, Geoplotlib, and Plotly. So these are various open source data visualization library which you can use to create various graphs and plot like bar chart, line chart, scatter plot, and other various types of plots in Python. So in our next session, we'll learn about Matplotlib in detail and we'll see how to use it to create various graphs like line chart, bar graph, and others. Okay, so this was all about the basics of data visualization. What is Matplotlib? Well, Matplotlib is an open source Python library used for visualizing our data. It creates 2D graph and plot them using some Python scripts. And once the plot is created, you can produce the output in a variety of hardcopy formats like PNG or GIF. So it's like you can save your graph in a PNG file or a GIF file. Okay. Now let's have a look at some of the key points or the reason why we should use Matplotlib for data visualization. So our first point is it has PyPlot. Well, Matplotlib has a PyPlot module which helps in easy customization of plot. Second reason is, in Matplotlib with the help of some simple functions, we can add various plot elements such as lines, images, text, etc. Okay. Third is, it supports a very wide variety of graphs and plots like histogram, bar charts, line chart, power spectra, error charts, and many more. Another reason to use matplotlib is that it can easily integrate with different Python libraries such as pandas, numpy, etc. And finally, matplotlib has object-oriented API which is used for embedding plots into applications. So I hope now you understand why we are choosing matplotlib for visualizing our data. Okay, so let's move ahead and see what are the different types of plot you can create using matplotlib. So let's see type of plot. So we have line plot, bar plot, scatter plot, histogram. We also have image plot, box plot, violin plot, stream plot, quiver plot, area plot, and finally we have pie plot and donut plot. So these are the different types of plot you can create using matplotlib. So this was all for this session. So in our next session, we'll see how to use matplotlib to create these plots. Okay? How to create line plot using my Jupyter notebook. Okay, so let me just open my Jupyter notebook. So there's my Jupyter notebook. Here what we are performing, let me just name it. So we are starting with how to create a line chart or line plot, right? So for this, the very first thing that I'll be doing up here is importing my libraries. I'll be importing Numpy for creating my dataset. So I'll import Numpy as np, and I'll import matplotlib to create the visualization. So import matplotlib.pyplot as plt. Okay. Next, I'll define a send matplotlib inline. This sets the backend of matplotlib to inline backend. With this backend, the output of plotting command is displayed inline within the frontend. Here, our frontend is Jupyter Notebook, and the plot will be displayed directly below the code cell that produced it. The resulting plot will then be stored in a notebook document. Okay. Next, what I need to do, I need to define my dataset. So here, defining the dataset. Okay. So let's define our x coordinate. Let's say x equal np dot arrange numbers between 0 to 10 with a gap of 0.1. Okay. Next, let's define y equal, let's say 2 times of x plus 5. So this is the equation of y. So now I have both my x coordinate and y coordinate. Okay. Now my next task would be to plot them on the graph. So plotting the data points. So for this, I'll just write plt.plot both the coordinates x and y. That's it. And finally, if you want to see the created visualization, just write plt.show. It'll show you the visualization that is created. So there's our line plot. Okay. Now this is a very basic example of line plot. Next, let's move ahead and see how we can customize our line plot. Okay. So here what we are doing, customizing the line plot. Okay. Let's just reuse this code. Now for this code, you got the output as this. Okay. Now let's customize this line plot and change the shape of this line or add the data point on it. Let's see how we can customize this line. So let's start customizing it. So first, let's add some title, x label and y label to our graph. So plt.title. So what's our title? It's a line plot demo. Okay. Let's name our axis. plt.x label is x-axis and plt.y label is my y-axis. Okay, let's execute it. So here you can see that we got the title as line plot demo and our axes are labeled like x-axis and y-axis. Here we have defined the title, the x-axis and the y-axis. Okay, now let's try to customize our plotted line. Let's see how we can customize this line. Okay, so let's add line width. You can change the width of the line. Let's say the width of the line is 2.0. Okay, you can change the line style. Let's say I want a dotted line, so I can specify colon over here. We can even choose the color. So let's say my color is red. So you can even control the opacity of your line using alpha value. So let's say alpha equals 0.5. And let's say I want to represent my data point as a circle. So I'll just write over here. Okay, let's execute it. So we got something like this. Okay, so this is not much clear. Let me just reduce the number of data point to make you understand a better way. Let's reduce it to only 10 numbers. So for 10 numbers, you got output something like this. It's clear? Okay. You can even add a legend to it, like plot.legend. Let's say the name of legend is line 1. For now, we have only one line, right? And yeah, this would be mentioned inside this square brackets. And its location, let's say it should be best fit. Let's execute it. So you can see we got a legend up here as line 1. Okay. So if you want, you can even add grid to your figure, like plt.grid, make it true. So the grid is added to your plot. Okay. So this was all about how you can customize a line plot. Okay. So moving on ahead, let's see how we can plot 2 or more plot in a same figure. So this was all about customizing a line plot. So now let's move ahead and see how to create 2 different plot in one single figure. But before that, let's understand what is a figure. So here on your screen, you can see a customized plot, right? So the area in which this customized plot is drawn or plotted is the figure. You can even set the figure, or you can even change the figure size. So changing the figure size would change the size of the plot. Let me just show you with an example. So let's define the figure. So figure equal plot.figure init. Figure size is what? Figure size is, let's say 10,5. So let's see what's the difference you get in the output. So as you can see, changing the size of figure change the size of the plot. Okay. Now let's move ahead and see how you can create 2 different plots in one single figure. Okay. So let's import numpy as np. Let's import matplotlib.pyplot as plt. Same matplotlib inline. Next, let's define 2 variables. Let's say x equal np.arrange 0 to 10 with an equal number of 1. So all the numbers between 0 and 10. Let's say y1 equal 2 times of x plus 5 and y2 equal 3 times of x plus 10. Okay. So now to create 2 or more plots in a figure, we need to use a subplot. So plt.subplot will define plt.subplot with height 2 and width 1. Okay. And here the first plot would be active. Okay. So let's plot our point in it. So here we are plotting the points with plt.plot x comma y1. So there's my first graph. Let's name it plt.title. This is graph 1, and let's plot our next graph. So plt.subplot height 2, width 1, and here the second part would be active. Again, let's plot plt.plot x comma y2, and let's add the title as plt.title. Let's name it graph 2. Okay. So now that everything is defined, so I can just call plt.show to see my created graph. Let's execute it. So I got the output as this. So both my graphs are in one single visualization. So if I want to display them side by side, what I have to do, I'll define the height as 1 and width as 2. That's it. Define the height as 1 and width as 2. So you'll get the graph side by side. Okay. So this was all about the line chart. Let's quickly jump back to our Jupyter notebook and see how to create a bar plot using matplotlib. So there's my Jupyter notebook. This is where we left. So what I'm doing here, how to create a bar plot, right? So again, the very first thing that I'll be doing up here is importing my libraries. So import numpy as np for creating my dataset. Import matplotlib.pyplot as plt for creating the visualization. Then percentage matplotlib inline for rendering the figure in the notebook. Now what I'll do, I'll create my data set. So here, creating the data set. So let's define a dictionary up here. So my data equal, let's say apples. How many apples? Quantity, let's say 20. Let's name a different fruit as mangoes. How many units of mangoes? Let's say 15 unit of mangoes. Then let's say lemon. Lemon is 30. And one more, let's say oranges. Let's make it as 10. Okay, so let's separate the name and the values. So let's define a parameter as names. So name equal list of data dot keys, right? And values equal list of data dot values. Let's define the figure size. So let's say figure equal dot dot figure. Figure size is, let's say 10 comma 5. Okay, now let's create the bar plot. So creating the bar plot. So plt dot bar, inside that mention names and values. That's it. So let's see what we just created. So plt dot show, execute it. Fig size is not defined. Okay, I just missed the equal sign over here. Okay, so this is how my bar chart looks like. So now that we have created our bar chart, let's customize it. So next is customizing the bar chart. Let me just reuse this code. So what all things I can add up here? Let's add a title. So plt dot title to our bar graph is bar graph demo. Let's define the X label and the Y label. So plt dot X label is name of the fruit, so fruits, and plt dot Y label is quantity of the fruit. Okay, so let's see what output do we get. So we got something like this. So here you can see that the title of my graph is bar graph demo. The x-axis is the fruit and the y-axis is quantity. Now what if I want to change the color of these bars? So for changing the color, I'll just add a parameter up here like color equal name of the color like orange, and just execute it. So here you can see that the color of my bar has been changed to orange. Okay, now what if I want to create a horizontal bar graph? So in that you don't have to do anything, just write bar h, that's it, and you'll get a horizontal bar graph. Let's quickly jump back to our Jupyter notebook and see how to plot a scatter plot using matplotlib. So there's my Jupyter notebook where we left. So now what I am doing is how to create a scatter plot. Let's add a new cell up here. Let's import the required libraries. So for this, I'll be importing this matplotlib dot pyplot as plt. So I'll be importing this library to create my visualization. Next, matplotlib inline. So now what I'll do, I'll create my data set. So creating the data set. So let's define like a equal, let's say 10, 20, 30, 40, 50, 60, 70, 80. Okay. B equal, let's take some random numbers like 5, 4, 3, 2, 5, 6, 1, 4, 2. Okay. And here let's define another variable x as 1, 2, 3, 4, 3, 2, 1, 2. Okay. So now that we have prepared our data set, so our next task would be to create the scatter plot. Creating the scatter plot. So plt.scatter a comma b. Okay. plt.scatter a comma x. Fine. And finally plot.show. Let's see what is the output. So here you can see that we have a as the x-axis and b and x as the y-axis. So both the b and x are plotted up here as blue and orange point, but we don't know exactly which one is b and which one is x. right? So just by looking at the visualization, we cannot say which one is B and which one is X, right? So let's customize it and make it more clear. So here, customizing our scatter plot. So this was our code, okay? So first of all, I'll add legend to my graph in order to distinguish between which one of them is B and which one of them is X, okay? So plt.legend, inside this, first is B and the next is X. Let's specify the location. The location will be the best location, wherever is the best location possible. Let's execute it. So here you can see we got the legend as blue color is for the B data and orange color is for the X data. Let's verify it. We had B as 5. So yeah, it's correct. Okay. So now let's add some title to our graph. So plt.title, let's say scatter plot demo. Okay. Let's name the x-axis and y-axis. Plot.x label is x-axis and plot.y label is y-axis. Okay, let's execute it. So we got our label and the title. So now what we can do, we can customize the color, size, edge colors, marker and alpha value of this scatter plot. So let's see how to do it. So here we have a comma b, so just write comma color. Let's say I want to keep it as green. Okay, let's say the size is 300. Okay, the edge color is, let's say, yellow. Shape of the marker is somewhat like this, and the value of alpha, that is the opacity, is 0.5. okay, and let's do the same change for the X. Okay, now let's just change these values, make this to red. Let's make the size to 400, edge color to, let's say, blue, marker, let's make it, let's say, 4, and alpha to 1. Let's execute it. So we got the output as this. For B, the color is green, size is 300, edge color is yellow, the marker is circle and it's transparent, and its opacity or transparency is 0.5. While in the case of X value, its color is red, size is 400, edge colors as blue, marker 4, and alpha or opacity is 1. So we got the shape. If we change it to 200, the size will decrease. Okay. If you want, you can even save your visualization up here using savefig. Okay. So plt.savefigure as scatterplot.png. Execute it. So your file is saved as scatterplot.png. So you can even add grid to your plot. So plt.grid, inside this pass the parameter as true. Execute it. So you'll get the grid in your plot. You can even save your visualization using plt.savefigure, and inside this pass the parameter as the name of the file. So let's say scatterplot.png. So this will save this plot in a PNG format. Execute it. Okay, it's done. So this was about the scatter plot. Let's quickly jump back to our Jupyter notebook and see how you can create a histogram using matplotlib. Okay, so this is the Jupyter notebook where we left. So here I'll be creating a histogram. Well, this histogram is generally used to display a frequency across a continuous or a discrete variable. Okay, let's see how to create it. How to create histogram.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customers says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also, the course material is structured in such a way that it covers all the basic till the advanced level of concept, that even a non-computer science background student can easily understand the concept.
Now, let's continue with the session.
So the very first thing that I'll be doing up here is importing my matplotlib library. So import matplotlib.pyplot as PLT. This will help me to visualize my data. Then %matplotlib inline for rendering the figure in the notebook. Next, let's prepare our dataset. So preparing the dataset, let's define some numbers. Let's say I want to add 5 numbers between 10 to 20. So let's add 10, 12, 16, 19 and 11. Then 2 numbers between 20 to 30. So 20, 26 and 28. Let's say 3 numbers. Then let's add 4 numbers between 30 to 40. So 30, 45, 30, 38, 35, 34. Now let's add few numbers between 60 to 70. So 60, 68, 64, 62. Now let's add some numbers between 70 to 90. So 70, 78, 75, 79, 85, 94 and 95. Enough. Now let's create a histogram. Let's see, creating the histogram. Now for creating the histogram, what we'll do, we'll just call plt.hist and inside that we'll pass the number and we'll define the bins. Well, this bin is a range of values that divide the entire range of values into a series of intervals and then count how many values fall in each interval. Okay, it's like if we are defining the range as 10 to 20, so how many numbers fall between the range of 10 to 20. Okay, so let's define the bin as bin equal 0.
Test your knowledge of data analytics by answering this question. Which of the following is not a major data analysis approaches? A. Data mining. B. Predictive intelligence. C. Business intelligence. D. Text analytics. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
0, 20, 40, 60, 80 and 100. It depends on you. You can define any kind of bins up here. Okay, now let's check our plot. So plt.show. So this is our required graph. We don't have any number between 40 to 60, right? No numbers between 40 to 60. That's why we didn't got any bar up here. If you just add one of the number between, like just add 45. Okay, now let's see. So you'll get this output. So on your x-axis is the range of the numbers and on your y-axis is the frequency of the numbers falling into that particular range. Okay, now let's just move ahead and customize our histogram. Customizing the histogram. So now the very first thing that I'll do is add a title up here. So plt.title histogram demo. Then I'll add plt.xlabel as range of values. Then plt.y label is frequency of values. Okay, execute it. You got this. So now talking about these bars, so you can change the color of these bar by adding hex color codes to them. Let me show you how. So this was my pen. So let's define color as, let's choose a hex value 52331. 6 values 1 2 3 4 5 6. So this hex value represents a color. Let's see which color is that. So it's this. So you can even define a edge color to your graph, like edge color equal, let's say, so as you can see we have added white as a edge color over here, right? You can even change it to black, any color you want. Now let's see what else we can do. So we can also add grid to it. So plt.grid, make it true. If you want, you can save your file. So plt.save the figure as, let's say, histogram plot.png. Okay, these are the various ways we can customize a histogram plot. So this was all about the histogram plot. how to create a box plot and a violin plot. Let's quickly jump back to our Jupyter notebook and see how we can create them. So let me just open my Jupyter notebook. So this is my Jupyter notebook. So the very first thing that I'll be doing up here is creating the box plot. So how to create a box plot. So the very first thing that you need to do is import your matplotlib library. So import matplotlib.pyplot, import it as plt, percentage matplotlib inline. So now that we have imported our matplotlib library, so next task that we need to perform is prepare our data. So next step is the data preparation step. So let's define three variables up here. First one is total. So let's define three different lists up here. So first is total. So let's say total consists of 20, 4, 1, 30, 20, 10, 20, 70, 30 and 10. Okay. My next list is of a order. And this order consists of, let's say 10, 3, 1, 15, 17, 2, 30, 44, 2, 1. Any random values. Okay. And discount. So my discount equals 30%, 10%, 20%, 5%, 10%, 20%, 50%, 60%, 20%, 45%. Okay, now let's define a list data, which it consists of all these parameters. So my list is total, order, and discount. Okay, so now the data preparation step is complete. So the next thing that I want to do is plot my data. So for that, I'll just write here plotting the data. Here I'll just write plt.boxplot. Inside this, pass the data, and I want to see the actual mean of these data. So I can just write show means equal true. So you can also add title to your box plot, like plt.title. Inside this, mention the title as box plot demo. Next, let's define the grid. So plot.grid true. And finally, let's visualize our plot. So plt.show. Let's execute it. So this is our required box plot. Okay, this box plot is very helpful in viewing the summary of a data set in an efficient way. Also, the box plot helps you in doing outer analysis. So here, these points up here, these represents the outlier. There's the minimum point, there's the maximum point, there's the range of points. Okay, so this is basically representing the range of point with your minimum value at this level, and there's your maximum value level. Fine. And this green triangle which you can see up here is nothing but the mean value. Okay, so this was about the box plot. So let's just move ahead and see how to create a violin plot. So our next topic is how to create a violin plot. For violin plot, I can just reuse this code. Let's just copy and paste it. Well, generally, this violin plot is used to visualize the distribution of a numeric variable for one or several groups. It's generally used when the amount of data is pretty huge and showing individual observation get impossible. Okay, so the only change that I need to do up here is plt.violinplot. Well, in general, you'll be using it when you are having a large amount of data and showing individual observation is almost impossible. Okay, so here data show means, you can also add the median, so show median, make it true. Okay, and you can change the title to violin plot demo. Fine, grid is already defined, plot.show, execute it. S is missing up here. So this is my violin plot. How to create a pie chart using matplotlib. This is my Jupyter notebook, and today we'll see how to create a pie chart. How to create a pie chart. The very first thing that I'll be doing up here is importing my required libraries. So importing required libraries. For this, I'll be importing matplotlib for creating the visualization. So matplotlib.pyplot as plt. Let's inline our visualization with our cell. Matplotlib inline. Now let's define our data. Let me just prepare my dataset. So you're preparing the dataset. Let's say I have a list of labels as dog, cat, wolf, and a lion. Now let's define their size. So let's take a list of size. So size is equal, let's say 50 Dog is 50, so cat is relatively smaller. Let's take it 45. Wolf, make it 60. Let's make lion as 75 or 80. Let's take 80. Now our data set is also defined. Now let's create a plot. Creating the pie chart. For this, all I want to do is plt.pie. Inside this, define sizes, labels equal labels. Just for the clarification, let me just rename this label as label. So here labels equal label. That's it. Let's add a title to it. plt.title pie chart demo. Finally, let's visualize it. So plt.show. That's it. Let's execute it. So here I got my pie chart. Now let's customize our pie chart a bit. As a part of customization, I can add percentage to it. I can add shadow. I can define the start angle, or I can even define the burst size. So for defining the percentage, we have a parameter as auto pcd equal percentage 1.1f. Okay. Now I want to add some shadow. So shadow equal true. And also we can define a start angle. Start angle is 90 degree. So now we have learned how to create a pie chart and how to customize it. Our third topic is how to create a donut chart. Let's do it. How to create donut chart. Here, let's start by importing our libraries. Import matplotlib.pyplot as plt. Next, let's inline it. So percentage matplotlib inline. Next, let's define our dataset. So let's say we have group names as group A, group B, and group C. Let's define their size. So group underscore size equal, let's say 20, 40, 60, 40. Or let's change it to 20, 30, and 50. Now for creating a donut chart, we would be needing two different pie charts, and one that would be at the center and would be of white color. So let's define size for our center. Let's take any random value, like let's take it 5. Let's create our donut chart. So here let's say my pie1 equal plt.pie. Inside this, the size is group underscore size. Let's define the labels. Labels is group underscore names. Let's define a radius as 1.5. So now in order to get a center circle, what we have to do, so we have to create a pie chart without any dissection, and its color should be white, and the radius should be less than that of pie1. So pie2 equal plt.pie. Inside this, size, radius, let's make it 1.0, and also the color equal w for white. Now let's execute it and see what we are getting. So we got the output as this. So this is our donut chart. So this is our output. So if you want to customize your donut chart, you can add shadows or change the color of these pies. Let me just show you how. For this, let me just define the color. Let's say A, B, C equal plot.cm dot blues, plot.cm dot reds, and plot.cm dot green. Now that we have defined our value, so here let's add another parameter as colors equal A of 0.5, B of 1.5, and C of, let's say, 1.0. Let's execute it. So the color of the pie has been changed to red, blue, and green of respective shade. These 0.5, 1.5, and 1.0 represent the respective shades of blue, red, and green. This was all about how to create a donut chart. How to create the area plot. So this is our Jupyter notebook. So how to create a area chart. So the very first thing that I'll be doing up here is importing my library. So let's import matplotlib.pyplot as plt. Okay. Next, let's inline our visualization with our cell. So for that we have percentage matplotlib inline. Okay. Now let's define our data set. find the data set. So here I have x as a range of number between 1 to 15. And I have defined y as 1, 4, 6, 8, 4, 5, 3, 2, 4, 1, 5 and so on. Okay. Now let's create the area plot out of it. So creating the area plot. So for creating the area plot, we have to call plt.stackplot, and inside that just pass x and y. That's it. And finally, let's see our visualization. So plt.show, execute it. So this is my area chart. Now if you want, you can even customize it by adding colors and setting transparencies and all. Let me just show you how. So let's define a parameter, colors equal, let's say I want black in it, and let's set the opacity or the alpha value to 0.5. Okay, so I got a visualization something like this. Okay, so this is my area chart. Now my next task is to merge the area chart with the line chart. Merge area chart with the line chart. So for this you don't have to do much work, just write plt.plot and create a line chart using the same values of x and y. So x comma y, and let's set the color to, let's say, green without any alpha value. Okay, let's see. So here you can see we got our visualization in which both the area chart and the line chart is merged together. If you want, you can even add the grid over here. So plt.grid, inside this write true. So here we have a combination of area chart with the line chart. So this was all about the area chart. So what is NumPy? Well, a NumPy is a most widely used Python library for linear algebra. It is used for performing mathematical and logical operations on multi-dimensional array. NumPy consists of various set of functions that can be used while performing your mathematical and logical operations. So this was about what exactly it is. Now the question arises, how to create a NumPy array? Well, we have shown some basic example up here, how to create a NumPy array. So we have created 1D array up here and 2D array. Let me show you this example in my Jupyter notebook. This would make things more easier for you to understand. So this is my Jupyter notebook. So the very first thing that I'll do up here is define my one-dimensional array. So how to define a 1D array? So for that, the very first thing that I have to do is import my NumPy library. So I'll be importing NumPy as np. Why I'm using np up here? So it's just because whenever I want to call some function of NumPy, I don't want to use NumPy every time. So apart from it, what I can do, I can just replace the word NumPy by np. So once you have imported NumPy as np, let's define an array as a equal np dot array. So here instead of writing numpy.array, I can just go ahead and write np.array. That's it. Okay. And inside the array we'll pass list of arrays. Okay, like 1, 2, 3. Okay. And print a. So this is how my 1D array looks like. Now let me show you how you can create a 2D array. So let's create a two-dimensional array. Again, let's import NumPy as np. Let's define an array as v equal np dot array. Inside array, what do we pass? List of function, right? So let's pass 1, 2, 3, comma 4, 5, 6 and print b. I'm telling you this will generate an error. Just think why. It gave you an error of data type not understood, right? So why do you think you are getting up this error? Any guesses, anyone? Think. Remember what I said up here. What do you pass an array? List of array, right? So where is array up here? It's a list, but we have to pass a list of array, right? So you'll enclose everything in opening and closing square brackets. So this would resolve your error. Okay. So this is how you got the final output as 1, 2, 3, 4, 5, 6. So this is how you create your two-dimensional array using NumPy. Okay. So let's start. Well, there are several methods of initializing a NumPy array. Let's discuss them one by one. So first we have is initialize an array of x cross y dimension with all the values as 0. So let's check back in the Jupyter notebook. So what we need to do is initialize all the elements of x cross y array to 0. Okay, let's see how to do it. So here let's import the NumPy as np. Now here I'll be using a function zeros. Well, this function is predefined in NumPy. Well, this is used to initialize all the elements of an array to 0. Okay, so np.zeros, zeros. Inside this, it takes a list of list. So inside this, what I'll pass up here is the size of my array. Let's take the size of the array as 3 cross 4. Okay, that's it. You don't need to do anything else. Mention the size as 3 cross 4. Let's execute it. So here you got the output as 3 cross 4 matrix, 3 cross 4 matrix with all the elements initialized to 0. Okay. Now let's move ahead and see our next example. Our next example says up here is arranging the numbers between x and y with an interval of z. So let's see how. So here what we have to do, arrange the numbers between x and y with an interval of z. Okay. So let's see how we're gonna do it. Again, import NumPy as np, and the function we'll be using up here is arrange, ARANGE. Okay, inside that we'll pass 3 parameters. First the starting point, next the ending point, and next the interval. Suppose I want the interval of 2, so I'll write 2 up here. Okay, so here arrange the number between x and y with the interval of z. So here x is 1, y is 10, and z is 2. Fine. So let's execute it. So you got the output as 13579. So what is the output? So the output is all the numbers between 1 to 10 with an interval of 2. Okay. Now let's just change these numbers and see what difference does it make. We want to print all the even numbers between 10 and 20. So let's see how we can do it. So here we are printing even numbers between 10 and 20. Okay. Just to tell you, you don't need to import NumPy every time you are doing it. Okay. I'll just show up here. If you're not importing NumPy, it won't throw an error because Python is executing every statement line by line, right? So here NumPy is already executed, so I can use np up here. I'll just write np arrange. Inside this, it should start from 10, right? And it should go till 20. And the difference should be 2 as we are considering the even numbers, right? So if you see the output, you'll get all the numbers between 10 and 20. But the number 20 would not be included up here. So it's like 10 till less than 20. Okay. So you got the output as 10, 12, 14, 16 and 18. Okay. Fine. Now let's get back to our PPT. So next we have is arranging z number between x and y. So now our x and y values are fixed, but what we have to do up here is arrange z numbers in between them. Okay. So here what we are gonna do, arrange z numbers between x and y. Okay. Let's see how to do it. So for arranging z numbers up here, we have a function as linespace. So you can call np.linespace. It's not line, okay? It's lin. Don't make this mistake. Fine. And after that, what you'll do, you'll specify the first number and the ending number, that is the value of x and y, and how many numbers you want between them. Suppose I want 10 numbers between 5 and 10. So let's see what is the output. So I got the output as array of 10 numbers between 5 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Let's take one more example of line space up here. Now again, let's print some even numbers, like even numbers between 0 to 10. Okay. So here I can write np dot line space. Inside this, the number should start from 0. It should go till 10. And how many numbers I want in between? It's 0, 2, 4, 6, 8 and 10. Right? So how many numbers? 6. Okay. So let's execute it. So we got the output up here as 0, 2, 4, 6, 8 and 10. Clear? So this was about the line space function and how you can arrange z numbers between two fixed values of x and y. Okay, let's get back to our PPT. So we have already discussed these examples. Let's move ahead. Next example we have up here is filling same number in an array of dimension x cross y. So it's like I want an array in which all the elements are initialized with the same number. Let's see how we can do it. So what I want to do, filling same number in an array of dimension x cross y. Let's see. So again, I won't be importing numpy up here. I'll just write np dot. So for filling the same number, we have a predefined function as full. It takes two parameters. First, the dimension of the array, and next, the element you want to fill in. So suppose my dimension of the array is 2 cross 3. Okay, and what value I want to fill in? Let's say I want to fill all the values with 6. So let's execute it. As you can see, we got the output as 2 cross 3 array with all the values initialized to 6. Okay, let's move ahead. Next we have is filling random numbers in an array of dimension x cross y. So now what if I want to initialize my array with some random numbers? So how can I do that? Well, for that you have a random function in Numpy. Let's see how you can do it. Here we are filling some random number array of dimension x cross y. Okay, so let's see how we can do it. Okay, no point of importing numpy. So the numpy function I'll be using up here is random. I'll just write np dot random, again dot random values in an array of dimension, suppose 2 cross 3. So it will create me a 2 cross 3 array with all the random values in it. Let's see the output. So as you can see, we have a 2 cross 3 dimensional array with all the different random values. Correct? Let's move ahead. So this was all about how you can initialize a numpy array. So the very first thing we got up here is ndarray.shape. Well, this shape function is used to return a tuple consisting of array dimension. It can also be used to resize the array. Let's check the shape of our array. So what we have to do up here is inspecting the array. So in this, basically what we are doing is checking the size of the array. So let's define our array up here, like a equal np dot array. Let's define our array as 2, 3, 4, comma 4, 4, 6. Is it correct? Or am I missing something? Remember these square brackets at the beginning, right? So you have to add these square brackets if you want to avoid the errors, because you have to pass a array up here. Now I have defined my array. So now what I want to do, I want to check the size of my array. So I'll just write print a dot shape. Execute it. So you got the output up here as 2, 3. So it means it's an array of dimension 2 cross 3. Okay, so what if I just change my array? Okay, so let's just define an array like s equal np dot array Let's define an array of different dimension, like 1, 2, 3, 4. Another 2, 3, 4, 6. Let's define one more, 6, 7, 8, and 9. So what do you think would be the dimension of this array? Guess the output? Any answer, anyone? We have 3 parameters up here. Let's just compare these two values. So here we had 2 set of arrays, right? And 3 elements in each array. So while printing the shape, we got the output as 2, 3, right? 2, 1, 2, 3. So what do you think here the output will be? Well, here we have 1, 2, 3, 4. 4 elements in each array. And how many arrays we have? 1, 2, 3. So what do you think the output will be? 3, 4, right? So we'll get the output as 3, 4. Just add these square bracket in the end, okay? Execute it. At a.shape, we have to print s.shape, right? So you got the output as 3, 4, correct? Now, what if I want to resize my array? So what you're going to do up here is resize the array, right? Okay, let's see how can we do that. For that, let's just copy this array up here. Okay.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. A graph that uses vertical bars to represent data is called as A. Line graph, B. Bar graph, C. Scatter plot, D. Vertical graph. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Well, even if you don't specify it, that won't be an issue, but don't worry, I'll discuss it later. So for now, let's define the same array. And as we know, the shape of this array was this 2 cross 3, right? Now, what if I want the shape to be changed as 3 cross 2? So what I'll do up here is I'll just write a.shape and I want to change it to 3 cross 2. Okay. Now let's just print the value of a. Let's execute it. Okay. So we got the value as 234446. 234446. Okay. So it just resized the array and changed the dimension. Okay. Let's see one more example. Let's change the dimension, like 4, 4. Here let's write 2446. Okay. Now how many elements do we have? 1, 2, 3, 4, 5, 6, 7, 8 elements we have. So now I want an array of dimension 8 cross 1. So since 8 elements are only there, so 8 cross 1. So now I'll get the output as 23442446. Okay. But yeah, you cannot just write random numbers up here. It's like if you'll write 8, 2, you might get an error in this case as no elements are there. So you got an error of cannot reshape array of size 8 into shape of 8, 2. Since the number of elements that you have is just 8. So maximum what you can have is 8 cross 1. Okay. So similarly, you can also get for 4 cross 2. It will be correct. Okay. So the trick up here is, let me tell you the trick. Hashtag trick. The multiplication of these two numbers must be equal to the total number of elements. Okay. So x multiplied by y should be equal to total number of elements in the array. Okay. So 4 cross 2, 2 cross 4, or what else? That's it, right? The factors of 8 are 2, 4, 8, 1. We tried with all. Okay. Let's just change it to 8, 1. So that's the output. Got it? So this is how we are resizing our array. Fine. Next, what if I want to check the dimension of my array? How will I do that? So just now I checked the shape of my array. Now what if I want to print the dimension of my array? So how will I do that? So for that we have a ndim function. Alright, let's see how we are going to do it. So what task we have is return the dimension of the array. Okay, let's see how we'll proceed. So let's define an array as a equal np dot a range 24. So here what it did, it created me an array from 0 to 23. Okay, so now what I want to do, I want to check the dimension of this particular array. I'll just write print a dot ndim. So ndim is the function which will return me the dimension of this particular array. So what do you think the dimension of this array is? Any guess? It's 1, right? So the dimension of this particular array was 1. Now since that we have defined a single dimensional array, let's just reshape it. So here we are reshaping our array. So for reshaping, let's define another variable as b equal a dot reshape in the dimension of 2, 4 and 3. So here as a part of dimension, you can use any number whose product is 24. So for that, one trick is there. Like what you can do is first calculate the factors of 24. What are those? 1, 2, 3, 4, 6, 12 and 24 itself, right? So here what all value it can take? So here you can select only number from 1, 2, 3, 4, 6, 12 and 24. So it's like if you are selecting 1, then another would be 1. If 2, then 2 cross 3 it's 6, 6 cross 4 it's 24, right? So here we took as 2, 4, 3, or you can even take 2, 3, 4, anything. If you are taking 6, then 6 multiplied by 2 is 12 and again multiplied by 2 is 24. So you can even reshape this array to a dimension of 6 cross 2 cross 2. Okay, let me just print the dimension of B and show you the output. So what is the dimension of B array? Let's see. Ndim, execute it. So here we got the output as 3. This is from the previous thing only, just remove it. So here the dimension of B is 3 dimensional array, right? If you change it to like what? Let's change it to 12, 2. This will work, right? And the dimension of this array would be 2, right? It's a 2-dimensional array. Okay, got it? So basically in reshape up here, what we are specifying is the value of x, y and z coordinate. Okay, since we are not specifying any z coordinate, so it's a 2-dimensional variable and the value of x is 12 and the value of y is 2. So we need a 12 cross 2 matrix up here. Let's even print B. Let's see what we get. So you will get the output something like this. So 12 in a column and 2 in a row. Okay, so now you know how to find out the dimension of any array and how you can reshape any array to your need, right? Let's move ahead. Now, what if I just want to return the number of elements in an array? How will I do that? So find the number of elements in an array. Let's see. We have already defined an array A up here, right? Here's array. Here's array. A equal np dot a range 24. So our array A consists of 24 numbers that we already know, right? Now, how do we find the number of elements in an array? So up here we have already defined an array as A equal np dot a range 24. Okay, so here we already know that number of elements in our array is 24 since we are only defining it, right? So what if you get a scenario in which you don't know how many elements are present in the array? So for that we'll be using size function up here, right? Let me just verify how size function work. So currently you know how many elements are there in A, right? It's 24, you have only defined it. So in order to find out the number of elements in an array, all you need to do is use a function size. So name of the array A dot size. That's it. Execute it. So we got the output as 24 and it's verified. So even you have initialized the array with 24 elements, right? And this function has verified this. What if I just change it? Let me just show you. Let's change it to 25. Let's remove this. Okay, let's print our size. Well, the output up here would be Any guess? 25 obviously, right? Okay, so this is how you count the number of elements in your array. Let me just take one more example. Let's define an array as a equal 1, 2, 3, 4, okay, comma 3, 4, 5, 6, comma 2, 3, 7, 9. Okay, so this is my new array. Let's name it as D. Okay, now let's print the size of D. How many elements are present in D? D dot size. So let's see what's the output. So we have to define a tuple up here. Okay, tuple object has no attribute size. Let's take one more example up here. So here let's define our array as D equal np dot array. Inside this, let's define few arrays like 1, 2, 3, 4, 5, 6 and 6, 7, 8. Okay, now let's just print d dot size. So this will return the number of elements present in D, and the output is 9, 3, 3, 3. Okay, well, what if I just add one more element up here like 8, 9? So what should be the output? Should be, so once we added 9 up here, we got the output as 3. Well, I know you are wondering that we'll be getting the output as 10, right? So here we don't have an equal number of elements in the array, right? So in this case, if you print d dot size, what it will return? It will just, so in this case, if you print d dot size, what it will return? So it will just return how many number of rows are there in your array. Okay, so how the size is working, it's multiplying the number of rows to the column. Okay, so if I remove 9 from here, so what we have is 3 cross 3, 3 rows and 3 columns, right? So 3 cross 3 is 9. So that's how it's calculating the value 9 up here. If you change the value of 4 here, again 4, and again add some value as, let's say 9. Okay, so in this case, what value you will get is 4 cross 3. 4 cross 3 is 12. So total number of elements in that array is 12. Okay, so this is how you count the number of elements in an array. Fine. Now let's just get back to our PPT and see what's left. We discussed this. Yeah, we already discussed how you can change the dimension of an array or resize it. Then another example, this also we discussed. Next, counting the number of elements in an array. We just did it. I'm assuming all these things are clear to you, right? In case you have any doubt, feel free to reach out to us and we'll make sure that the doubt is clear to you within 24 hours. Okay, so next we have is we want to find the data type of the array. So let's see how to do it. So here we have is find the data type of the array, right? So let's take an example up here. So let's define our array as a equal np dot arrange 24 numbers, and each of data type, for that I'll write d type. So what's the data type? Let's say all are of float. Okay, let's check print a dot d type. So it's a float, right? Now what if I just remove it? What if I just write np.arange 24 and print the data type for that? So here we'll get int 32 values. So in this case, if you print the values of a, you are getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on, right? And just if you change the data type using d type equal float, so all you'll be getting is 0 point something, 1 point something. So you got a float value up here. Okay, and even the data type which we are printing up here changed from int 32 to float 64. Correct? Okay, so this was all about NumPy array inspection. So first we have is addition using NumPy. So for performing some addition, we have a sum function up here. Let's see how does it work. NumPy array mathematics. And in this, we are learning about addition. Okay. Import numpy as np. You can write any name apart from np. If you write na, that is also fine. We are just following the convention and writing np up here. Okay. So now what if I want to find the sum of two numbers? So what I'll do, I'll call the sum function. So I can call np.sum. np.sum, inside that sum of two numbers. What are those two numbers? 10 and 20. It will just give me the result as 30. As simple as that. You can even use a variable, like using a variable. So let's define a comma b equal 10 comma 20 and np.sum. I want a sum of a plus b using a variable, that is sum of a plus b. Okay, so np.sum a comma b. Execute it. What error did we got? Access 20 out of bounds for array of dimension 0. So always remember, whenever you are writing some parameter inside the sum, make sure that you are placing them inside the square brackets. Okay, as the sum function only takes the array of values. Okay, so now if I execute it, the error would be resolved. Okay, so we got the value as 30. Now what if I want to find the sum of a particular axis? Like I have a 2x2 matrix, and inside that I want to find the sum of just my first axis or just my first column. Let's see how we can do it. So here let's define np.sum. Inside that, let's pass some array like 1 comma 2 and another array like 5 comma 6. Okay, so now what if I want to print the sum of 5 plus 1 and 6 plus 2? So in that case, I'll just mention like axis equal 0. Okay, so you'll get the output as 6 comma 8. 5 plus 1 6 and 6 plus 2 8. Now what if I want to print the value of 1 plus 2 and 5 plus 6? So in that case, np.sum array of 1 comma 2, same number, nothing need to be changed, just the axis value would change. Okay, 5 comma 6. Now specify the axis value as 1. This is the only change that you have to do. So here you'll get the output as 3 and 6 plus 5 11. So you got the output as 3 comma 11, correct? Now what if I don't specify the axis up here? So what values do you think I'll get? What if I remove this? Let's see. So I got the value as 14. How? So it summed up 1 plus 2 plus 5 plus 6. So it gave me the entire sum of all the elements of the array. That is 1 plus 2 plus 5 plus 6. That is 14. Okay. Similarly, like sum, we have other important function up here like subtract, divide, multiply, exponent, square root, sine function, cos function, log function, and many more. Let's see some of them. Now let's copy up this title, Numpy array addition. Here what we are performing, let's change it to subtraction. Now to perform subtraction, we have a method as, so we have to call the function subtract. Let's see an example like np.subtract. What do you want to subtract? Like any value like 10 comma 20. So we'll get the output as minus 10. 10 minus 20. So you got the value as minus 10. Okay. Similarly, what if I want to find the multiplication of two numbers? I'll just write np.multiply 2 comma 3. Let's take two number multiplication of two number.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customers says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also the course material is structured in such a way that it covers all the basic till the advanced level of concept that even a non-computer science background student can easily understand the concept.
Now let's continue with the session.
So we'll get the output as 6. Let me just add one more heading up here. All other Numpy mathematics function. So inside this we saw for multiply. Now let's check out for division. So for dividing two numbers, we have function as divide. So np.divide. Divide what? Let's divide 10 by 5. Here we are dividing two numbers. Okay, let's execute it. So we got the result as 2.0. Okay, so here all the operation that we perform with sum can also be performed with subtract, multiply, divide, or anything. Okay, it's like here we use a variable. So here we are summing up two array with axis 0. Here we are summing up axis 1. So all those function can even be done with np.subtract, np.multiply, or np.divide. Let me just show you with one example. Let's just copy it and let's paste it up here. So instead of sum, let's change it to divide and execute it in valid number of arguments. Now let me just show you how you can divide two arrays. So let's define two array up here, like a equal np.array. It consists of 2, 4 and 6. Okay, and other array b equal np.array. Inside this I'll pass 1, 2, 3. Now let's divide array A with array B. So np.divide array A with array B. Let's see what result do we get. So we got the divided result of two different arrays. Fine. Similar operation we can perform with multiplication. So you got the value as 2, 8 and 6 3s are 80. Okay. So we also have other function as exponent, square root, sine, cos and log. So let's see them one by one. So all you have to do is change the function. So we have exponent function for calculating the exponents. So we have exp function for calculating the exponents, sqrt function for calculating the square root, sine function for finding out the sine value of an array, similarly cos function for finding out the cos value of the array, and similarly log function to find out the log value of the array. Let's see them one by one. Again, so there's our array, we have already defined it. So let's use all these functions one by one. Print np.exponent of a. Okay, execute it. So this is the exponent of a, that is e to the power a. Okay, e to the power 2 is 7.38, e to the power 4 is 54.5, e to the power 6 is 403.42. Okay, let's just copy this function and let's find the square root of all the elements of a. So sqrt. So this is our square root. Let's add one more thing. This will make things more clear. Square root, and here it was exponent. Fine, copy this. Now we'll calculate the sine. Sine is np.sine value of a. Again we have to check for cos. So cos is np.cos, and finally log. So we have log as np.log. Okay, execute it. So we got all the values of here. Exponent is this, square root is this, sine of 246 is this, cos of 246, log of 246. Okay, so these are some of the mathematical function that you can perform using NumPy. So let's move ahead. Let's go back to our PPT. So we already discussed this part, and we also learned about all these different types of other functions that you can perform, and we also discussed about the error that you might get. So let's move ahead. So next we have is the array comparison. So in this we have element wise comparison and array wise comparison. Let's see them one by one. So here we have is array comparison. Okay, so let's define 2 or 3 arrays. Okay, so a equal like 1, 2, 4. Let's define b equal 2, 4, 6, and let's define one more, c equal again 1, 2 and 4, same as A. Okay, so now let's use NumPy to perform a element wise comparison of these arrays. So for this I'll write np dot equal, let's write A comma B. So it will compare 1 with 2, 2 with 4 and 4 with 6. So if these two elements are equal, it will return true. In other case, false. So for now, what output do you think we'll get? Well, for now, all the output would be false, right? As 1 is not equal to 2, 2 is not equal to 4 and 4 is not equal to 6. But what if we change this B to C? So in this case, you'll get all the true values. Just for understanding, just change this 6 to 4. Now let's compare A with B. So in this case, we have last as true. So these two are false and 1 is true. So 2 false and 1 true value. So 2 false and 1 true. Correct? So this was about the element wise comparison. Okay. Now next we'll see. Now next, let's perform a array-wise comparison. Okay, let's just copy them. Okay, now in this, I want to compare the entire array. If all the elements of array A equal to all the elements of array B, then only in that case we'll get the output as true. In all the other case, we'll get the output as false. Let me just show you with this example. So np dot array underscore equal. So this is the function that we are going to use for comparing two arrays. So like this, compare A and B. Even if one of the element is different, we'll get the output as false. So here we got the output as false. See, executed false. So here what we have, A 124 and B 144. So we had two elements equal in A and B, right? Just 2 and 4 were different. And even then we are getting false. What if I just change the value to C? So in this case, you'll get the output as true. Correct? So this was about array-wise comparison. So now that we have learned how to compare two arrays, both element-wise and array-wise. So let's move ahead and see what we have next. So we are done with this example. Next we have is the aggregate function. So under this, we'll see how to perform various statistical calculations on the array. Okay, let me show you with an example. Aggregate function. So here, let's again copy paste the value of A, B and C. So in aggregate function, what all things we can do? We can perform an array-wise sum, or we can find the minimum value of an array, or the mean of an array, the median or correlation coefficient of an array, or even the standard deviation of the array. Alright, let's print all of them one by one. So here I want to print my sum. So print np dot sum of array A. So it will give me the sum, right? 4 plus 2 plus 1, that is 9. Wait, just to clarify it, sum is this. Then let's print the minimum value from the array. So our minimum value is np dot min of A. Now let's print the mean value. So mean is np dot mean of A. It's as simple as that, right? Print median is np dot median of A. Then print correlation coefficient is np dot correlation coefficient of A. And finally the standard deviation. Standard deviation is what? It's np dot std of A. Okay, so let's execute it. So we got the value as sum 7, minimum value is 1, 1 to 4, correct? Mean is 2.33, that is 4 plus 2 plus 1, that is 7 by 3, 2.33. Median is 2.0. Correlation coefficient, that is 1, and standard deviation is 1.24. Okay, so this was about the aggregate function. Let's come back. So next we have is Numpy Broadcasting. So let's see what exactly is. For example, we have two array with different dimension, right? but make sure the number of rows or number of columns are same. Okay, so in this case what we have is same number of element in each array. Okay, so it's like when you add first array to the second array, what it does, it simply adds it. Like, so here you can see we got as 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2. But here again, 10 plus 0 is 10, 10 plus 1 is 11, 10 plus 2 is 12. So similarly, what it did, it broadcasted this value and add all these values to different rows of this array. Okay, so same values being added to this row, this row, this row, and this row. Okay, so this is the concept of broadcasting, as this particular array is broadcasted and summed with all the element of this particular array. Let me just show you with an example. This is concept of broadcasting. Okay, let's import numpy as np. Let's define an array as np.array. Inside that, let's place few values, 0, 0, 0, then 1, 2, 3, then 4, 5, 6. Let's take one more. Let's take it as 5, 6, 7. Okay, now let's define another array b equal np.array. So in this, let's specify a number like 0, 1, and 2. So this is the number which will be added to 0, 0, 0, 1, 2, 3, 4, 5, 6, and 5, 6, 7. And this is the concept of broadcasting. Okay, let me just show you. Print first array. First array is what? A, right? Change the line. Then print the value of second array. And then print the value of first array plus second array. That is A plus B. Okay, execute it. So here we got the output as first array is this, second array is this, and first array plus second array, you can see that 0, 1, 2 is added to all these numbers. Fine. So this was the concept of broadcasting. And with this, we come to the end of NumPy array mathematics. Array manipulation in Python. So as a part of array manipulation, so we have concatenating two arrays together, stack array row-wise vertically, stack array column-wise horizontally, and combining column-wise stacked array. Let's take an example in Jupyter Notebook and learn them one by one. So here we're going to start about array manipulation Python. Okay, so first of all, let's define two arrays. Let's take a equal np.array. Inside this, let's say 1, 2, 3. Okay, so this is my array A, and b equal np.array 4, 5, and 6. Okay, so first of all, we'll see how we can concatenate these two arrays. So first is concatenation of two arrays. So for this, we have a function concatenate under NumPy. So we'll just call it np.concatenate. We'll just write A and B. That's it. So here you got the output as 1, 2, 3, 4, 5, 6 in all the element in a single array. So therefore what it did, it concatenated both the array A and B into one. Okay, so next we have is stack array row wise, that is vertically. So stack array row wise vertically.
Test your knowledge of data analytics by answering this question. Which of the following is not a major data analysis approaches? A. Data mining. B. Predictive intelligence. C. Business intelligence. D. Text analytics. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Okay, so again for this we have another function in NumPy as vstack. So just take two parameters, the name of two arrays A and B, execute it. So as you can see, my two arrays are stacked one above other vertically. Here one more thing I have to say, like if you want to stack array row wise but in a horizontal fashion, so it's again same as your concatenate function, but here we have another function as hstack. and even this takes two parameter a and b, and it's quite similar to the concatenate function. It'll give you the same result. Okay, so this was about hstack. So till now we discussed about concatenating or stacking row wise, right? Now what if I have to combine column wise? So let's see here, combining column wise. So for this I have a numpy function column underscore stack. So let's call it np dot column underscore stack. Inside this, let's pass our arrays a and b executed. So here you can see that my array a and b are stacked in a columnar fashion. Okay, so this was about combining column wise stacked array. Okay, so let's get back to our PPT and see what is the next topic. So next topic in array manipulation in Python we have is splitting array. That is, what if we want to perform some horizontal split or vertical split in the array? Let's see how to do it. So for this, let's define an array. Let's take x equal np dot arrange 16 numbers and reshape this 1D array in the dimension of 4 cross 4. Okay, let's print x and see our array. So this is our 4 cross 4 array consisting of numbers between 0 to 16. Now what if I want to split my array horizontally from here, this point, such that my first array contains 0, 1, 4, 5, 8, 9, 12, 13 and my next array contains 2, 3, 6, 7, 10, 11 and 14, 15. Let's see how to do it. Well, for this we have another function as hsplit. Let me just show you. Print np dot hsplit. Inside this you have to pass your array and define from which position you want to split. I want to split it from second, like there's my 0th index, first index, my second index. Okay, so I want to perform a split from this point. Okay, so let's see the output. Let me make things more clear for you. Let's add a new line up here, horizontal split. After performing the split, so here you can see that I have two arrays. First array is this, consisting of 0, 1, 4, 5, 8, 9 and 12, 13, and my next splitted array consists of the rest half, that is 2, 3, 6, 7, 10, 11 and 14, 15. Okay, I can even perform some customized split over here. Let me show you some example, like print np dot hsplit start from x and until np dot array 3, 6. So let's see what's the output, but before this let's add some new line. Let's check the output. So here we got two arrays, right? First one is this 0, 1, 2, 4, 5, 6, 7, 8, 9, 12, 13, 14, and the next one is the last column. Okay, so here let's split it from this point such that 0, 1, 2, 4, 5, 6, 8, 9, 10 all are these in, so all of them are in one array and rest of them, that is 3, 7, 11, 15 is in different array. Okay, so let's do it. Np dot horizontal split and just write x comma np dot array. So here you will get the output as this. Okay, now from this example, what if I want these two columns together and this entire column has a separate array? So I want 3 arrays in total, so I just have to make a little change in it. Just write 2 comma 3, that's it. So it's like np dot hsplit x comma np dot array second and third column. So here I got the output as this. This is my first array, this is my second array and this is my third array. Okay, so guys, this was all about splitting arrays and array manipulation in Python. Indexing and slicing in Python, and we'll see how to select certain elements from the array. So let's start with what exactly is indexing and slicing. Well, indexing just refers to a position. For example, if you are storing some numbers or a string in an array, so each cell of an array has some index number associated to it. For example, the image shown on your screen represents an array in which each cell has a different character. So we have Monty Python stored in an array. So here index number of m is 0, 1 and so on till n is 11. So this is the index number when you are going from top to down. Okay, and suppose if you directly want to extract the last character from the string and you don't know what is the length of the string, so in that case you can use the negative index number. It starts from -1 at the end and goes till minus 12 at the beginning. Let me just show you an example and make things more clear to you. So this is our Jupyter notebook. So let's define an array a equal Monty Python. So each character is stored in a different cell. Okay. So now what if I want to extract Monty from here? So how will I do that? A of Monty, that M starts from cell number 0 and it will end till MONTY 0, 1, 2, 3, 4 and 5. So before the colon we write the part which is included. So M is included. So after the colon, that is cell with index number 5 is not included. So just before 5. So it's like 0 to 4. Let's see the output. So here we got the output as MONTY. Now what if I want to extract, let's say, these characters? Start from 0, 1, 2, right? Start from 2, ends at 3, 4, 5, 6, 7, 8 and 9. So I'll just write 0, 2. Start from 2 and end before 9. So this was my requirement and I got the output as NTY-PYT. So this was a very basic example of indexing and slicing in Python. Let's move ahead to learn more about it. So let's learn how to slice a 3x3 dimensional array with the numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9 stored in them. Okay, so let's learn how to extract or slice the array. So what if I want to extract the selected element? So here my selection is in first row, right? That is 0th index. So I can directly extract with A of 0. So if I write A of 0, this includes all the element from the first row. That is 1, 2, 3. But when I write colon 1, it means you don't have to include 1. That is whatever part comes after colon, we have to exclude that part. That is, we have to take number just before that. That is, if colon 1 is there, so we'll take till 0. And this will extract the first row from the array. The first one, it extracts all the elements from the first row. And next one, it extracts the first row from the entire array. Next, what if I want to select these elements? So here my selection is in the first row, right? That is 0th index. So if I write A of colon 1, now how to extract this selected element? Well, in this, I know that my selection lies in the first row, right? That is 0th index. Now I'll write A colon 1. So what it will do, it will extract the entire first row or extract till row equals 0. Only this row will be extracted. Next, I don't want to include the part of 0, 0. So I want my selection to start from column 1. Okay, so I'll write 1 colon up here. So after writing 1 colon, what it did, from the 0th row, it then selected the column index starting from 1 till last. And therefore we got a selected value. Let me show you this example in my Jupyter notebook. Let's define an array. Let's say A equal np.array. Inside this, 1, 2, 3, 4, 5, 6 and 7, 8, 9. Okay, so let's extract the first array from here. Let's extract first array. So we saw A of 0. A of 0 gives us all the element from the first row. Next, if I write A of colon 1, so this will extract the first array. Fine. Next, what if I want to extract 2, 3 from here? Okay, first let me just show you the entire array. So this is our array. Now I want to extract 2, 3 from here. So how I'll write A? First select the entire row. So 2, 3 lies in first row, right? So I have to select the entire row. Then it should end at 2, 3. Then my 2, 3 starts from column number 1. So I'll write 1 and 1 till last. Okay, execute it. So you'll get the output as 2, 3. Go back. Now if this is our requirement, so how to extract the selected element? So in this, my selection lies in first 2 rows, right? That is 0 and 1 index. So here, if I write A of colon 2, so this will extract both the row 0 and the row 1, okay? But now I want my column number to start from 1. So I'll just write colon 2 and start from 1 till end. Okay, let me show you this as an example. So there I wanted to extract 2, 3 and 5, 6, right? So let's see how can I do that. So A of 2, 3 and 5, 6. These numbers or the selection lies in first 2 row. So starting from 0 before 2, that is till 1. So select all the rows from 0 to 1. Then in the column part, the column starts from 1, right? 0, 1, 2. So it will start from here, right? So it should start from 1 and it can end till last. So let's execute it. So in this case, we'll get the output as 2, 3 and 5, 6. 2, 3, 5, 6. Clear? let's move ahead. Again, same example. This one you can work it out on your own. Can you say what's the answer for this? Okay, let me give the solution of this. So a of 1 colon comma. So what does it mean? Start from row number 1. So this is our row number 1 till end. So include everything from here. Okay. So we have a of 1 colon comma. Okay. So what does it mean? So it means extracting starts from row number 1 till end. So this is my row number 1 till end. So this will include all of these values 4, 5, 6, 7, 8, 9. Okay. And it should continue till 1 colon, which means after extracting all the elements from row number 1 till the end, that is row 1 and row 2, when all these elements are included, from these elements I want to start from colon number 1, that is from here till the end. So the output what I'll be getting is 5, 6, 8, 9. Let me just show you. So I want to extract 5, 6, 8, 9, right? So a of here 5, 6, 8, 9. So these lies in first and second row, right? So row it should start from 1 and till last. Okay. And my column 5, 6, 8, 9. It start from first column, right? 0, 1, 2. Even the column should start from first and till last. So here I'll be getting the output as 5, 6, 8, 9. So here are a few more examples that you can try. And we also discussed about several functions from the NumPy. So now a question might arise in your mind, like what is so special about NumPy arrays? So why can't we use simple Python list for these scientific computation? So let's move ahead and see what are the benefit of using NumPy array over the list. So NumPy array consumes less memory when compared to a list, is also faster and more convenient as compared to a list. Okay, let me just take few examples in my Jupyter notebook and show you how exactly it consumes less memory, how it is faster than a list, and how it is more convenient than it. Okay, so let's just get back to our Jupyter notebook. Advantages of NumPy over a list. So first, let's compare NumPy and list on the basis of their memory size. NumPy versus list parameter is memory size. So for this, let's import NumPy as np and again import syslibrary. Now let's define a list. So let's say there's our list L equal range list has 1000 numbers in it. Okay. Let's print the size of it. So print sys.getSize of any integer between 1 to 1000. For example, I can take 1 over here. Size of any integer multiplied by how many total integers are over there? 1000, right? So either you can write 1000 or you can write length of L. Okay. Now I need to compare it with NumPy array. So let's define a NumPy array. So let's say our NumPy array A equals np dot arrange 1000 numbers. Okay, again print a dot size multiplied by, you can directly write 1000 over here or you can use a dot item size. Okay, let's execute it. Let's modify our code a bit. Here size of a list and here size of an array. So we got the output as 28,000 as the size of the list and size of the array is 4,000. Okay, so from here I can say that storing a NumPy array occupies less memory when compared to a list. Okay, so now that we have compared their memory size, now let's compare NumPy and list on the basis of their speed. So NumPy versus list on the base of their speed. For this we have to import another package, import time. We have already imported NumPy as np up there. Now let's create a function. Here I'm defining function as using list. Let's define our starting time t1 equal time dot time. Okay, now let's define a list x as x equal range of 1000 numbers, and let's define another list y as range of 1000 numbers. Let's make them 10,000. Okay, this way we can check the speed of their processing in a better way. Okay, now let's add all the element of each list. So z equal x of I plus y of I for I ranges in length of x or length of y or maybe 1000. Okay, length of x or y anything, or you can just write 1000 up here. Okay, so this is my z, and from this function what I want, return time dot time minus t1. Now here this t1 was the initial time, right? And now this time would be the process time, that is time after executing this statement, right? So if we subtract this time minus the initial time, we'll get the total time taken to process this particular line. Now let's define another function. So define using numpy. Same, define the starting time. Wait, let me just add some comments up here. Starting or the initial time. This is also the starting of the initial time. Next, let's define a numpy array. Now x equal np dot arrange 10,000 numbers. Okay, and b equal np dot 10,000 numbers. Now for the processing part, what I want to do, I want to take the sum of both a and b. Z equal just a plus b. It's as simple as that. And this is how it is more convenient than a list. More convenient than a list. Okay. Now again, what I want from here, return time dot time, that is time after things are processed, that is this particular statement is processed, minus the initial time, that is t1. Okay, now let's call these two function and store their output in two variables. Let's say list time equal using underscore list, and numpy time equal using numpy. Okay, and then finally let's print them. Print list underscore time comma numpy underscore time. And one more thing you can add up here is, like in this example, numpy is string value of list time divided by numpy underscore time, that is the time taken to execute the numpy array, this many times faster than a list. Okay, fine, let's execute it. The name using underscore list capital. So for this example, we got the processing time for list is 0.00199, while for numpy we got 0.00099. So in this example, numpy is 1.99 times or almost 2x time faster than a list. Okay, so this is how a numpy is faster than a list, and here I showed you how it is more convenient than a list. So I hope these things are clear to you.
What is Scipy? Well, Scipy is a free and open source Python library which is used for scientific and technical computing. Okay, it contains module for optimization, linear algebra, integration, interpolation, special functions, Fourier transformation, signal and image processing, and other scientific computations which are most common in science and engineering. This library is built upon NumPy to make the scientific calculation more efficient. But before we actually move ahead, there's few special characteristics of Scipy that you should be familiar with. So let's move ahead and discuss about some of the characteristics of Scipy. So first of all, it contains toolboxes dedicated to common issues in scientific computing. Secondly, Scipy offers different submodules for different applications. Third is, it operates very efficiently on NumPy. We can say NumPy and Scipy works hand in hand. Okay. So fourth is, it adds significant power to the interactive Python session by providing the user with high-level commands and classes for manipulating and visualizing the data. Finally, Scipy routines are tested and optimized. Therefore, Scipy should be used whenever possible. Non-programmer scientists face difficulties while performing scientific calculations in large real-world data. So this issue can be resolved very efficiently with the help of short and simple codes offered by Scipy. So this was about some of the characteristics of Scipy. So till now we know what exactly is a Scipy and what are its various characteristics, right? So let's just move ahead and see what are the various sub-packages or sub-module that this library has to offer.
Okay. So these are the various sub-packages which are a part of Scipy. So first of all, we have something called scipy.clusters, which comes in handy while dealing with vector quantization or k-means clustering. Second, we have is scipy.stats, which is generally used for statistics. Then comes scipy.optimize, which is used for minimizing or maximizing objective functions. Another very important sub-package is scipy.integrate. This is useful while dealing with different integration routines. Then we have scipy.linalg, which is generally used to perform linear algebra routines. And finally, we have scipy.fftpack, which is used for fast Fourier transform. Okay, so these are the various sub packages which are available under Scipy. So in our next session, we'll deal with them one by one in detail. Okay, why do we use scipy.cluster? Well, this sub package is very useful when we have to divide the dataset into cluster based on some attributes. So in the k-means function, we have to pass the data and the number of clusters that we need to divide them in as the parameter. Now a question might have popped into your head, right? Like what exactly is this clustering? So let's discuss that first. So let's say we have a data set that looks something like this, and you want to group them into two clusters, the green and the blue cluster. So from here you can say that clustering is the process of grouping similar items into one single group. For example, you can say that we have selected two clusters over here, right? So all the data points in green cluster are completely different from all the data points in the blue cluster. Okay, but all the points within the green cluster are quite similar to each other, and same is the case with the blue cluster. Okay, so summarizing it, you can say that clustering is a process in which the data points are clustered into groups. The data points within one cluster are quite similar to each other, but when you compare it to the data point in different cluster, it's completely different. There is no similarity between them. Okay, so now the question arises, how to calculate this, or how can we create this cluster? Okay, so let's see how to create this cluster. So how do we find cluster? So first of all, we randomly pick two different cluster centers. Okay, then as a step 2, what we'll do, we'll assign our data set into two clusters based on minimum distance to the cluster centers. Fine. Then we'll calculate the mean distance of each member in the cluster. Then as a step 4, what we'll do, we'll shift the cluster center towards the mean, and we'll consider that two mean values are the new cluster centers. Okay. Then again we'll repeat step 2 and step 3 until no member changes the group. Okay. So I hope you got an idea of clustering from this. So let us discuss with the help of an example to make it even more clear. So let's say we have a data set in which we have coordinates as x, y, distance k1, distance k2, minimum, and cluster. So these are our attributes over there. Distance k1 is the distance between the point and the centroid of cluster 1, and distance k2 is the distance between the point and the centroid of cluster 2. So let's say we have a data set 1, 1, 2, 2, 4, 4, 5, 5 and 6, 6, and we need to divide them into two different clusters. So first of all, we'll randomly pick two cluster center or centroids. Let's say k1 equal 3, 3 and k2 equal 5.1 and 5.1. Okay. Then what we'll do, we'll calculate the distance from each point to k1 and k2. And based on the minimum distance, we'll assign them the clusters. Okay. So for example, the distance from 1, 1 to k1 is 8. But that to k2, it's 33.62. So clearly here minimum distance is 8. So our first point goes to cluster 1. From the point with coordinate 2, 2, so the distance from k1 is 2, but to k2 is 19.22. So this also belongs to cluster k1. And similarly, we'll find the distance for rest of the point, and based on minimum distance, we'll put them into the different cluster. Okay. So now after assigning the cluster, it looks something like this. So cluster 1 has the point with coordinates 1, 1, 2, 2 and 4, 4. And cluster 2 have the point with coordinates 5, 5 and 6, 6. So our next task would be to find the mean of all the members in a cluster. Okay. So the coordinate of mean of cluster 1 is 2.33, 2.33. And the coordinate of mean of cluster 2 is 5.5 and 5.5. Okay, so now consider the coordinate 2.33, 2.33 and 5.5, 5.5 as new k1 and k2. Okay, again find the distance of each point from k1 and k2. Then based on minimum distance, put them in clusters. Okay, now repeat these steps until no member changes the cluster. So in this example, we had very less number of data. So the whole calculation with repeating steps doesn't look that annoying, right? But what happens if the data set is large, right? That would be too hectic task for you to calculate it manually. So now to reduce this computational complexity, we have scipy.cluster. Okay, now let me show you how you can use it in Python. So to perform clustering operation, we'd be needing some data. So here I have imported some car dataset using pandas. Okay, so my dataset consists of 11 columns and 32 rows. And all these 32 rows consist of different numerical data. Okay, here in this slide, I have just shown first 13 rows of the dataset. So as you can see here, my dataset consists of MPG, cylinder, displacement, horsepower, DRAT, weight, QSEC, VS, AM, gear, carburetor, right? So now we'll be using this dataset to create the cluster. Okay, so import pandas as PD, data equal pd.readExcel, inside that the name of the file. So this is how you can import the data. Okay. So now to perform clustering operation, we first need to import k-means and vq from the scipy.clustering subpackage.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customers says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also, the course material is structured in such a way that it covers all the basic till the advanced level of concept that even a non-computer science background student can easily understand the concept.
Now, let's continue with the session.
Then we'll pass our data and the number of cluster that we need in k-means function. In our case, we need 3 clusters, right? So this k-means function will return the array of 3 centroids. Okay. So after we get the centroids, we'll pass our data and the centroids into the vector quantization function, which returns an array of cluster index values for each record. So let's see the output. So as you can see from the array of cluster index, our dataset is divided into 3 different clusters. It was simple, wasn't it? But there's a common pre-processing step for machine learning algorithm called the data whitening. We need to perform data whitening when we use features that represents different characteristics and are on very different scales. So which we are going to see in our dataset. Okay. So we'll now see if there is any change in the cluster after we perform whitening. Well, again, to perform data whitening, we'll be importing whiten from scipy.cluster.vq. Then after importing the data, we'll pass the dataset into the whiten function. Then repeat the same steps to find the centroids and the array of index. Now comparing to the array of cluster index, you can see that many of them has been changed, right? In this and in this. So this is why we need to perform data whitening before passing the data into the k-means clustering function. So this was all about scipy.cluster. Okay.
So pandas is an open source Python library which is used for manipulating one-dimensional and two-dimensional data. And the name pandas is derived from panel data, which is a common term for multi-dimensional datasets encountered in statistics and econometrics. Now let's look at the types of data structures in pandas. So we've got one-dimensional and multi-dimensional data. So if you're working on a one-dimensional data set, it is known as a series object. And the two-dimensional data object is known as the pandas data frame. And if you're working on higher than two-dimensional data, pandas would create a panel data for you. So let's properly understand what exactly is a series object. Well, a series object in pandas is a one-dimensional labeled array which is capable of holding mixed data types like integer, string, floating point number, and so on. Now let's understand about data frame. So a data frame is a two-dimensional labeled data structure with columns which contain data of different types. So here we see that we have a two-dimensional data frame where the first and the third columns are of string type and the second column is numerical in nature. So now that we've understood what exactly is pandas and we've also understood the different types of data structures in pandas, let's go to Jupyter and start working with pandas. So I'll start off by importing the pandas data frame. So I'll type in import pandas as PD. So this PD which you see, this is just the alias. So I am importing pandas with the alias PD. So we have successfully imported this pandas data frame. Now I'll go ahead and create a series object from a list. So let's say I will name the list as data and I will give in these values. So the values inside these lists are 1, 2, 3 and 4. Now to create a series object from a list, all we have to do is use this pd.series function. So I'll use pd.series and inside this I will pass in this list and I will store this in S1. Now let me print this out. Right, so we have successfully created our series object from this list. So we've got these 4 numbers and these are the index values. So what you see over here is the indexing starts from 0. So 0, 1, 2 and 3, these are the index values and these are the actual values. Now let's see how can we change the index of this series object. So I'll just copy this over here, paste it over here again. So we have got the index attribute over here. Inside this, what I'll do is I will give in different set of values. Now let's say I want the index values to be A, B, C and D. So I'll just pass in these values for the index parameter over here and I'll store it back to S1. Now let me print S1 over here. So we have successfully created a series object where the index values are A, B, C and D. Now if we want, we can actually extract these individual elements with these index values. So let's say I want to extract the value which is present at the index value C. So I'll type in S1, I'll put in parenthesis and inside this I'll put in C, right? So I've successfully extracted this value. Similarly, let's say if I wanted to extract the element which is present at index A. So I'll type in A over here, right? Now let's say if I want to extract the first 2 elements. So if I want to extract the first 2 elements, I'll just put in a colon over here. I'll put in 2, right? So I've extracted the first 2 elements. Similarly, if I want to extract the last 2 elements, I'll put in a colon and over here on the left side of the colon, I'll put in -2. So this is how we can extract the last 2 elements from the series object, right? So we have created a series object out of a list. Now let's go ahead and create a series object out of a dictionary. So let me create my dictionary over here. I'll name this as D1. I'll put in curly braces over here. Now I'll create my dictionary. So I'll just start off by assigning the key value pairs. So A, 1, after that B, it is 2, after that for C, it is 3, and after that for D, it is 4. Right? So I have successfully created my dictionary over here. Let me also print this out. Right? So these are the key value pairs. Now, again to create a series object out of this, I will type pd.series and inside this I will pass in the dictionary which is D1 and I will store this in S2. Now let me print out S2. So this is my series object over here, right? So all of the keys have been assigned as the index and all of the values are the actual values in the series object, right? So A becomes the index value over here, B is the index, C is the index, D is the index, and the value corresponding to this key becomes the value in the series object as well. Now let's say if I want to resequence the index values over here, let's see how can we do it. So I will copy this and I will paste it over here. Now again I will use the index parameter and inside this, let's say instead of A, B, C, D, I want the sequence to be D, C, B, A. So that is what I'll give over here. D, C, B, and A. Now let me run this and let me just print out S2 over here, right? So we have reversed the sequence of these indices. So initially it was A, B, C, and D. Now I have reversed it and now it is D, C, B, A. Right, so this is how we can create a series object out of a data frame and also change the sequence of these indices. All right. So we have work with series. Now let's go ahead and see how to create a data frame out of a list. So I'll just write a comment over here. Creating data frame from a list. Right. So let me again go ahead and create my list. Data equals 1, 2, 3, and 4. Right. So I have created my list. Now I'd have to go ahead and create the data frame. And to create the data frame, this would be the syntax. So I'll type in pd.data frame. So over here, you have to keep in mind that D is capital and F is capital, right? And inside this, I will just pass in this list and I will store this in df. Now let me print this out, right? So we have successfully created a data frame out of this list. Now let's also go ahead and create a data frame out of a dictionary. So I will type in fruit over here. So the name of the dictionary is fruit. And over here, I will write the key to be equal to fruits. And the values for this key are, so we've got all of these fruits. We've got apple, we've got mango. After that, we've got banana. And finally, we've got guava. So this was the first key value pair. After that, I'll give in the second key value pair, which would be the count of the fruits. So I'll type in count, and over here I will just set in the count. So let's say there are 10 apples, 20 mangoes, 40 bananas, and 30 guavas. Right, so we have created a dictionary. Now let me print this out. Now let me also go ahead and create a data frame out of this. So you already know we'd have to type in pd.dataframe, and inside this I will pass in fruit, and I will store this in, let's say, fruit underscore df. Now let me print this out, fruit underscore df, right? So what happened over here is these two keys have turned into the column names. So fruit has become the column name over here, count has become the column name over here, and these values come into the rows, right? So fruits we have over here, and apple, mango, banana, and guava are the row values. Again, count becomes the column name, and these values over here come over here, right? So this is how we can create a data frame out of a dictionary, right? So now that we've understood the basics of series and data frame, let's go ahead and see how to import a data frame and do some sort of data manipulation on top of it. So I have this customer churn data frame with me. Let me go ahead and import it. So to import a data frame, I'll type pd.readcsv. Now inside this, I will just give in the name of the file. So the name of the file is customerchurn.csv, and I will store this in a new object and name that object to be customer churn. Now let me go ahead and print the first 5 columns of it. So it'll be customer churn dot head. Right, so this is our customer churn data frame, and it comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, and so on, right? So this is a special function in pandas which gives you the first 5 rows, right? So 1, 2, 3, 4, 5. Now similarly, let's say if you want to have a glance at the first 10 rows, you just given the value 10 over here, and you can glance at the first 10 rows of this customer churn data frame. So an analogous function to head is the tail function, which would give you the last few rows. So I'll type in tail over here. Now I'll click on run. So this over here gives you the last 5 rows from this customer churn data frame. Similarly, if you want to have a glance at the last 10 rows, you will just put in the value 10. Right? So these are the last 10 rows present in the customer churn data frame. All right. Now let's see how can we extract specific rows and columns from a pandas data frame. So for this, we've got lock and ilog functions. So let's actually start working with the ilog function. So let's say I want to extract only the rows from row number 5 to row number 15, and only the columns from column number 2 to column number 4. Let's see how can we do it, right? So I'll start off by giving the name of the data frame, which is customer churn. After that, I will use the function ilog, and I'll put in a comma over here. right? So whatever is present on the left side of the comma, that denotes all of the rows, and whatever is present on the right side of the comma, that denotes all of the columns. So let's say if I want to extract all of the rows from 5 to 15. So I'll put in 5, I'll put in a colon, and I'll type in 15, right? So I'll be extracting all of the rows starting from row number 5 to row number 15. Similarly, if I want all of the columns starting from column number 2 to column number 5, this is how it will go, right?
Just a quick info, guys. Test your knowledge of data analytics by answering this question. A graph that uses vertical bars to represent data is called as A. Line graph, B. Bar graph, C. Scatter plot, D. Vertical graph. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So let's actually have a glance at this. So this 2 to 5 over here. So since we already know that in Python indexing starts from 0. So 0, 1, 2. So this would be our column number 2, which is senior citizen. So 2, 3 and 4, senior citizen, partner and dependents, right? So we have extracted column number 2, column number 3 and column number 4. And we have extracted the rows starting from row number 5 to row number 14. Right, so this is how we can extract specific rows and columns from a data frame. Now let's go ahead and see how can we perform some sort of data manipulation. So let's say from this entire data frame, I want only those records where the gender of the customer is female, right? So for this, what we'll do is I'll just start off by typing the name of the data frame, which is customer churn. And then inside the parenthesis, I will give in the name of the column, which is gender. After that, I'll use the double equal to operator and then give in the condition, which is the gender of the customer needs to be equal to female, right? Now I'll click on run and let's see what do we get. So you get a bunch of true and false labels. Now this bunch of true and false labels basically means that over here at record number 0, it is actually true. That is, the gender of the customer is female. So false over here indicates that gender of the customer is not female. Here again it is false, here again it is false. So again at record number 4, it is true. That is, the gender of the customer is female. Now what I'll do is, I will cut this and I will paste it back inside this, right? So what is happening over here is, from this customer churn data frame, I will extract only those records where this condition is true, right? And I will store this in, let's say, female customer. Alright, I'll click on run. Now let me print out the head of this. Female underscore customer dot head. Alright, so we have successfully extracted a subset from the original data frame where the gender of the customer is only female. Now similarly, let's say if you want to do some sort of complicated operation than this. So let's say we want to extract only those records where tenure of the customer is greater than 50 and the internet service of the customer is equal to fiber optic. Alright, so now let's start off with the first condition. So I'll give in the name of the data frame, which is customer churn, and inside the parenthesis, I will give in the name of the column, which is tenure. So the tenure of the customer needs to be greater than 50. Alright, so I'll cut this and put this inside braces. I'll put the AND operator and give in the second condition. So the second condition is the internet service of the customer needs to be equal to DSL. So I'll type in internet service and this needs to be equal to DSL. Right, again I'll put this condition inside quotes over here. Alright, so we've got these two conditions, and finally I'll put those two conditions inside the data frame. So what is happening is, from this entire customer churn data frame, we'll be extracting only those records where these two conditions are satisfied. Right, and I will store this in, let's say, C underscore tenure underscore internet. Now let me print out the head of this. So it'll be C underscore tenure underscore internet dot head. Alright, so let me have a glance at the tenure. So over here, if you see, the tenure of the customer is greater than 50 for all of these values. So 62, 58, 72, 70, and so on. Now, similarly, if I have a glance at the internet service column, then you'll see that all of these values are DSL. Right, so this is how we can perform data manipulation operations on top of the pandas data frame.
So, exploratory data analysis, or EDA for short, is the process of performing initial investigations on data so as to discover patterns, abnormalities, or anomalies in assumptions with the help of summary statistics and graphical representation. Basically, when we have some data on which we want to perform data science and statistical analysis and machine learning modeling, we first need to make sure that we understand what the data represents, shape of the data, what are the different kinds of things that are available in our data, different data types available in our data. If we could visualize our data and understand relationships between individual columns or individual features in our data, that's really good. And all of that and more, such as visualization and all, is done in a step called exploratory data analysis. So that's what EDA is all about. Now, EDA allows us to get a better understanding of our data and make important observations on it. In order to understand this, let's understand with an example. If you have a data set which you have no understanding of, you don't understand what the data it contains is, what do the columns represent, how do the columns relate to each other, and which columns are important for the particular task that you are trying to solve. In cases like this, it is very difficult to understand how you are going to solve the problem, how you're going to build the model, how you're going to perform statistical analysis, so on and so forth. So in this sections, what happens is we would like to perform exploratory data analysis in order to get a better understanding of our data. This also helps us understand whether or not the data that we have needs some sort of boost. So, for instance, if we have some data set that's highly biased on one result, for example, we are trying to predict whether or not a particular internship is going to convert into a job. Let's say we have a data set and we want to figure out whether or not we can create a predictive model in which we can feed in some data about an intern and figure out whether or not we should give them a job. Although it's a very specific use case, if all we have is data where people did not get converted into full-time employees, our data set is completely biased, and this is something that we could miss if we don't take time to analyze our data using exploratory data analysis. So if that is the problem, then we would have to get more data so that we can balance out both the probabilities and then teach our model about these things so it has better understanding of what features lead to what results. So now we come to why EDA. Why would you want to perform exploratory data analysis? We've understood what it is, but why exactly would you want to do it? Well, exploratory data analysis is one of the most crucial steps in data science. It allows us to achieve certain insights and statistical measures that is essential for the data scientist. A good understanding of exploratory data analysis process allows us to make some important observations and early decisions that could help us reduce or that could help us not take steps that are not needed. So as we discussed in the previous example, if our data set is biased, then performing modeling and using multiple algorithms and trying to figure out the accuracy of each model is not going to be a good idea, mainly because the data set we have is not good. If you don't have a good data set or don't have a data set that's representative of the reality in the current world, then your model is not going to be good. It's not going to perform really well. So exploratory data analysis helps us perform as fewer steps as possible in order to get the best result. This is why exploratory data analysis is so crucial a step in our data science process. So it performs certain steps to define and refine our important features and variable selection. So it could be that you have a data set that contains 25 different columns, but for what you are trying to predict, only 3 or 4 columns are going to be enough. They explain most of the things or most of the variation in the data or in the column that you're trying to predict. So you only need to use 4 variables. Now, which 4 of those should you use, and if indeed are they 4 variables or are there 5 variables that explain it better? For that, exploratory data analysis is important. It allows us to select features that are going to be useful for us. In case we don't use the correct features, we end up with a model that's highly bloated contains data that's irrelevant, requires users to fill in data that's relevant, and could lead to incorrect or highly improbable results. So we need to be very careful when we're trying to take model columns or columns on which we are trying to model our data on to make the predictions. Now, why would you want to perform exploratory data analysis with Python? There are many other languages out there, including R. You can even perform exploratory data analysis in JavaScript and Java and C++. So why should you use Python? Well, exploratory data analysis using Python is very easy. First of all, Python is probably one of the easiest languages to get started with. This is why Python is so popular in data science community, because many people who perform data science operations or machine learning operations on a particular data set are people who come from the academic world. They don't have much understanding of what programs are, what variables are, what classes are. They only need to write code to get the things that they want to get done be done. This is where Python comes into play. It fills the gap. So since Python is so easier to use, and another advantage that Python provides is that it has a number of libraries that allows us to perform tasks related to exploratory data analysis. In case we are performing these tasks ourselves, it's very, very important for us to make sure that the libraries we are using are trusted and used by multiple people, because if it's a library that someone has created, our confidence in it is going to be really low. For example, if it's a library to perform data visualizations, but it's a library that not a lot of people have used, then you cannot be sure that the library is going to give you accurate visualizations, and it's always going to be a bit problematic. In Python, however, there are libraries that have been used by millions of developers and academic people. What they do is they just understand the basics, and then they import the data and visualize it and perform the task that they need to perform right at the step. And that's really important for our dataset. So this is why Python is such a good candidate for exploratory data analysis, mainly because it's easy to understand, easy to read, it's got a really clear syntax, as well as because it's got so much good tools and libraries around exploratory data analysis and data science in general. It's just a really good experience for developers or people who are getting started with exploratory data analysis or data science, or even professionals. Now, Python has libraries to perform all kinds of tasks relating to exploratory data analysis, such as visualizations analysis, etc. Visualize the data, there are libraries available, not just one library, but multiple. Depending on the features that you're trying to use, you can import either one of the libraries that are available. There's libraries for data analysis, libraries for numerical manipulation. There are libraries for many other different kinds of tasks, such as creating neural networks, defining the structure of a neural network, visualizing neural networks, so on and so forth. So this is why Python is so popular. Now, some of the most popular libraries to perform EDA are NumPy, Pandas, and Matplotlib. Now, since I'm assuming that many of you are beginners and you have no understanding of what these libraries are, we will cover what these libraries do in a later point in the presentation. Also, again, if you wish to learn more about these libraries and more about data science and exploratory data analysis and Python in general, stick with us till the end of the presentation, and we'll help you guide you through some of the resources that can help you out there. Now let's take a look at some of the advantages that exploratory data analysis provides us. So it provides us with several benefits. First advantage is that it allows us to spot missing data. Using exploratory data analysis, we can easily find null and missing values. So in case we have a data set in which certain columns have null values, or certain columns have certain proportion of the data is missing, we can remove the data, we can fill the data. Although removing the data and filling the data is not part of exploratory data analysis, spotting the missing data is definitely a part of exploratory data analysis, and it allows us to do the same. It allows us to find the underlying structure of data. So on the surface, what we can see is the number of columns, the columns that we have, and the data that we have in them. Underneath the row and columns and the tabular structure of our data, if indeed it is tabular, what we can do is we can understand what the underlying structure is. Underlying structure means what are the different data types that a particular column holds. Are they in the correct format to be processed? what is the range of data that is contained in a particular column. Do columns relate or correlate with each other in the data set? And if so, is it helpful or harmful for the task that I'm trying to perform? So on and so forth. Then there's variable importance. Exploratory data analysis helps us to figure out which variables in our dataset are the most important ones. So in that case, it helps us understand which variables have the highest influence on the thing that we're trying to predict or on the column that we're trying to predict. That way, we can just drop the rest of the columns and only use the ones that have influence on our columns above a particular threshold. And finally, data visualization. Now, we can sit and talk about data a lot, but one of the issues that exploratory data analysis solves is that when we show these statistical measurements to people, first, especially people who are not statistically literate, it's going to be really difficult for them to understand. Mainly because they have to firstly scan through the data, then understand which data has higher value, which data has lower value, and then understand the implication of each of them. It's much easier to visualize this data and understand the characteristic of the data that we possess. In this scenario, exploratory data analysis is really, really helpful. It allows us to perform visualizations and explain our data in a better capacity, even to people who may not be that familiar with the data that we have, as well as the statistical analysis that we are performing. Now let's take a look at the libraries that we had discussed earlier and what in exploratory data analysis. I would just like to mention that these are the three libraries that I have picked. These are the most one or at least some of the most common libraries that are being used. Not necessarily the case that these are the only libraries that will be used, or also not necessarily the case that these are the libraries that are going to help you in a particular problem. It could be that there are better alternatives available, and to understand about the alternatives, you need to firstly look at all the options that are available. So I recommend before starting any exploratory data analysis process, take a look at the tasks that you want to perform, take a look at the libraries that are available. These libraries are the most popular ones and for good reason. So these should help you out, especially if you're a beginner. But as you become more and more advanced and more into the exploratory data analysis and data science community, you understand that there are better tools available for the one particular task that you're trying to perform, and it's better to use those tools. All right. So the first one is Numpy. Numpy, or many people call it Numpy as well. It is a numerical manipulation library. In Python, we can perform numerical manipulation using raw Python itself, but it contains a lot of the information that are not relevant for our purposes. Since Python is an object-oriented programming language, which it's fine if you don't understand what that is. But in case you do understand, it stores a lot of information that's not relevant. So when we try to perform complex mathematical operations, those properties about the object orientedness of the particular variable come into play, and they negatively affect or negatively impact negatively impact the performance. So in situations like this, NumPy is quite useful. It firstly just keeps all the relevant data. Secondly, it has a lot of functions that allow us to perform these numerical manipulations. Inbuilt functions for calculating the sine waves, the cosine waves. For fast Fourier transform is also available, and many different kinds of numerical manipulations that are difficult to implement by hand are already implemented in NumPy. So you don't have to worry about implementing these things. You just have to worry about using them when the need be. Then there's pandas. If you have done data science with Python for any period of time, pandas is a library that you must have come across. Pandas is great for data analysis, data summarization, and many other tasks relating to data. It allows us to load data in our Python program using something called data frames. Data frames is a special object or a special way of representing data in pandas, and it affords us a lot of benefits. It allows us to perform a lot of complicated tasks on our data, such as joining two data frames, filtering a data frame, manipulating data, dropping data, and a lot of different kinds of tasks that by hand are going to be very difficult. So it's a layer of abstraction over these complicated tasks, so you can perform them yourself, and it's very efficient as well. Then we come to Matplotlib. It is a visualization tool, or is a visualization library, allows us to create charts and graphs and allows us to perform a lot of visualization. Many different visualization libraries such as Seaborn use Matplotlib underneath the hood. So in case you wish to become a data scientist and want to perform exploratory data analysis by visualizing the data, Matplotlib is a library that you might need. You can also use other libraries, but Matplotlib is probably the best one to start with because it's very easy. It exposes you to some of the fundamental concepts that you need to understand when you are dealing with in IronPython visualization or graphs or charts. They can help you out with that. All right, so we have reached the demo section. Now for the demo, I have already written the code so that I don't write the code and you have to then follow along and look at the errors that I make. I'll explain the code to you now. I told you that you only need to import the libraries that you need. In the current scenario, I didn't need to use any numerical manipulations because the data is already manipulated for me. Then I can use this. I'm using pandas, Seaborn for interactive visualizations, and also Matplotlib. These are two different visualization libraries. Seaborn is great for creating summarizations of our data sets, and Matplotlib is great for visualizing individual columns. This bit of code here is telling the Jupyter notebooks. Let me just zoom in on it because it may be possible that you guys aren't able to see this. Now, in Matplotlib, it's possible to use it with multiple backends. In this scenario, we're using it with Jupyter Notebook. We're just trying to tell Matplotlib that whatever visualizations that you produce, make sure that they are optimized to be rendered inside a Jupyter Notebook. Now, many people say it's not necessary to do this step. It was necessary previously, but now it's not. But I like to keep it in just in case. Then I am importing a data set. And to give you some context, this is a data set that I have downloaded from Kaggle. You can download it yourself. I would recommend it that you do it afterwards, and you can play with it as well. This dataset and many other datasets are available on Kaggle for you to perform exploratory data analysis with. You can do it on Kaggle as well. And when you're doing it, you can, using that exploratory data analysis notebook that you have created, you can share it with people. Kaggle is a great platform for that. So you can use it for that. And now we take a look at the first 5 columns, first 5 rows of the data. Now, as you can see, the shape of the data is 5 rows in 81 columns. Now, 81 columns is probably a lot. As you can see that even our pandas library is refusing to show all of this because it knows that it's not possible for us to show everything. So we have this. Now, we take a look at the information of the data. This tells us about the data set that we have and gives us information about each column, right? So we have 1460 non-null columns, non-null data points with of type int 64 in the ID column. And you can take a look at everything. Here, as you can see, in the alley column, we only have 91 data sets. That means that majority of the data is null. We'll deal with that in a moment.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customer says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also, the course material is structured in such a way that it covers all the basic till the advanced level of concept, that even a non-computer science background student can easily understand the concept.
Now, let's continue with the session.
As you can see, the data is quite disparate. Sometimes it's 1460, sometimes it has 1452 data points. So we are dealing with a data set in which we can have null values quite a lot. For instance, pool QC has only 7 values that are not null, others are all null. And as you can see, the data set is quite disparate as well. Some are objects, which are basically string or some other data set other than numerical data set. Some are integers and some are float. Float are basically real numbers. These are numbers with decimal points. So currency could be considered float, and real numbers are considered integers. So your mobile number could be considered an integer because it's not going to have a decimal point is that. Right. So I don't want you to get bogged down into the specifics of the code. What I'm trying to tell you is how we are going to do this. So here what we're doing is we are taking all the columns in which our data is greater than or equal to 30%. So any column that contains less than 30% data, which is it has 1460 columns, but only 30 or less percent of the values are present in that, and we are going to drop it. So any column that contains less than 30% of the data, we're not going to consider it at all because it could have negative implications. So we do that. Now what we do is we also delete the ID column from our dataset, mainly because ID is just something that is generated by the database in which it was stored, or maybe not by the dataset, but by the people who collected this data. It's not really important for us. It's important for storing the data, but for analysis of the data, ID is just a number that was randomly assigned to a person. It has no significant value. Now we will print the list of columns that were dropped. As you can see, alley, QC, fence, and miscellaneous features are the columns that are dropped. ID is the one that we have dropped manually, even though it contained a lot of data. Now we try to do two things here. First thing, we take a look at the sale price, which is a column that we are very interested in because that's the column that we're trying to model our scientific process across. So we describe the data, which is we count the number of columns. As you can see, it contains every bit of data that is available. The mean is 1,80,921 point some value. Standard deviation, minimum value, 25 percentile, 50th percentile, which is here, then 75th percentile or the third quartile, and the maximum value in the column. This is, by the way, this is something that pandas is doing for us. We didn't have to write functions to loop over the data and figure out the min, max, 25th percentile, and all of that. So it tells us the name of the column, sale price. Data type is float. And now what we do is we try to visualize it. So as you can see, the majority of our data lies in this region. Yeah. So here and here. This is what is known as a histogram or distribution plot. Since Seaborn allows us to do it pretty easily, we do it. Don't worry about the code. Stick with us till the end of the presentation and we'll show you how you can learn to write the code. Right now, we're trying to understand the process of exploratory data analysis. So as you can see, even though we have a maximum value of 77,55,000, majority of our values are lying between somewhere around these values. Right. Now we take a look at the different data types available in our dataset. We have integer. We have O, which stands for object. Object basically means that this is something that's not a number. And we have float. This 64 is basically how many bits are used to represent the data. This means that the data could be of high size. You can, by the way, change this all yourself. So here what we do is we say, okay, give me all the numerical data that we have. This is done mainly because we want to be sure that we are only dealing with numerical data. Dealing with data that is not numeric, firstly we'll have to convert the data into numerical formats and so on and so forth. So we're trying to firstly estimate the task ahead of us. We take the numerical data that contains float 64 and int 64, basically not selecting the object data types. We take a look at the head. As you can see, it has 37 columns, which is a massive drop from what we had earlier. Earlier we had 81 columns, out of which we dropped, I think, 4 or 5 because they had a lot of null values. This one is by far something that we have done only to understand what the data is about. Now we take a look at the distribution of our data using histograms. What we do is we basically create a histogram for all the columns. So again, we didn't have to do it ourselves. These are all 31 columns with histograms, and you can take a look at the data. As you can see, it contains a lot of data. Some columns contain a lot of data that's centered around a particular data point. Others are very separate, such as this one. This only contains values that are 0, so that's fine. And you can take a look at the data and analyze it. We're not going to analyze it right now. This is just for you to understand how to generate these visualizations. Then we take a look at correlations. Correlation basically is a number that allows us to understand how much of our data is how much influence does one column has on a particular column. And we remove the last column because the last row is basically sales, or the last column, sorry, I'll just remove the comment. So the last column is sales, so we don't have to worry about that. From here, we basically just take all the columns with correlation greater than 0.5. We call them golden feature list. Any column that has a higher value than 0.5 on correlation means it has good correlation for our data. We're taking the absolute value, which means we don't care whether it's negative or positive. Correlation ranges from -1 to +1. -1 means if the data in this column decreases, data in the other column which is negatively correlated with it will increase. Positive correlation means data in this column increases, data in other column which is positively correlated with this increase. So we take that and we sort it in ascending values. Now after doing this, we take a look at the correlations. So these are the correlations. The highest correlation we have is overall quality and GR live area. It's around 80 to 70%. Now what we can do is we take a look at all the numerical columns and we generate.
Test your knowledge of data analytics by answering this question. Which of the following is not a major data analysis approaches? A. Data mining. B. Predictive intelligence. C. Business intelligence. D. Text analytics. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
For the first for all fifth values, what we're trying to do is we're trying to create visualizations to understand how a particular column relates to first 5 columns. So for instance, sales price relating to MS subclass, MS lot range, lot area, and so on. And as you can see, we're doing it for everything, and we're doing it 5 plots at a time. Now that we have done that, here is a bit of a code that's going to be a little difficult to understand, so I'm not going to try and explain it to you. But basically here, what we're trying to do is we're trying to create individual data frames or individual feature data frame, as I've named it. Create some temporary data frames based on particular sections, such as we take the column name and the sales price, and then using that data frame we check whether or not the column's value is not equal to 0, and we create or we add it to the data frame. Then we create an all correlations matrix, and then we try to print it. Now we come to the interesting part. So these are all the 11 strongly correlated values that we have, right? For this one, since we had 81 columns and now we have reduced it down to only 11 columns that have really high influence on our sales price column. Now to visualize it, what we have done is we have created something called heat map. Let me just zoom in so that you guys can see. I think I zoomed in a little too much. Yeah. And also you can manipulate the size of this plot when you're writing code. I'm not going to do it right now. But as you can see that some columns have correlation of 0.4, some have, and this is negative, by the way. As you can see, these are color coded. So any column with light color such as blue or purple are negative. Any columns with light the color such as yellow or green are positive. As you can see, we have 0.83% of correlation with GR live-in area and fireplaces. And so this allows us to understand what are the particular columns that are highly correlated with each other. Allows us to understand whether or not a column has influence on not just one column but multiple columns, and how does that affect our purposes.
So this project would be on market basket analysis. So let's have a look at the problem statement. So consider yourself to be the manager of a supermarket, Walmart, and your task as the manager of the store would be to increase cross-selling. That is, you'd want to encourage the customers to buy items related to what they've already bought. And to do this, you'd have to find the association between different items. That is, you'd want to figure out if a customer buys item A, how likely is he to buy item B as well. So you'd have to start off by understanding the transactions. So you'll have to find the total number of transactions. Then you'll have to find the total number of items available in the inventory. After which, you'd have to find the total number of items purchased. And then finally find out the 10 most frequently bought items. So let's go to RStudio and implement these. Right guys, so we are back to our studio. So we are supposed to load the A rules and A rules Wiz packages. And I'll be loading them with the help of the library function. Right, so we have loaded both of these packages. Now it's time to load the dataset. So now to load the dataset, I'll be using the read.transactions functions. So this read.transactions function helps us to read a dataset in the form of transactions, right? So the file name is marketbasket.csv and I have a parameter format and the value which I'm assigning to this is basket. So this basically means that each record in the dataset would be in the form of a transaction. Then I'll go ahead and remove the duplicates. So I'm setting rm.duplicates to be equal to true. And then I'll skip the first record. That is, I'm not reading the first record and I'll read the rest of the records from the dataset. And I'll be storing this in a new object and name that object to be market basket. Right, so we have successfully loaded the dataset. Now let us have a glance at the summary of the object which we've just created. So summary of market basket. So you see all of these values over here. So these values basically tell you the number of items which were purchased in each transaction. So let's take this. So this basically tells you that there were 1359 transactions in which the number of items bought were 2. Similarly, if we take this value over here, so there was one particular transaction in which the customer had bought 548 items. Similarly, if we take this value, so there were 433 transactions in total in which the customers had bought 19 items. If we take this value, so this is 165 items. So there was one particular transaction in which the customer had bought 165 items in total. Right. So we had to find the total number of transactions and the total number of items available in the inventory. So the transactions would be the number of rows. That is, the transactions are listed in the form of rows. So the number of rows would give us the total number of transactions. And since the total number of rows are 18,440, the total number of transactions would also be the same. That is, the total number of transactions in the dataset are 18,440. Now the columns represent the items. So that is why the number of columns which we have would also represent the total number of items. And since we have 22,346 columns, that would basically mean that we have 22,346 items in total in our inventory. And then we also have a value of density. So this density value basically gives the percentage of all of the non-empty cells in our matrix, right? And then we'd also had to find out the total number of items which were purchased. So to find out the total number of items which were purchased, we'd have to multiply the total number of transactions with the total number of items available in the inventory with the density value. So let's go ahead and do that. So I am multiplying the total number of transactions with the total number of items available in the inventory with the density value. And this is what we get. So you see that in total 4,08,582 items were purchased. Now let's actually have a glance at the first 5 transactions. So what I'm doing here with this command is I am giving the name of the object which is market basket and I am inspecting the first 5 transactions. So these are the first 5 transactions, guys. So in the first transaction, the customer had bought just one item and that item was medium ceramic top storage jar. And this is the second transaction. So there are around more than 30 items in this, right? So in the second transaction, the customer had bought more than 30 items. Similarly, this is the third transaction. This is the fourth transaction and this is the fifth transaction. And the final task was to find out the 10 most frequently bought items. So let's go ahead and make a plot for that. So now since we'd want to give different colors to the different bars which we are making, we would require the rcolor package. So let me go ahead and load that. Right, so I have loaded the rcolor package. Now to find out the frequency of different items, we have the item frequency plot. So I'll be using this function. So let me guide you through this function. So first off, we will give in the name of the dataset, which consists of all of the transactions. And then I'll give in the number of the transactions of which we'd want to make this plot. And since we'd want to make a plot of the top 10 most frequently purchased items, I will give in top n equals 10, and then type is equal to absolute. So this will give us the absolute count of all of the items which have been purchased. After that, I will stack the bars horizontally. So horizontal equals to true basically means that I am stacking all of the bars horizontally. And then this brewer.pal, this function comes from the rcolor brewer package. And I am assigning 10 different colors from the spectral palette. Right. So let me hit enter, and this is what we get. So guys, these are the 10 most frequently purchased items from the entire data. So this white hanging heart tea light holder is the most frequently purchased item, right? So now that we're done with the first task, let's go ahead and build our first set of association rules. So here we'd have to build a priori algorithm with support value 0.005 and confidence value 0.8. Then we'd have to sort the rules with respect to confidence and inspect the top 5 rules and also the bottom 5 rules. After which we'll go ahead and sort the rules with respect to lift and inspect the top 5 rules. And finally, we'll plot the rules using different methods. Right, so let's go ahead and perform all of the above mentioned tasks. So we were supposed to build an a priori algorithm with these parameters. So let me put in the command over here. So what I'm doing is, on top of the market basket data, I am building the a priori algorithm with these parameters. So here the support value is 0.005 and the confidence value is 0.8. So the support value of 0.005 basically means that out of all of the transactions, I am selecting those item sets which occur at least 0.5% times. So I'm reiterating, guys. So the support value of 0.005 basically means that out of all of the transactions, I am extracting only those item sets which occur at least 0.5% times, right? And then we have this confidence value, which is 0.8. So this confidence value of 0.8 basically states that out of all of the item sets or out of all of the antecedents which we have extracted, the consequence should be present 80% of the time, right? So we have assigned the support value to be 0.005 and the confidence value is 0.8. And I am sorting the rules with respect to confidence and I am storing it in an object and naming that object to be rule 1. So let me run this. Now let me have a glance at the summary of the rule which I've just built. So summary of rule 1, and we get a summary of this, right? So there are 6 rules which comprise of 6 items including the LHS and the RHS, that is including the antecedent and the consequent. Similarly, there are 79 rules which have 5 items, and there are 211 rules which have 4 items, 201 rules which have 3 items, and 64 rules which have 2 items, right? So this is the length of the item sets and this is the count with respect to those item sets. Now let's inspect the top 5 rules. So I am giving the name of the rule, which is rule 1, and I am inspecting the top 5 rules. So these are the top 5 rules when sorted with respect to confidence. So we see that if someone buys garbage design, that customer is also likely to buy key fob. And the support value is 0.005 and the confidence value is 1. So the support value of 0.005 means that out of all of the transactions, garbage design would be present at least 0.5% times. And this confidence value of 1 means that if someone purchases garbage design, then he is 100% likely to also buy key fob. And then we have this next rule over here. So if someone buys elephant, then he is also likely to buy birthday card. And the support value is 0.006 and the confidence value is 1. So the support value of 0.006 means that out of all of the transactions, this elephant has been purchased 0.6% of the times. And this confidence value of 1 indicates that if someone purchases elephant, then he is 100% likely to also buy a birthday card. Right? Similarly, if we take this rule over here, so for this, the support value is 0.006 again. So this means that out of all of the transactions, RetroSpot was bought 0.6% of the times, and this confidence value of 1 means that if RetroSpot is bought, then birthday card is likely to be bought 100% of the times along with the RetroSpot. Now let's go ahead and glance at the bottom 5 rules. So we given rule 1, and from this rule 1, we are inspecting the bottom 5 rules. So that is why we're using the tail function. So these are the bottom 5 rules, guys. So let's examine this rule over here. So there are 2 items in the LHS and there is 1 item in the RHS. That is, the antecedent comprise of 2 items and the consequent comprise of 1 item. So for this, we have the support value to be 0.006 and the confidence value to be 0.8. So the support value of 0.006 basically means that out of all of the transactions, customers are likely to buy this item set 0.6% of the times. And this confidence value of 0.8 means that if someone buys this item set over here, then he's 80% likely to also buy a set of 3 wooden stocking decoration. Now let's have a glance at this rule over here. So on the LHS, the item set is lunch bag apple design, lunch bag pink polka dot, and lunch bag woodland. And on the RHS, we have lunch bag red retro spot. So for this, the support value is 0.006 and the confidence value is 0.8. So the support value of 0.006 basically states that out of all of the transactions, this item set was bought 0.6% of the times, and this confidence value of 0.8 states that if someone buys lunch bag apple design, lunch bag pink polka dot, and lunch bag woodland, then he is 80% likely to also buy lunch bag red retro spot. Now let me go ahead and also sort the rules with respect to left. So rule 1, and I'm sorting this rule 1 with respect to left, and I'm storing the result back to rule 1. Now let me inspect these rules. So I'm inspecting the top 5 rules over here. Right, so after sorting the rules with respect to the left, this is what I get. So if I examine this first rule over here, on the LHS, the item set is Dolly Girl Children's Cup and Space Boy Children's Bowl. And on the RHS, or the consequent is Dolly Girl Children's Bowl. Right, so for this, the support value is 0.005 and the confidence value is 0.96. So again, here the support value of 0.005 means that out of all of the transactions, this item set is present 0.5% of the times. And this confidence interval of 0.96 means that if someone buys Dolly Girl Children's Cup and Space Boy Children's Bowl, then he is 96% likely to also buy Dolly Girl Children's Bowl. So now let me go ahead and plot these rules. Now let me change the method. So I'll be plotting the rule 1 again, but the method which I'm giving would be toKey. So let's see what is the difference which we get over here. So now this time the coloration is with respect to the length of the item set. So if the length of the item set is 6, then the color of the dot would be yellow. Similarly, if the length of the item set is 2, then the color of the dot would be purple. Similarly, if the length of the item set is 5, then the color of the dot would be green over here. So let's examine this rule over here. So since the length of the item set is 6, so there are 5 items in the antecedent and there is 1 item in the consequent. So here the support value is 0.007 and the confidence value is 0.9. Similarly, let's examine this over here. So the length of the rule is 3 over here. And the items in the antecedent are pink Regency teacup and saucer. And we also have roses Regency teacup and saucer. So if someone buys these 2, then there is 80% likelihood that he would also buy green Regency teacup and saucer. So here what we are basically doing is we are segregating these points with respect to the length of the item set. Now let us make the final plot. So this time the method which I'm using is graph. So let me hit enter and let's see what do we get this time. So this time we get a graphical result over here, right? So let me zoom in. So we have all of these rule numbers over here. So let me put my mouse pointer over here, right? So this is rule number 92, which states that if someone buys herb marker mint, herb marker parsley, herb marker thyme, then he's also likely to buy herb marker chives. So for this, the support value is 0.007. The confidence value is 0.89. Now, let me zoom out. So the distance or the gap between these two graphs basically means that there is absolutely no association between these items and these items over here. Similarly, let me zoom back. There are two items over here as well. So these item sets are completely different. These item sets are completely different, and these item sets are completely different. That is, there is no association between these three set of items over here. So let me zoom in again and let me have a glance at this rule. So this is rule number 100 over here, which states that if someone buys Dolly Girl Children's Cup and Space Boy Children's Bowl, then he's also likely to buy Dolly Girl Children's Bowl. Similarly, let me zoom out and let me have a glance at this rule over here. So this is rule number 87, which states that if someone buys pink vintage spot beaker, then he is 87% likely to also buy blue vintage spot beaker. Now we'll go ahead and build the second set of association rules. So here we'd have to build a priori algorithm with support value 0.009 and confidence value 0.3. Then we'd have to sort the rules with respect to confidence and inspect the top 5 rules and also the bottom 5 rules. And finally, we'll plot the rules using different methods. So we'll make the second set of association rules. So this is the command for that. So this time again on top of market basket, I'm building the a priori algorithm. So for this, the support value is 0.009 and the confidence value is 0.3. And I'm sorting the rules with respect to confidence and I'm storing the result in an object named as rule 2. Let me hit enter. We have successfully built the a priori algorithm. Now let me have a glance at the summary of rule 2. So here we see that the length of the item set could be either 2, 3 or 4. So there are 16 rules where the length of the item set is 4. There are 288 rules where the length of the item set is 3. And there are 537 rules where the length of the item set is 2. Now going ahead, let me have a glance at the top 5 rules and the bottom 5 rules. So this is the command for that, rule 2, and I'll be inspecting the top 5 rules using the head function. Right, so these are the top 5 rules. So here let's have a glance at this first rule over here. So if someone buys set 3 retrospot tea, then he is also likely to buy sugar. And for this the support is 0.013 and the confidence is 1. So the support value of 0.013 means that out of all of the transactions, people are likely to buy set 3 retrospot tea 1.3% of the times. And this confidence of 1 means that if someone buys set 3 retrospot tea, then is 100% likely to buy sugar. Similarly, let's have a glance at this. So the rule is backdoor gives us key fob. And for this, the support value is 0.012 and the confidence value is 1. So again, if the support value is 0.012, this means that out of all of the transactions, backdoor has been bought 1.2% of the times. And this confidence value of 1 means that when someone buys backdoor, he is 100% likely to also buy key fob. Now let's have a glance at the bottom 5 rules. So I am inspecting the bottom 5 rules with the help of the tail function over here. Right, so let's examine this. So here the rule is in the antecedent we have home building block word and the consequent we have white hanging heart tea light holder. So for this, the support value is 0.011 and the confidence is 0.3. So the support value of 0.011 means that this item is bought 1.1% times, and this confidence value of 0.3 means that if someone buys home building block wood, then there is only 30% likelihood that the person would also buy white hanging heart tea light holder. Similarly, let's examine this rule over here. So for this, support value is 0.012 and the confidence value is 0.3. Similarly, if someone buys Jumbo Shopper Vintage Red Paisley, then there is only 30% likelihood that he'll also buy Jumbo Bag Baroque Black White. Now let's go ahead and plot these rules. So I'll start off by making a simple plot over here. So I'll use the plot function and I'll give in the rule 2 over here. Engine is HTML widget, which gives us an interactive plot. So you see these bright red colored dots over here. So these are the dots with the maximum lift. So the lift of these dots is more than 85. So it's around 89, 90, right? So if you want a lift of 90, then the confidence should be greater than 0.8 and the support should be less than 0.01. Now let's go ahead and make another plot. So this time we'll be making the 2-key plot. So the method is equal to 2-key. So again, we have 3 different colors over here. So yellow is for all of those rules where the length of the item set is 4. Green is for all of those rules where the length of the item set is 3. And purple is for all of the rules where the length of the item set is 2. So if you have a closer glance at this, then we see that those rules whose length of the item set is 2, they are mostly scattered, right? So they are present everywhere. But when it comes to those item sets whose length is 3 or 4, then for them, the support should be less than 0.015, you see. So these item sets which have 3 items in them, so they are mostly in this bracket over here. So for them, the support needs to be less than 0.015. And if we take these yellow dots over here, so for these yellow dots, the confidence value should be greater than 0.6 and also the support needs to be less than 0.015. Now let's go ahead and make the third plot. Right, so let me hit enter. So we get many different sets over here. So this item set is not associated with this item set. Again, this item set is not associated with this item set. Similarly, this item set over here is not associated with this item set. So let me zoom in and have a glance at these set of association rules. So let me have a glance at rule number 96. So here, if someone buys herb marker parsley, then he's also likely to buy herb marker rosemary. Now let me zoom out and let me have a glance at this association rule. So here, this is rule number 59 and this states that if someone buys set of 3 wooden tree decorations, then he's also likely to buy set of 3 wooden stocking decorations. Let me zoom out. Let me have a glance at another rule. So this is rule number 20 and rule number 21. So this tells us if someone buys blue happy birthday bunting, then there is 71% likelihood that he would also buy pink happy birthday bunting. Let's examine this. So this tells us if someone buys Scandinavian paisley picnic bag, then there is 62% likelihood that he would also buy pink vintage paisley picnic bag. So now we'll build the third set of association rules. Here we will build a priori algorithm with support value 0.02 and confidence value 0.5. Then we'd sort the rules with respect to support and inspect the top 5 rules and the bottom 5 rules. And finally, we will plot the rules using different methods. So guys, we are back to our studio. So let's go ahead and build the third set of association rules. And this would be the command for that. So here on top of the market basket data set, I am building the a priori algorithm where the support value is 0.02 and the confidence value is 0.5. And I am sorting those rules by support. Right, so now let me have a glance at the summary of these 3 rules. So summary of rule 3. Let me maximize this. So we have item sets with just 2 different length distributions over here. So there are 26 rules with the item set length to be 2, and there are 3 rules whose item set length is 3. Now let me examine the top 5 rules. Right, so this is the first rule, which tells us if someone buys jumbo bag pink polka dot, he is also likely to buy jumbo bag red retro spot. And the support for this is 0.029 and the confidence for this is 0.62. Now let me have a glance at the bottom 5 rules. Right, so rule 3, and I am inspecting the bottom 5 rules with the help of the tail function. So these are the bottom 5 rules, guys. So this is the first rule over here, which tells us if someone buys alarm clock bake like pink, then he's also likely to buy alarm clock bake like red. So for this, the support value is 0.02 and the confidence value is 0.64. So the support value of 0.02 states that out of all the transactions, 2% of the times alarm clock bake like pink was bought. And if someone bought alarm clock bake like pink, then there was 64% probability that he would also buy alarm clock bake like red. Now let me go ahead and plot these rules. So plot of rule 3, I'm making a basic plot. Now we see that we can't really find some association with this, so these are quite scattered over here. So let's go ahead and make the 2 key plot now. Right, so I'm using the plot function. I'm making the plot for rule 3 and the method is 2 key.
Just a quick info, guys. Test your knowledge of data analytics by answering this question. A graph that uses vertical bars to represent data is called as A. Line graph, B. Bar graph, C. Scatter plot, D. Vertical graph. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So we have 2 different colors over here. Yellow is for those rules where the length of the item set is 3 and the purple is for those rules where the length of the item set is 2. So now if we take these 3 dots over here, this is for yellow. So this is for all of those rules whose length of the item set is 3. And we see that the support value needs to be less than 0.02 and the confidence value needs to be greater than 0.7. Now let me make the third and the final plot. So this time the method is graph. So these are the different set of association rules which we have. Let me zoom in. So this is rule number 2, which tells us that if someone buys green Regency teacup and saucer, he is also likely to buy Rose's Regency teacup and saucer. So the confidence for this is 0.78. Now let me zoom back. So let me have a glance at rule number 19. So this tells us if someone buys Dolly Girl lunchbox, then there is 68% likelihood that he would also buy Space Boy lunchbox. Let's have a glance at this. So this is rule number 5. So this tells us that if someone bought alarm clock bake like red, then there is 60% likelihood that he would also buy alarm clock bake like green. And this brings us to the end of this project.
What is the difference between data science and data analytics? Well, the first main thing that you need to know is that, while many people actually, change around these terms, data science and data analytics, and use it together, there is a very keen difference because the main difference, in my opinion, is the scope in which data science, spreads its wings in and data analytics is good in. So we can consider data analytics to be a part of data science, guys. So data science is the umbrella and the data analytics is a part of that. So coming to the differences, well, data science is a complete umbrella term for a group of fields, again, which is basically used to mine large data sets, which basically means that we'll be, looking and hunting into large data sets and driving meaningful insights from them. But at the same time, data analytics is a more focused version, which is basically, considered to be just a larger part of the entire process, because at the end of it, all the data collected by the data scientists can be used by the data analytics team to pretty much go about doing visualizations, analyzing trends, and so much more. So coming to the next point, it's pretty much think bigger picture, think data science, because data science isn't concerned with answering any specific queries with respect to a specific set of data. It works its scope in a very wide way. But when you talk about data analytics works extremely well when you have a small scope to work with, when it is focused and you know the questions which need the answer to. And these questions, the answers that you can derive from these questions are basically from the existing data which is already present. So this is another simple difference between data science and data analytics. Coming to the next one, well, data analytics is all about the present data and the future. Well, let me tell you, again, data science pretty much, produces broader insights as we've been talking about, and that you should concentrate on the questions which should be asked based on the past data, where you can mine the data and make sense of it. This is the data sciences team. But then coming to data analytics, here we basically we basically drive into discovering answers to questions that are being asked at that very moment, at that very instant, to drive something in the present or to produce a trend or an analytics for the future, guys. So again, when we've been talking about scope, here's a quick reminder slide for you guys. Data science has a vast scope, it has a macro scope, while data analytics is more preferred for a microscope. So what this basically means is that data science is a more vast field, and so we've already spoken about how data analytics come under data science. So data analytics is used to do a certain set of tasks really well, and a data scientist can also go about doing all of these tasks as well. But then there are many other tasks for data scientists that a data analyst cannot do, and this brings us to the goal. Well, the goal of the data science field is basically to ask the right questions and get the right answers from the data. But then the data analytics goal is to pretty much find some actionable data where you can make sense out of it and drive business decisions and more. And this brings us to all the major fields that we can go about using. You might have heard of the term data science in majority of the fields in today's world. Well, it is used in machine learning, it is used to achieve artificial intelligence, search engine engineering, corporate analytics, it is used in the field of medicine as well, it is used in the field of manufacturing, and so much more. Data science has its foot deep in today's world of technology. And coming to data analytics has been a boon to the field of healthcare, to the field of gaming, travel, a lot of other industries, again manufacturing industries too, where the data requirement is immediate and the analysis and the analytics which goes with it is also immediate, guys. So this brings us to the question whether data science and data analytics are the best of both worlds. Well, think about it this way. The two fields basically can be considered as two sides of a same coin, because again, when you think about it, it's one coin where their functions are extremely highly interconnected, but then there are two faces to the coin where they are actually a bit different from each other.
And how do you find out these points? So there is a lot of different ways. So not everybody can just look at numbers and tell you, right, okay, this looks like 7.5, so this might be this, but that does not happen in real world. That is only movies. In the real world, it's very, very, very important that every organization makes a very informed decisions in their world. To make those informed decisions, what people do is they plot different kinds of graphs, they have charts, they have usage meters, and they have different fluctuation points. And as you can see in the image on the screen as well, so there are different kinds of dashboards for different kinds of data, and you pull this data from various different sources into one place. So as you can see in this image right here, if you think about Google Analytics offers you this huge amount of analytics which takes data from everywhere. So you can see.
Just a quick info, guys. If you want to make a career in data analytics, then Intellipaat has IIT Madras Data Science and Business Analytics Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below. Let's hear what our customers says about the course.
Intellipaat provides industry experts as mentors who constantly tracks our progress and provides insights. They engage all the class so actively that it finally gave me a confidence that we can learn online. And also, the course material is structured in such a way that it covers all the basic till the advanced level of concept, that even a non-computer science background student can easily understand the concept.
Now, let's continue with the session.
It can gather data from Google Plus, it can tag from your Google searches, from your YouTube watches, and what are the different Google products that you're using. It takes information from everywhere, even your Android phone. It can take all of that into account and then put yourself in a point where you can make an informed decision, because you are taking the data sets from so many multiple sources. You're covering basically all the aspects as you can. Similarly, you can connect data wherever it lives, right? So it is very, very important that you take multiple sources into account rather than one particular source. Having multiple sources into account will ensure that you are making an informed choice, because you have not missed some data points. There might be some data points which you might consider that these might be irrelevant, but when you go into analytics of it, it might affect or impact very huge in huge amounts. So that is something which you have to keep in mind when you are working with data analytics, that not it's not in every case that some particular field might not work out. So you have to take into account that you have to take data from wherever it lives, convert it into fashion that you can actually use that, and you apply your models and different analytical model, and you see what the graph is telling you, and you find out. As you can see, the January to February different plots are moving here and there, so you can find out which months different products were more in demand, less in demand, what was the age group that was in that wanted that particular product, and what the percentage might be, how many new users are coming, if your particular video is getting more likes or dislikes, what is the average watch time, what is the point where viewers are giving you maximum retention and stuff like that. So it is very stunning how much information small data sets can give you, and can actually transform the way you perform business. Moving further, let's talk about what are the skills to become data analyst. So now we understand what is data analytics, we understand what is data, we know that it is the job to solve problems through looking at different data sets. And this is not something you can do very easily without knowing stuff. So you have to understand, you have to gain skills in order to become data analyst, and that is what we are dealing with next. So to become a data analyst, there are 4 things which are very, very, very important, and you'll see it across almost all of the job descriptions out there. First and foremost thing is the knowledge of statistics. Every data analyst is working out there who is working out there has fairly very decent of knowledge of statistics, because every plotting or every manipulation that you do with respect to your data is based on some statistical method, or there is some statistics behind those manipulations that you're doing with respect to that data. So understanding what kind of statistical rule does what to your data and what insights that can produce is fairly important when you're working with data, because when you enter the industry, the problem statement will not be there like use this particular data set model to find this out. No, that will not be the case. The consumer, the stakeholders will give you a direct problem. Okay, this is XYZ is my problem, just tell me how do I solve it. In that, you have to understand the problem, you have to understand what kind of data that he has, and doing what kind of analytics or applying what kind of statistical factor will actually produce results which might give you the insights to solve that problem. So knowledge of statistics is fairly very important. Then a lot of companies today demand Python and R, but this is fairly more relevant for data scientists. So if you are someone who wants to move along with data science as well, you should understand well enough what is Python and R. But these days the requirement for data analysts also include Python and R, so it is very important that you know that. Other than that, you must understand data wrangling, which is basically working with data. So different kinds of data will be there, and you have to find out how to work with that data, make it more efficient and usable. So you have to know that. And then you have to have the knowledge of database technologies, which as Pig and Hive are very, very important with respect to that. Other than that, another thing which you'll find across all of the jobs for data analyst is a proficiency in Excel. So if you want to become a data analyst, you must understand how to use Excel, because Excel is something you might consider that it might not be that relevant, but trust me when I say this, Excel is far more beyond powerful that you understand. It is a very, very, very useful tool which is used across industries by almost every company which is out there, because every data analyst at some point touches huge amounts of sheets, and that is where Excel comes into the picture. Moving along, there are some other skills which you need to have, not just with respect to the technology, but with respect to yourself. So you need to develop this analytical skills, because you need to understand how to work with large amounts of data, what are facts, what are figures, and how this different graphs is telling you what. So having that sense of understanding of how data works is fairly important. And analytical skill is very, very important, because when not you have to look at different graphs, right? But the graphs only show you visual representation. It's you that understands what that particular graph is actually telling you. The graphs are just numbers and figures, but the insights that you gain is your own. So that is where the analytical skills comes into the picture, and you can develop this through practice, through working with a large amount of data with a different number of problems. When you work through it, you develop analytical skills on your own and nothing else. Other than that, there is another very, very important factor, which is with respect to the communication skills. So a lot of people who are working as data analysts are working for some stakeholders, right? So the stakeholders don't understand these facts and figures. If I just bring to you that these are the numbers which we have and this is what is going on, that does not paint you the whole picture. Even the plotting of the graph might not tell you the whole picture, because they do not understand what kind of statistical approach you have applied to gain that graph, correct? So in order to make them understand, you need to tell them what kind of analytics that you performed and what is the results which are coming out of that. And that can be only done through communication skills. So as a data analyst, you will be performing those analytics on the data set, but you will have to communicate that to the end users, to the stakeholders, so that they can work on solving those complex problems based on the suggestions that you give them. Moving along, then there is critical thinking. So data analyst must look at numbers, trends. They gain this knack. So every experienced data analyst has this knack of working with data. So they just look at these numbers and they have this intuition about it, about how the things are going to work. And communication skills further help a team in having that critical thinking, because a team has this set of very bright individuals who have different ideas, and communicating across the board about these particular ideas that you have can bring out the best idea to the point where you can gain bring more efficiency to your team and bring out better insights for your team and your company. So that is where that comes into the picture. And it's basically an art. So basically, if you think about it, data analysts are performing an art at the end of the day. They are making this beautiful graphs, beautiful pie charts, beautiful pictures, which are telling people what is going on with respect to their company, with respect to their product, or for that matter, with respect to their servers, CPU, whatnot. So this is basically a work of art that they do. So let me share with you real quickly. So there is this one job for Uber. As you can see here, it is mentioned that they must have excellent analytical skills, that you must be able to connect the dot between the data and the operations and get that intuition that you had. You need to have that intuition about what the data is telling you. So it's not just about that. So it is very important to have a very good analytical thinking, and it is something that you can develop with being exposed to data analytics again and again and again and again, because once you get a zest of it, you develop that knack upon yourself where you can solve the problems on your own. Other than that, Uber demands that you must have excellent knowledge of Excel and general programming languages and coding skills. So general programming languages and coding skills here mean R and Python, which we discussed, and Excel skills are very important. As I mentioned before, Excel, if you are looking to become a data analyst, it is something that you must know. It is very, very, very important. Other than that, a data analyst is expected to learn data visualization as well, because it's you who understands the statistics, but you have to show the end users or the stakeholders or even different members of the different teams. You have to tell them about what the data is telling you, and you can do that through graphs, and that is done through data visualization. So having an experience with data visualization is something which is required at Uber. Other than that, basic understanding of statistical techniques and the ability to solve problems and employ business solutions to it is something which Uber demands. So again, everything that we have covered so far is the demand of Uber. Let's look at the another job description at Disney. So we are looking at, again, Python and R. So programming languages and statistical programming language is important. So Python and R is there itself. Then familiarity with data exploration as well as data visualization tools like Tableau and Power BI. So as we mentioned before, data visualization is basically for your stakeholders and end users. Every data analyst is expected to have some knowledge with respect to the visualization tools. And then there is understanding of statistics and strong communication skills, as well as written, which will contain both written, verbal, and presentational skills, because a data analyst has to work with a team of a lot of different people. He has to communicate across the board to various different people, and they need to understand what the data is telling them so that they can implement the measures or go ahead and solve that problem based on the insight that you have provided. So that is what basically this job description is all about, and this is something that we've covered across this session so far. Moving along, so what is a path to learning data analyst? So how do you become a data analyst? The thing is very simple. So you need to start with understanding the basic W's of what, why, when, and how. These are the things which you need to understand. Basic terminologies inside of data analytics and different things of data analytics you need to understand before starting off with data analytics all alone. So basic W's of data analytics as to why you are solving that problem, how you can solve that problem, different things, is something that you start with. Then once you have the understanding of that, you move along and understand the different basic mathematics and statistics behind these data analytics models and different techniques which are out there. So understanding statistics is something that you do next, because moving further, you will be applying those statistical models to the data set, right? So you understand what the data is and different basics of data sets, and then you understand statistics. Then a logical next step would be applying that statistics to your data set, right? So that will be data processing techniques. So how do you apply different statistical models and different sets to those particular data sets is something that you understand. So data processing techniques is something that you have to learn, and you have to understand. To do that, you need to have the knowledge of how databases work. So you need to understand database technologies. And finally, when you have applied all that statistics on that particular data set, so you pull the data from some point, you apply your statistical models to it, and then you visualize that data towards the end. So using R and Python, you get some insights, and then you plot the data in some form so that it is accessible for the end users to understand what is actually going on.
Coming to the first question on these top data analysis interview questions, it is, what are the key differences between data analysis and data mining? Well, data analysis involves the procedure of actually cleaning the data, organizing the data, first procuring it before doing all of these, and of course at the end of it driving meaningful insights out of it. But data mining is a very different concept, because in data mining we are very much concerned about finding patterns in the data, finding hidden patterns, and to see how better we can use these hidden patterns to drive insights. Well, data analysis can also be compared to data mining up to one certain extent, but then the procedures that goes into working of data mining is pretty different. Now, data analysis is actually used to produce results which will have a larger impact on the audience, let's say in general, when you directly compare it to data mining. So these two, form to be very vital differences that lie in between data analysis and data mining. Coming to question number 2, it says, what is data validation? Well, data validation is the actual process where we try to see if the data is valid or not, as simple as that. It's not just that, when we're thinking about data and its accuracy, we want to find out if the data is actually accurate and if the data is actually of a high quality as well. First, see if it's coming from a valid source. Second, see how accurate it is. Third, see what the quality of the data is. So to go on to do these, there are multiple processes where, we use to actually go on to perform data validation. Two of the very important processes are data screening and data verification. Data screening involves making use of a lot of models to make sure that our data can be verified in a way that it is accurate, and to make sure that there are no redundancies, no repeatances, or nothing in the data that will harm the models, let's say. And then we have data verification. What happens in data verification is that, if let's say there is a scenario of redundancy. Now, if there is a redundancy, what we try to do is we try to see if we can evaluate using multiple steps, and to see if the presence or the absence of that particular item in the entire data set is required or not. If it's required, we keep it. If it's not required, it gets removed. As simple as that. So first, screening the data and then, performing data validations are a couple of processes that have a huge impact in data validation. Coming to question number 3, it states, what is data analysis in brief? Well, it says in brief, so make sure you do not get carried away with your answer. Data analysis is actually a very structured process where we work with data continuously to perform activities such as data ingestion, data pre-processing, data cleaning, data transformation, data visualization, and eventually we drive insights out of these analytics result or the visualizations themselves. So why is this done? We do it to make sure we can drive revenue or analyze any of the key performance indications of a business. So to begin with, data is collected from multiple sources, right? It can be an on-site server, it can be an off-premise server, a cloud storage network, or wherever it is. Once the data source is grabbed, we have to make sure that we bring in the data into the company architecture. And once this is done, we'll understand that the data is a raw entity, so it needs to be cleaned, it needs to be processed. If there's any missing values, it has to be filled. If there's any entities that's repeating, or if it is out of scope, we need to remove it. So after pre-processing, what we'll do is we'll use a couple of models to drive analytics out of it to see that we can create very good reports and to make sure that the data output is converted to a format which is understandable by a technical audience and an equivalent non-technical audience as well. Because at the end of the day, a data analysis result can be viewed mostly by board members, stakeholders, and you will basically be explaining this to a non-technical audience. So in that particular case, all of these steps are paramount. Coming to question number 4, it states, how do you know if a data model is performing well or not? Well, this question is very subjective, as you can already tell, because there are many things that involves to check if a data model is performing very well or not. So to find out and assess the accuracy of a data model, we can use a couple of steps. The thing we can do is, a very good design model, as you might already know, will give you very good predictability, right? So you can understand if this is the input, that can be the output, and it will keep doing that on a basis where it will offer you good predictability. That is one. Second thing is that a good model will make sure that no matter what changes you make to the data or what changes you make to the pipeline, the results can be obtained without having to make major changes in the model itself. That is what defines a good model. And then of course, your model needs to have the ability to scale against data in a way where, with one requirement, you might be working with a small amount of data. You might have another requirement where you're working with a huge amount of data as well. So your model needs to cope up. That's point number 3. Point number 4, when you're talking about this, is to make sure that your model's working itself should be easy, right? If it's complicated for you as a data analyst to use, it literally wouldn't make sense to spend a lot of time and effort into it. So having it easily understood among clients and data analysts equally will make sure that both the requirement specification from the client and the performance of the data analyst working with the model will be as high as possible to get the results. So these are some of the points that you have to keep in mind to check if a data model is performing well or not. Coming to question number 5, it says explain data cleaning in brief. One thing you have to know about this question is that it can also be stated as explain data wrangling in brief. So because data cleaning is also called as data wrangling, and as the name suggests, whenever we talk about data cleaning, we try to find ways where we can clean the data, take it from its raw entity into usable information, right? Our end goal is to basically have data with the utmost quality possible. So how do we do it? First, we'll try to see if we can clean the data by removing all the stuff we do not require, right? We call it outliers, but then to remove it, we need to understand what do we need to remove. Do we need to remove one particular row, one column? Do you need to remove the entire data block or what? The second thing is, it's not just about removal, it's about adding certain stuff back in as well. So we can fill certain data in without having to cause any other redundancies or to obstruct anything else in model performance as well. So we remove the data, we can add the data, and in fact we replace the data with mean or median values as well. Again, this is a very important statistical concept that we'll be discussing in the next couple of questions. But then yes, you can replace existing data with the mean or median values of the data itself, and that in fact makes models very much accurate in a couple of cases. And the last thing is that we'll make use of concepts called as placeholders, which are used for all the empty spaces in the data too. So these are some of the 4 very important steps or procedure that's involved in data cleaning. So after understanding data cleaning, here's question number 6. What are some of the problems that a working data analyst might encounter? Well, there are many issues that a data analyst might face when you're working with data, right? Because data itself is an ocean. So working with the ocean is not easy. So the one very important thing we talk about this is the accuracy of the model, right? If there are any issues that causes the biggest problem is going to be the accuracy in model development, and if it is low, it will cause a lot of errors, a lot of mistakes, where at the end of the day performance will fall. The second thing is that the source of the data, if it is not a verified source, it means that your data will be very, very raw and very shabby. This means that it will require a lot of cleaning, a lot of pre-processing even before the analysis has begun. This will take a lot of time and effort as well. And the third thing is, whenever you're extracting data from multiple sources, or let's say, you're merging data from multiple sources, right? So this will cause again a lot of redundancies with respect to data, and it is very, very vital that these redundancies are taken care of. So when you're thinking about all these steps, right, it is very vital they go hand in hand, because if you miss one of these steps with data ingestion or data cleaning, the rest of your model will come tumbling down. So these are some of the major problems that the data analysts face in a production environment. Moving on to question number 7, it states, what is data profiling? Well, data profiling, as the name suggests, is a methodology that we make use of to make sure that we have the right steps in place to analyze all of the entries that are present in our data. So it's not just taking a quick overview of what data is present, but rather taking an in-depth look. So what we're trying to do with data profiling is to make sure that we have the ability to see the data in a very high accuracy way, and to make sure that we understand the data better, right? So what are the data types of the data that is present? What's the frequency of occurrence? And a lot of other things as well. So when you're thinking about all of this, it's very, very important that we profile the data. So with this, we can check out question number 8. Question number 8 asks, what are the scenarios that could cause a model to be retrained? One very important thing about data that you have to know is that data is never a stagnant entity, right? Data keeps changing as business changes. So whenever there's an expansion in the business, it means that, there's a day and night difference in the data that the company starts seeing. So what this does is a huge challenge to data analysts, because here we have to analyze if the model itself needs to be retrained or not to work with the new data. If yes, then yes, the model will be retrained, the new data will be shown, the model will be trained, business protocols will be changing, whatever the model sees will change, and of course the output can change drastically as well. So considering all of this, we have one general rule of thumb that we make sure is that whenever we have the models that are retrained, right, we try to align it as much as possible to the new business protocols and whatever is being offered as well. So this, and it is very vital to understand the scenarios that happen to cause a model to be retrained as well. Coming to question number 9, it states, what are the prerequisites to become a data analyst? Well, there are many skills that's actually required to be a data analyst, and I'm sure you guys will know most of these skills if you're here at this video, right? So you'll require programming skills such as JavaScript, ETL, and XML. You need high proficiency with working with databases, especially like MySQL, MongoDB, Oracle SQL, and more. And you need to have the ability, the passion, and the interest to collect and eventually analyze data. You'll need to figure out how to design databases on your own, and how to perform data wrangling and data mining as well. And once you know how you can go about working with data, what comes next is you having the ability or the experience itself to work with a large amount of data sets in a production environment. This is very, very, very important, and all of these skills are the major prerequisites, let's say, for you guys to become budding data analysts. Well, coming to question number 10, it states, what are the top tools used to perform data analysis? Well, as you might already know, there is multiple tools that can be used in the field of data analysis, right? But then there are really popular ones that get a lot of attention. And these are, Google search operators, also called as GSO. We have RapidMiner, we have Tableau, we have Kineem, we have OpenRefine. We have a lot of these other tools which take the center stage as and when we talk about data analysis. So it's very important that you know these tools. Question number 11. It says, what is an outlier? Well, an outlier is basically a value in a dataset that we consider to be very much away from the mean of the data, because in two ways it will hurt the data, because an outlier can cause model accuracy to fall a lot, and of course at the end of the day, if it's outside whatever we call the normal zone or the useful zone in the data, or the inliers, right, what it does is it is redundant, right? So when you're thinking about small amounts of data, it's probably okay, but then when you have large data sets, if it can swing the model accuracy around, big no. The second thing is storage as well. Storage is not really cheap, and when you're thinking about all of these, it's very vital to know what outlier is and how to remove them as well. But then there are two types of outliers you have to know about. One is univariate outliers, and there's multivariate outliers, and they speak, the names speak for themselves as well, right? Well, So moving on to question number 12, it states, how can we deal with problems that arise when the data flows in from a variety of sources? Well, when your data is coming from a variety of sources, it will come with a variety of problems because data is really shabby, as we've been discussing, and it is very important to handle these as well. So to go on to solve these problems, what we try to do is we try to see if the data is same or if the data is similar. Which might cause redundancy, and if it is similar, of course, we can merge it into a single record and reduce the redundancy. We can restructure the entire schema where we are trying to make sure there's good schema integration with the data, and at the end of it, no matter how much cleaning you do, no matter how much pre-processing you do, and how much time you take to do all of these, there will be an entry in a large data set, or there'll be a couple of entries, in fact, that will be hurting model accuracy if you're not careful. So these are some of the problems that arise and how we can deal with them as well. Coming to question number 13, it says, what are some of the popular tools that are used in big data? There's many tools in big data, and again there are some of these tools which come to the back of the head as soon as we think about big data. So a couple of these tools are Hadoop, we have Spark, we have Scala, we have Hive, we have Flume, Mahout, and as you can see, there's a pattern that exists, right? All of these tools are by Apache. Apache is an open source foundation, and they've been contributing a lot to the world of big data, and it is very important that either you have the experience using these tools or you know what each of these tools do as well. That brings us to the 14th question that states, what is the use of a pivot table? Pivot table, as you might know, as you might have heard it or used it, is one of the most important concepts that exists, in fact, in Microsoft Excel, in my opinion. Because they will give you a very easy to use way where you can view and summarize large data sets without having to put much effort into them. So, most of the operations that we do with pivot tables actually are drag and drop operations, and it really does not require any sort of coding or any sort of programming, or really any sort of, let's say a hard amount of effort is not required to create reports and to make them look beautiful itself as well. So in all of these usages, pivot tables are very important, and I'm sure if you're at this video, you guys might have used pivot tables yourselves as well. So coming to question number 15, it states, explain the KNN imputation method in brief. KNN is K nearest neighbors, and it's one of the most important methods that we use to see how we can pick up the nearest neighbors in a nodal arrangement and to see how we can measure the distance metric between each as well. So what we're trying to do here with a KNN imputation is that we try to predict both discrete and continuous attributes that happen to be present in a data set. With this, how can we do it? Well, a distance function is exactly what we use here to find if two data, two nodes or two neighbors are similar or not. If there are similars in more than one attribute, then we're going to use that to perform analysis as well. So to go on to do this in a very structured way, we use a method, and that method itself is called as the KNN imputation method. Moving on to question number 16, it says, what are the top Apache frameworks used in a distributed computing environment, right? So we're living in a world of distributed computing where we can make use of the computing power offered by thousands, if not millions of computers across the globe at a time, right? So when you're sitting with that kind of a power, there are two tools which always come to center stage. This is MapReduce and Hadoop, because these are the top Apache frameworks which are in the limelight, which can handle large amounts of data set very easily. And if it's in a distributed working environment, there are a very less number of tools that get to outshine what MapReduce and Hadoop does. So these are the top Apache frameworks. Coming to question number 17, it states, what is hierarchical clustering? Hierarchical clustering can be, this question can be asked to you in another way. What is HCA? HCA is basically hierarchical cluster analysis, or it can be called as hierarchical clustering as well. So it's basically an algorithm that we use to make sure we can find the easiest ways where we can group similar objects. So once we group this similar object, each group itself will be called as the cluster, and hence the name. So why do we require hierarchical clustering? Well, we require hierarchical clustering because we need to create a set of clusters to show that this data differs from another cluster itself, be it individually, be it cluster wise, or even if they consist of similar entities as well. So to show the difference that exists in between data, we make use of hierarchical clustering. Moving to question number 18, it says, what are the steps that are involved when working with a data analysis project? Well, again, this question can be answered in multiple ways, but then the foundational concept is the same. So, there are many steps that are involved when you're working on an end-to-end project, especially in the world of data analysis. You'll begin by finding out there is a problem existing, or you'll have a client bring you a problem statement. Once you understand the problem, you'll source the data. Once you get the data, you'll clean it, you'll pre-process it, and you'll explore it to see what the data actually is. Once you understand the data, you will start creating data models, and you'll create situations where you'll use the data on a smaller scale to see if you can solve a problem in a simple way. Once you do that, you'll validate it across a bigger data set to see if it works on the complete data set. If it does, you implement it. But then it's not just done with the implementation aspect of it. Once you implement it, you need to verify if you have solved the problem or not. And that is the last important step. So based on how much the interviewer is asking you to stress on the answer, make sure to expand on it. Keep it concise. Don't get lost in each of these steps, because I can talk about each of these steps for 20 minutes right now, but then it really wouldn't add a lot of value in an interview scenario, right? So read the room, read the interviewer, understand what he or she is expecting, and deliver the answer in that way. So with this, we come to the 19th question that states, can you name some of the statistical methodologies used by data analysts? Well, again, you can name a lot of methodologies used by data analysts, but try to keep your answer concise, right? So name 4 or maximum 5, in my opinion. That should be very useful. See, we have Markov process, we have cluster analysis, we have imputation method, we have imputation technologies, we have the Bayesian methodologies, we have rank statistics, and we have a lot of other statistical techniques that are very useful. In fact, I can say they are foundational in many cases when you're working in the case of data analysis as well. So for all of these techniques that exist, each of these have their own niche purposes, and they're very effective at doing what they state. So when you ask this question, make sure to mention this. Coming to the next question, which is the 20th question, it states, what is time series analysis, or also called as TSA for short? Well, time series analysis is used to perform, trend analytics. We try to see how the data changes with respect to time. And it's not just how the data changes with time. Here, what we're trying to analyze is for a fact that the presence of data at particular intervals of time, and seeing the presence of data and its response and its behavior of how actually it drives the data set. So if you have a data that does this at this point of time, and you want to understand why it does that, or you want to understand what it does because of it changing its state or changing its data at that particular point in time, then TSA is very effective to use. So moving on to the 21st question, it's actually a follow-up to the 20th question. It states, where is TSA used, right? So TSA has a lot of usage when you think about it in a lot of different domains. So make sure to at least mention 3 or 4, but then I have given you more out here so that it'll help you remember, right? So TSA is used in statistics, in the field of signal processing, econometrics, weather forecasting, earthquake prediction, astronomy, and even applied sciences as well. There's a very good chance the interviewer will not ask you how it is used, but probably give you a situation and ask you to think about it and tell if you can provide a solution there as well. But then these are some of the most important places where time series analysis adds a lot of value. So when you ask this question, make sure to mention this. Moving to question number 22, it states, what are some of the properties of clustering algorithms, right? Well, clustering algorithm, whenever you have it implemented, will have a lot of properties, but then these are the main ones. So you have the flat or the hierarchical property, it can be iterative, it's going to be disjunctive, and a lot more. So when you're thinking about clustering algorithms, do talk about how these foundational concepts of it being flat or hierarchical, it being iterative to make sure that you arrive at the solution, or it being disjunctive, which definitely defines how clustering algorithms work effectively to split out data into clusters and make use of it as well. Coming on to question number 23, it states, what is collaborative filtering? Well, collaborative filtering is a very important concept. It's an algorithm which is widely used in the field of data analytics to create recommendation systems. So recommendation systems is used to understand the behavioral data of a customer, or in fact to understand what the data is doing and why it is doing something the way it is doing as well. So when you can think about it, when you're shopping on an e-commerce site, maybe like Amazon or Flipkart or something, you will be shown recommendations, right? So users who bought this also bought this. So when you think about that, that's a recommendation given to you. And in fact, collaborative filtering is used just for this purpose as well. So it'll be using a lot of data. It'll be using cookies data, browser history, and there are very complex methodologies, there are very complex models and algorithms put into place to recommend the best products out to you. And the working of that is achieved through collaborative filtering. Coming to question number 24, it says, what are the types of hypothesis testing used today? There's three main types of hypothesis testing which gets the center stage again, right? So in fact, there's many types of hypothesis testing, but these are the important ones. The first will always be ANOVA, or what we call as analysis of variance, because here we try to perform analysis in between the mean values of multiple groups to see how data is changing. The second thing we call as the t-test. The t-test is actually used wherever standard deviation is unknown to us, and let's say the sample size is pretty less as well. Again, we'll have another question discussing about t-test. And the next thing is the chi-square test, or also called as the chi-square test. You can pronounce it both ways. So what we do with the chi-square test is that we try to use hypothesis testing here to find if there is a requirement, find what's the association of the categorical variables in a sample, and to see how best we can arrive at the goal of our model as well. So when you're thinking about hypothesis testing, make sure to talk about 3 or let's say even 4 types of testing, and quickly briefly talk about what they do as well. Coming to question number 25, it says, what are some of the data validation methodologies used in data analysis? Well, there's many data validation techniques as we've been discussing for a while now, and these 4 are very important. The first thing is field level validation. Field level validation is we try to validate every single field where data is present to make sure that there is no errors, let's say because a user might have entered it wrong, and any other redundancy which would have caused the wrong data to be in the wrong place as well. So form level validation is done when the user works with the form, but then before saving the information, if there's any changes that's been made, we need to keep a track of that as well. And then we have data saving validation. Data saving validation will take place when the file, let's say, or even the database record is being saved as well. So whenever it's being saved, there's a change of state. To analyze that, we perform this validation. And then we have the search criteria validation. Here we're trying to see if the valid results can be returned or not whenever the user asks for it, or whenever the user is going through the data set, summarizing it, or even driving results out of it as well. So these are some of the very important data validation methodologies that are widely used by data analysts across the globe. Coming to question number 26, it states, what is k-means algorithm? K-means algorithm is a very popular algorithm that we use to cluster data into multiple data sets, or in fact cluster data into multiple clusters as well. So each of these clusters will consist of similar data, and the name k-means comes from k actually being the number of clusters that we required. If k is equal to 5, it means that our k-means algorithm is going to divide the data set into 5 different clusters. So to use this, you will require a good amount of experience. It's very simple to use though, but then to achieve really effective results, it requires experience to work with k-means, and of course to know how many clusters you want. And since you'll be working with the data which is unsupervised in nature, you will not have any sort of labels that guide and show what the data is as well. So working with k-means can get finicky at times, but then it's really fun and it's really effective too. Coming to question number 27, it states, what is the difference between the concepts of recall and true positive rate? Well, this is a very tricky question. I'll tell you why, because recall and true positive rates are literally the same thing. So recall and true positive rates are exactly the same. And whenever we try to think about the formula of either recall or true positive rate, right, it's basically true positive divided by the true positive value and the probability of the false negative value too. So it's TP divided by TP plus FN. It's the actual formula for recall, and it's a very simple question with a very straightforward answer. Coming to question number 28, it says, what are the ideal situations in which a t-test or a z-test can be used? We have one very simple practice that we follow that's become standardized in fact right now. A t-test will be used if your sample size is less than 30, and a z-test will be used if your sample size exceeds 30 in many cases. So a pretty neat trick to remember this is that t is less than z, so t can be used whenever you use a sample size less than 30. Z is at the end of the alphabet spectrum, and it means that your data is exceeding certain cases, right? So that's a pretty simple way in case if you have not had any experiences working with z-test and the t-test as well. Coming to the 29th question, it states, why is naive bias called as naive? Well, whenever we think about naive bias, right, we don't know why it might be called naive, because this is a very tricky question. It gets asked a lot just to see if you actually know the answer or not. Well, it's called naive because it actually makes the general assumptions that everything present in your data is important and it is independent of each other. Thinking this always as a human being, it can be naive because your data is different. It is sometimes dependent on each other. It will not always be independent. Not all the data is important as well, right? So to know all of this, your model will not understand that. It will just say everything is important and everything is independent. So this is not true. It will not hold in a real world scenario, and that is the reason we call naive bias as naive bias. Coming to the 30th question, it states, what is the simple difference between standardized and unstandardized coefficients? As the name suggests, whenever we talk about standardized coefficients, we're trying to interpret all the results based on the standard deviation values. When it's unstandardized, it means that we're trying to use the actual value of the data rather than the standard deviation results. So if you're considering the standard deviation values, it's the standardized coefficients. If you're considering the actual data that is present and not the standard deviation value, then it's unstandardized. Pretty simple question, pretty straightforward answer. Coming to the 31st question, it says, how are outliers detected, right? There are many methodologies that we make use of whenever we're detecting outliers. It is very important to remove them in most of the cases. But then, out of all these methods that exist, we have two very important methods. One's the standard deviation method. The other one is the box plot method. In the standard deviation method, what we try to do is the value itself will actually be considered as an outlier if the value is either lower or higher than 3 standard deviations from the mean value. So we'll find the mean value, you'll get to know the standard deviation. If the value is 3 times higher or lower than the standard deviation value, it means that it deviates too much from the data and that it is an outlier. And then we have the box plot model. Box plot model is the most popular way of how you can find out outliers, because here we try to find the interquartile range, or what we call as the IQR. And if your data is to be considered as an outlier, it means it has to be either 1.5 times more or 1.5 times less than the mean in the interquartile range. If that's the case, then of course your data is considered as an outlier. Coming to question number 32, which states, why is KNN preferred when determining missing numbers in data? KNN, as we've already discussed, it's called K nearest neighbors algorithm. It's a very famous one that's used a lot, and we now know why it's called that. But why is it used when you're determining missing numbers? It's because it has the capability to approximate a value based on other values that are present very close to it as well. It can easily approximate these values, and hence it finds a very important place in the world of determining missing numbers present in our data as well. So coming to question number 33, it states, how can one handle suspicious or missing data in a dataset while performing analysis? You can think about this in a lot of ways, because when you're thinking about any sort of data, there will be discrepancies in it. So to handle all of these, what we try to do is we create validation reports where we discuss the data in detail to make sure that most of it is right at least. And then we escalate the data or this is suspicion to our superiors or experienced data analysts to have a look at it and then take a call about it. So we try to replace the data which might be old and invalid as well. We try to make it valid. We try to put in the latest up-to-date data to see if it fixes it, and we can go on to use the many strategies that we have in the world of data analysis to find the missing values, use approximation, to put in the values to see what fits best to perform analysis, trial and error, and whatever is required to handle, either missing data or suspicious data as well. Coming to the 34th question, it states, what is the simple difference between PCA and FA? PCA stands for Principal Component Analysis and FA stands for Factor Analysis. Among all the many differences that lie in between them, one major difference between principal component analysis and the factor analysis is the fact that factor analysis is actually used to specify and work with variance that exists in between the variables, right? So whenever we're working with the major difference, what we're trying to do with PCA is we're trying to use the variance that exists in between variables, but then with PCA, it's a little different. With PCA, what we try to do is we try to explain the covariance that exists between the components. So factor analysis deals with variance, principal component analysis deals with covariance. This is probably the biggest difference that lies in between principal component analysis and factor analysis. Now moving on to the 35th question, it says, how is it beneficial to make use of version controlling? Version controlling is very important, and it provides you a lot of advantages, right? One thing is that it will give you a structured pipeline where you can compare all the files, identify a lot of differences, merge if any changes are done in a very structured and a convenient way where you can track it as well. Because here you can track the life cycle of any sort of application building with every stage of its build, be it development, be it production, be it testing, be it verification. You can actually track all of these too. And then when you're thinking about how it will bring together a good way to establish let's say a collaborative work culture in the company, then yes, a version controlling system will do just that. And then when you're thinking about making sure that with every release of your version, the security of your code, the safety of it, the variety of it, and the veracity of it as well, right? So to keep it secure, keep it safe, a version controlling system will definitely help. Coming to the 36th question, it states, what are the future trends in data analysis? Well, if you ask this question, what the interviewer here is trying to do is he or she is trying to assess your grip on the subject and how much research have you actually done into the future of data analysis, right? So to answer this, make sure you can state good number of facts and respective validation for those facts, of course, for all the sources that you have used. To add a lot of positivity to your candidature, because at the end of the day, they're trying to understand how in depth experience you might have in data analysis, or how in depth of a passion do you have for data analysis as well. Try to explain how data analysis will have a huge impact on businesses today. In fact, talk about how it is already revolutionizing the world around us, how it will revolutionize the future trends as well, and how it is showing nothing but immense potential too. If you have facts, if you have statistics, if you have experience, if you have to talk about new tools, new techniques, new ways that data analysis will help, please do talk about all of these. Coming to question number 37, it states, why are you applying for the data analyst role in our company? Well, with this question, the interviewer wants you to convince them basically regarding why you think you are proficient in the subject, how well can you handle data analysis, how well can you work in a production environment, how best can you be fit as a team player, all of these things as well. So to answer this in a very, very, nice way, first thing you have to do is you need to know the job description in detail. You need to know what they're expecting of you to see if you can deliver that or not. Because once you understand the details of what the company does, what the job description is, what your team does, where you will be fit into the organization, you will of course find the best way to understand why you need to do it. You might have a passion for data analyst, you might have a genuine interest to build your career there. Let's say you have a very keen interest on working with data and to solve problems using that too. Well then, you can have multiple reasons, and there is no one answer for all the questions here. So this question completely depends on you, but then you can use this as a guide to go on to answer it. Coming to the 38th question, it states, can you rate yourself on a scale of 1 to 10 depending on your proficiency in data analysis? This is another question the interviewer will usually ask to see how confident you are when you're sitting at the interview, how much you know about the subject, and how spontaneous can you be whenever you ask questions, right? So one very important thing that you need to understand here is that answer it honestly. Do not be over optimistic, right? So if you think you on a scale of 1 to 10 you are at a 7, please make sure not to say 9, 9.5 or 10, because if you're answering it that way, then you might be asked very, very difficult questions or advanced questions which might be over the scope of your expertise, which might put the wrong image into the interviewer's head, and you might lose out on the candidature as well. So to be as honest as possible, talk about what you've done and talk about why you rate yourself at that particular scale as well. Coming to question number 39, it states, has your college degree helped you with data analysis anyway? Well, talk about the latest program that you completed in college, right? So you firstly start your answer with this. Talk about if your college actually helped you with data analysis anyway. Don't say no if you haven't had any experiences there, because see, if you are in fact enrolled in a college degree, you will have access to a lot of data that in fact you could have used to perform data analysis as well. So talk about if you've been keen to do it, if you have done anything to the data, anything with respect to data analysis in the past, or let's say if you have not done any of these, right? Talk about the experience that the entire college degree program gave you and how you think it built you in a way where you can be a good fit into data analysis, into the entire field and the organization that you're applying as well. So talk about how it molded you into being the data analyst enthusiast that you are today. Coming to the 40th question, it states, what is your plan after joining for this data analyst role? So again, do not be carried away by this question. It is very, very easy to get carried away here, and you can talk about it for a lot of minutes. But then keep it as concise as possible. This is my advice to you, because you can talk about a lot of things here, but start out with talking about a plan. on how you can begin understanding the data analysis structure set that is already set up in the company, how you think you will be a good fit there, how you plan on either seeing if the actual existing model might need some betterment or not. But at the end of the day, don't just say that you're gonna barge in and do a lot of changes in a short amount of time. Keep your answer structured. Keep your answer thinking in consideration that you'll be going into a production environment, and it's always vital if you can highlight how better you can make the product, the company, the brand, or whatever it is, with you being there as well. So talk about the expertise that you bring to the table and how you think that might help the organization too. Coming to the 41st question, it states, what are the disadvantages of data analytics? So even though the advantages are huge, right? There are one or two disadvantages that you will have to talk about. And if you do not know this, and it is very important that you know this as well, right? See, data analytics can actually cause a breach into the customer privacy and all of their information as well, right? So it's very vital to know where you're getting the data from. You might be thinking about customer transactions, purchases, subscriptions, and you will have a lot of access into what this customer is doing as well. In that particular case, make sure that you do not cause any sort of breaches in customer privacy. And then when you're thinking about another very important disadvantage as a learner is that some of these tools are really complex to use and you will require training to go on to use it as well. So it's not as easy as you download the tool, install it, and begin working with it. You will require a good amount of structured training and to work with it efficiently as well. And one of the other things is that it'll take a lot of skill, it'll take a lot of expertise, it'll take a lot of hands-on experience to go on to select the right tool itself. First of all, to find the right tool, to use it and to use it effectively, it's going to take a lot of time, it's going to take some money, and of course it's going to take the biggest asset of the company is the client's time too. So in that particular case, even though these are not huge disadvantages, the privacy thing is definitely one disadvantage to consider. Complexity of the tools are important, and of course the requirement for a lot of skills can get overwhelming for beginners as well. So as an add-up question to that, you might be asked, what skills should a successful data analyst possess? Well, this is basically a descriptive question because here the interviewer wants to understand how your analytical skills are and how your thinking skills are, right? See, there are many tools and skills that a data analyst must have. Think about programming languages, right? You'll require expertise in Python, you'll require expertise in R, SAS, concepts of probability, details of statistics, regression, correlation, and many other skills that a good data analyst should possess. How much of experience should he or she possess? Well, that depends on how long this person has been into data analysis, right? But then it is vital that you know what skills are required. What skills are used by professional data analysts. You might have some experts or let's say famous data analysts out there that you might be looking up to. So it's very vital you to understand all of that and answer this question in an effective way as well. Coming to the 43rd question, it states, why do you think that you are the right fit for this data analyst role? Again, if you're being asked this question, it means that the interviewer wants to understand if you are the right fit for the job description, number one. Number two, why do you think data analysis is for you? And number three, what knowledge do you have in data analysis to actually fit into their organization well? So one thing again, a very important note is that do not get carried away because you can answer this for 20-25 minutes straight, but keep it very small, keep it concise, keep it detailed, and just talk about your passion, talk about your interest, talk about your goals and how much these goals and passions will match the company's substructure and their goals as well. See, every company will have a vision and a mission, and if you can commit to the vision and the mission of that company and better either better the product that they deliver or better the brand itself, then of course you will be the right fit for the table, right? So taking a product from one place into another place which is definitely better, and you can prove it with numbers in the case of data analysis, it is very important you know how you are the right fit for the role as well. Question number 44. It says, can you please talk about your past data analysis work? Well, you might be asked this even though you're a fresher. You might be asked this even if you're an experienced candidate as well. If you are a fresher, then do talk about how you've either figured out there are problems that exist in the world of data analytics. So if you're a fresher, do talk about how you might have performed very simple analytics as well, right? So think about how many people could have how many guests that come into your place. Find a structured way on calculating that and why you think that's the case. Talk about how many people buy a certain product in your supermarket. There can be many things that you might not have officially done on paper, but your brain would have analyzed it, right? Talk about that. But then if you actually have a certification program, you would have worked on, in fact, a good certification program, you would have worked on a lot of industry level projects as well, use cases too. Talk about that. And of course, if you're an experienced person attending a data analysis interview, talk about your previous company, talk about what you did to the company, what value you added, what problems you solved, and how better was the team when you left, compared to when you were joining as well, right? So talk about a lot of these insights, talk about your debating skills, talk about how you can think out of the box, how good you are with your statistical skills, and of course, how much of a team player you were in the past, and how that has continued as well. So let's talk about a behavioral question now. Question number 45 states, can you please explain how would you estimate the number of visitors to the Taj Mahal in November of 2019? Well, this question does not expect you to say the exact number of what number of visitors Taj Mahal got in November 2019, but then here people are trying to see your thought process without you making use of a data set, without you making use of a computer, to see how you would approach the problem, right? So here's a very good template that you can use. First, you would begin by gathering some data, right? So to do that, you will have to understand a lot of things. You will need to know the population of Agra, where the Taj Mahal is located, how people can move in and out of Agra, how convenient is it, and a lot more. The next thing you'll be looking at is the number of tourists that come to Agra, right? And how popular is Taj Mahal itself in Agra. So with all of these, you will find the average stay of these tourists that come. You can analyze it in detail. For example, the age of the people who come, the gender, the annual income that they have, the number of vacation days that they take, the number of bank holidays that exist in India, and all of that. The number of days Taj Mahal is closed, the number of days it's open, the number of days it records the highest number of visits, and all of these. Once you have gathered all of these data, you will go on to perform statistical analysis on it to understand how many visitors it has got as well. And if you want to perform even advanced analysis, you can go to the local tourist offices to gather all sorts of data, process it on your own, and eventually use it to verify if your model is right or not as well. So this is a classic behavioral question, and it's not just the Taj Mahal, it's not just the date. This question can be asked in many different ways. For example, how many cars were sold in India in, let's say, the last month or the last year as well. So that's another very common question that's asked. And whenever you ask this, make sure to take this kind of an approach, use the template, and think about it for a second. Take 1 or 2 minutes to think about it. There is no hurry when you're answering this question. Coming to question number 46, it says, do you have any experience working in the same industry as ours before? Well, as you might already know it, a data analyst will fit into a lot of domains, right? Even in the field of medicine, even in the field of social media, be it whatever it is. A data analyst is required if there's a business, as simple as that. So if you've worked in the same industry as the company that you're applying for now, do talk about how you've used your skills to polish yourself into that industry and how best you brought yourself out of it. If you do not have worked in the same experiences, don't just say no. Talk about what you think are the skills that are needed for this industry and how you're working on yourself to come to that particular spot as well, right? So it's very important that you talk about how you're building yourself towards working in this industry, your interests, your passions, and if you've had experience, of course, do talk about that and thoroughly explain it. Thoroughly explain all of the skills that you might have used, techniques, tools, and how you've benefited the past company that exists in the same industry as well. Coming to question number 47, it says, how good are you in explaining technical content to a non-technical audience with respect to data analysis? See, your ability to explain a technical content to a non-technical audience has to be one of the most important things that you'll do as a data analyst, because your communication skills are very vital. It's not just delivering technical content, it's your ability to have patience, it's your ability to break complex things into simpler, it is your ability to break up complex things into simpler things where you can explain it to an audience who might be your board members, stakeholders, or some other non-technical audience as well. So if you've had any experiences of situations where you had to explain technical concepts and break it down to a non-technical audience, make sure to talk about that talk about how well versed you are, how effective that you have been in delivering content before as well. So this question again is a question where I cannot give you one answer for each and every one of you, but then you yourself give it a thought for 15-20 minutes and you will get the best way on how you can answer it. Coming to question number 48, it says, what tools do you prefer to use in various phases of development? Again, this is a question that's asked to check what all the tools that you have used, how you have used it, and how best do you think a tool will fit into that particular task as well. So if you have used any or all of the tools that's involved in data analysis, talk about it. Talk about how comfortable you were in using these tools and talk about how they're popular as well. See, some of the tools that we discussed in the questions are very, very popular, right? Talk about how they are popular and why they're popular too. So this will add a lot of value to your candidature. And coming to the 49th question, it says, which step of a data analysis project do you like the most? Well, it's very, very common to have a liking towards one or two tools in the entire process of data analysis, right? See, a data analysis is a vast field. You just cannot have one particular tool where you will do everything with that tool. So you will have multiple tools to do it, and you will have a liking to one particular tool. You might not like the other tools as well, right? So when you're thinking of the entire analytics cycle, it is always vital that you do not talk negatively about any of these tools, because those tools are put into place to do their tasks and they have been doing it well. If you do not like it, well, okay, you do not like it, we understand that, but do talk about what best the tool can do, how it can improve itself to probably, making yourself be inclined towards that, or what are the steps that you think can help make the tools better, in fact, as well. But understand this, when you're answering this question, know that it is okay to have a favorite tool, know that it is okay to, put in more time into one particular tool, because it's your career, it's your interest, it's your liking, and if you think you can be very efficient at using that tool effectively, then be it. It is okay. And then coming to the last question on these top data analyst interview questions and answers set, it states, have you earned any sort of certification to improve your learning and implementation process, right? See, a good certification program, what it does for you, it's going to give you thorough knowledge, in-depth expertise from top trainers across the globe. It's going to give you a certificate. It's going to give you exposure to potential hirers. It's going to do a lot for you. So if you are involved in a very complex program that has the capability to take you from a beginner all the way to an advanced data analyst, it means it's adding a lot of value to your life. But how should you answer this when you ask this in an interview? See, one thing is that if you have a certification, right, it shows the interviewer that you have interest in advancing your career in this particular field. It shows that it shows that you have strong aspiration to learn, because you've put in your time, you've put in efforts, you've put in money, and all of these, and dedicated it to the world of data analysis, right? So if you're doing all of this, it always adds value to the interviewer as well. And then when you're thinking about how effective learning that you've put into place, see, many certification programs will give you all the theoretical knowledge that exists, but only the good ones will give you really good industry level projects and case studies to work with. So if you have had the experience to actually crack these industry level problems, it means that you have the capability to learn things on your own and be a player in a productive environment as well. So that itself is going to portray a lot of value of you being certified in that domain. And now if you have more than one certification, just go on to list the certifications of what you have done as well. But instead of stating a lot about what you have done, the most value that can be added to your application is to state how you have used this certification, right? So you could have learned a lot of things, but if you have not used that, it will not add any value, right? So what problems have you solved? The entire world of IT came into place because we have problems and we realized we can use computers to solve them. So to how best of your capability and potential have you made use of these certification programs to solve problems that are there, or how do you plan to solve them if you haven't done any as well? Talk about how helpful it's been to you, your career, and how much value it added to your life experiences, to your learning and interests towards data analysis as well.
This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts. The course link of which is given in the description below.